Getting coffee ready. That's good.
Yep.
All right. All right. Welcome everyone to the second day of the virtual MLNET community conference here. We're so happy to have you back here. And John, he's just poured up his coffee for the day, which is awesome. We are excited, and coffee will be needed because we have a long day in front of us, right, John?
Yep. I got plenty of coffee ready here, if y'all can see. Should be enough for the day, but
Yeah. I mean,
hopefully.
9 speakers, right?
Oh, yeah.
Yeah. Well, before we get started, let's introduce ourselves again for those who didn't join yesterday. So, John, do you want to start off by telling us who you are and what you do?
Yep. John Wood here. Let's see, been .NET developer mostly for at least 10 years. It's kind of hard to keep track now. Mostly web development. At least that's what I do day to day. And during my off time, I mess with ML.NET.
Cool. That's awesome. So my name is Alexander Slotte. I'm a Microsoft MVP. I'm based out of the East Coast here in Washington, D.C. And I love community speaking, community involvement. I try to do as much as I can and as much as my wife allows me to do. I also stream live on Tuesdays and Saturdays. So if you want to continue learning more about ML.NET, you can join me on Twitch on Saturday mornings at 10, I think, and Tuesday mornings at 10 as well. So that should be awesome. But before we get started, I want to take a moment to thank our sponsors as well, because without their support, a lot of the things that we have managed to pull together today wouldn't really be possible. So we have Excella and we have Vintellect. And John, would you like to say a few words about Vintellect?
Yep. Vintellect is a small consulting and training company, mostly based out of Atlanta. They mostly do web applications and a lot of Azure kind of DevOps and stuff like that as well.
Awesome, yeah. And Excel is a similar company, I think. We are about 300 people, also a small consultancy organization, focused mostly on agile transformations and .NET. And we are based out of the Arlington, Virginia area, but we do consult across the US. So definitely reach out to us if there's anything we can help with, for sure. But some orders of the day here, right, John? What are some things we need to think about during the day here that we shouldn't forget?
Well, at noon Eastern, the Q&A with Microsoft data scientists. But in order to ask your questions for that, we have a Slack channel that anybody can join. And once you join there, there's a channel there where you can ask your questions.
Exactly, yeah. So definitely join the Slack community we have. There should be a link on Twitter, and if that's not available for you, we'll put that in the chat as well, so you can view it. So definitely start asking questions. I already see quite a few questions coming in here, which is going to be awesome. Mm-hmm. Just ask the in-depth questions or something you really wanted to know. And during the day today, we're going to have tons of speakers, and if you have any questions to them, either ask them in the Slack channel, or you can do that in the Twitch stream or in the YouTube stream, and me and John will make sure to moderate them after their talks. There'll be about 45-minute sessions, and then follow with about 5 minutes of Q&A for each of you. So definitely make sure to do that. And a lot of the speakers as well, they will most likely join the Slack discussions afterwards. So if you want to continue your discussions with them there, you can feel free to do so. So that should be awesome. Also, John, we have a feedback channel, right?
Yep, we do have a feedback channel. So if any feedback, good or bad, or anything we can approve for hopefully the next time we have this conference, feel free to put that feedback in the feedback channel.
Yeah, exactly. And we have, I think, people from the Microsoft team in the channel as well, monitor those discussions, and I'm sure they will be happy to kind of interact with you and start a discussion there. So that should be really good.
Yep.
Something else here to think about as well is that throughout the day today, we are going to have interviews with different people. So we're going to have interviews with companies and organizations throughout the US that are doing ML today. I think we have Miha from Romania, we have folks from the US and so forth. So that should be really interesting just to kind of hear their experience with MLNET and how they use it today. So if you want to get some I guess, inspirational thoughts on how you can get started with MLNET today in your organization and how you can use it, definitely make sure you tune in between breaks as well to listen into that. Anything you want to add to that, John?
The interviews are a good way for if you're looking for case studies for using ML.NET in your organization. Those are good ones to look out at.
Exactly. Yeah. Perfect. So, John, how's the day looking otherwise? What kind of talks are we going to be hearing?
Oh man, we got quite a few talks here. I tell you what, one the most excited about is the chatbot talk with Veronica.
Yeah,
Uh,
that should be
it's
that should be a good one, right? As well.
yeah, yeah,
And we have, I guess we're starting off today with Henry Gia here in the morning with some AI ethics. And I think that's the first, well, the only talk, I guess, that's not directly ML that related, but it's more of an overarching topic that's library agnostic, if you will. So that should
yep.
be interesting. What do we have after Henry?
Well, after Henry, we have Jernage talking about machine learning simplified with ML.NET.
Yeah, and he's based in Brisbane, I think, Australia. So he's going to be late in the evening when he calls in. But we're very thankful for his dedication to join us with his talk.
Yeah, I think you said it's what 11:30 p.m. over there now.
Yeah, that's late, but
Yeah.
we're happy to have him to share his expertise.
Hmm.
So after Journey, I think we have Justin, right? So we have a Q&A session with the Microsoft data scientist. And again, definitely put your questions in the chat on that. That should be interesting. And following Justin, what do we have then?
Yep. After that, we have Luis talking about transfer learning for deep learning.
Yeah.
With custom vision and ML.NET. So a bunch of cool deep learning stuff there.
Nice. And that's Justin Beltran, right?
Luis
Oh,
Beltran.
sorry, Luis Beltran. Sorry, Luis. So not Luis from yesterday, but Luis Beltran, another Luis. Cool.
And he's from Mexico, right?
I think so, yes. And I think he's also pursuing a PhD, which is exciting. So I want to hear
Nice.
more about what area he's focusing on there. I think it's informatics of some sort, but that's really exciting to hear more about. And I think he's also a Microsoft MVP, so very well versed in the community.
Yeah.
And then after Luis, I think we have Daniel Costea from Holland, I think, currently, which is he's going to talk about Jupyter notebooks, I believe, right?
Right.
That'll be exciting. And he's a Microsoft MVP and a trainer and done about 1,200 hours of developer training. That's a lot of hours.
Yeah.
But
And then after that, we have Bart talking about decision analysis with ML.NET and Blazor. So that's going to be interesting to show how to mix the ML.NET and the Blazor frameworks together.
absolutely, yeah. I think a lot of questions yesterday were about just Blazor and how we can use that with WASM and all those things. And it's pretty cool to see a demo, I think, on how it will integrate well and how we can work with that. So that should be a really good talk. And Bart, he's working for Microsoft, so he should have some good knowledge on that as well. Should be cool. Should be really cool.
Yeah.
So after Bart, what do we have next here?
The Bard is the one I mentioned earlier with even smarter chatbots with ML.NET.
Okay, perfect. And as we mentioned yesterday, she's famous from Build, right?
Yeah, that's right. She got mentioned in Build.
Yeah, she was
Build
in
famous.
Yeah, Build famous. I mean, that's better than famous from TV, right?
Oh
Famous
yeah.
from Build. Considering that we had 252,000 people registering for Build, I would say you get a pretty good exposure if you're on Build.
Yeah, definitely.
Yeah. So that's going to be really cool. And then after Veronica, we have Praveen calling in from India. He's a cloud architect and I have a community speaker. And I believe he's going to talk about the data frame API. So that should be really fun.
Yep. I'm enjoying the data frame API. It's still kind of early, but you can still do a lot with it right now.
Yeah. So the data frame, explain a bit more about that. I know you worked a lot on that as well, John, like a data frame. What is it trying to mimic, I guess, in the Python world or
Yeah.
elsewhere?
So If you're familiar with pandas in Python, that's what the data frame API is trying to be like for .NET, for
Yeah,
that the data kind of processing and all that.
yeah. So I think it's as you said, it's very early. There was I guess the general availability was just released like half year ago, maybe.
Yeah.
Pretty early, but you can already do a lot of stuff with it, and I'm really excited to see. I know that I guess they want to mimic the data frame in pandas, but it would be even better, I think, if they would be able to also do it more C# like. I think
Right.
some synthetic sugars here and there, but we'll see how it evolves. I guess it will depend on feedback from the community. So chime in.
Yeah, it's open source, so definitely put some issues out if for future requests, or feel free to put a PR in if you want.
Exactly. Yeah. Perfect. And so, what after Praveen's talk here? What is the last talk of the day?
Yeah, our last talk is from Will, and he's going to go over building serverless machine learning APIs with Azure Functions, ML.NET, and even some Cosmos DB in there.
Yeah, pretty cool. I'm excited about that one. And Will, he's located in New Zealand. I think he's from the UK from the beginning. I may be wrong here, so Will has to correct me later. But he is currently at least in New Zealand, and that's fascinating to kind of get his perspective from there. And we have a question in chat. I see Brie has already answered it, but I'll make sure everyone knows it as well. Is that all the sessions will be recorded and they will be uploaded on the YouTube channel. You can already now watch the recorded workshop from yesterday on Twitch and YouTube. But we will clean it up a bit, right, John? And upload
Yep.
it again there. So we will have it for persistence. And the same thing will be happening for all the sessions today. We'll make sure to record them and upload them specifically so you can watch them later. It should be good. And with us today, we have Luis and Bree as well, helping out here, answering questions and monitoring the chat. So you see already Bree is up early here in Seattle time, and I know Luis is also on the line here, helping us with the questions today. So if you have any questions, know that we have a committed and dedicated team here in the back trying to assist you as much as possible. So thank you, and Luis and Bree for doing that. And today, actually, the stream and the conference today is completely not managed by me. Today, we are thankful enough to have Luis' brother, Eduardo. He is producing the stream for us today together with Luis. So me and John, we are just going to be hosts today and enjoy the conference as much as you do.
Yep. Look forward to interacting with everybody as the sessions go on, and to learn some stuff myself.
Yeah, I've got some talks that definitely. Well, I'm going to tune into them, of course, because we're going to be here. So I'm excited.
Yeah.
Well, the final thing I want to leave you with, I guess, before we kind of await Henry's talk at 10 a.m. Eastern, so in like 15 minutes, is that in the bottom corner of your screen right now, you see a hashtag, and the hashtag is virtualml.net, virtualmlnet, sorry. So if you see something you like today, if you see a talk, something, if you want to take a nice screenshot of me and John right now, smile, John, maybe you do that. Then make sure to put that on Twitter or LinkedIn or whatever social media you use, and use the hashtag virtualmlnet for that, so you can share the love with the community, and that would be awesome. And yeah, I think that's kind of all we have right now, John, right?
I think so. We'll be monitoring the Slack and the chats if anything else comes up.
Yeah, exactly. So stay tuned. We are going to have Henry join us at 10 a.m. Eastern, so in 15 minutes. And until then, start asking questions in the chat, start connecting with your peers, and we will see you in 15 minutes.
Yep. See you then.
All right. Good morning, everyone. Welcome back to the virtual MLNET community conference here, day 2, and we are getting started with sessions now. If you join us this morning, me and John, we're talking about what's happening during the day, and we have 9 awesome speakers lined up for you today. And the first one is actually going to be on a topic that is not MLNet related, but it's on a more overarching topic, AI ethics. So with us today, we have Henry Gia. Good morning, Henry.
Good morning. Good morning, everybody.
Yeah, Henry, you're a data scientist lead here at Excella, my company that I work for as well, right? And
Yep,
you're also a startup advisor.
absolutely.
What kind of startup advising do you do?
So normally, primarily, I like to offer services to those in the very early stages, normally when they are in incubator, and also those in a non-for-profit sectors. So, kind of startups that is currently maybe a little cash strapped, so they could really use access to some expertise, but really not necessarily have enough industry experience or the money to reach out to the well-known foreign firms. So I'm there for them.
Okay, that's awesome. Really cool to hear. We actually have a team up channel in our community Slack for startup ideas and things like that. So maybe you should join and assist everyone there.
That's a great idea.
Yeah, but today you're going to talk about AI ethics, right?
Absolutely. I think that's a topic that is becoming more and more of a cohesive central conversation. And this is one of the things that will overarchingly affect all practitioners of data science. Doesn't matter which language you're using or which country you're in. I think this conversation will come sooner or later. So I think it's a great thing to share with everybody.
Cool, awesome. Well, everyone on the stream today, if you have questions to Henry afterwards, put them in the chat and we'll make sure to moderate them. But I won't take any more of your time, Henry. The floor is yours.
Oh, thanks, Alex. And good morning again, everybody. Thanks for attending. So I'm going to spend a little bit of time today talking to you about AI ethics. It's a very abstract concept, but I hope to kind of serve as a survey and overview of various aspects of this topic. And whatever conversations or questions you might have coming after this will probably be more far valuable than the initial information I share here. So let's get started. So AI ethics. Um, I think ethics itself is a very philosophical concept, right? It's something that philosophers have been debating and theorizing for millennia. And primarily, there are like 3 very popular ways to look at considering what is ethics and what is ethical. One of them is virtue. Think of the term virtuous, tend to be set by a set of rules or hopeful aspirations, doing the right things, avoiding the vices, and so on. The ontological one is more of a moral framework. Think of like the 10 Commitments or some of these, or even some ways you can consider the U.S. Constitution potentially be a legal framework based on a moral framework. So these principles that guides actions based on a rational interpretation of those rules. Or lastly, the consequentialists. They believe that drive actions that leads to the greatest benefit is really the central principle that should be guiding what is ethical and what is ethical action. So not to go into the weeds here, what we're discussing here is probably a mishmash of the deontological and the consequentialist beliefs. So somewhere between we're essentially trying to say, how do we establish the framework and the principles to help us leverage AI as a tool, as a technology that can provide the greatest benefit to the world. Not to, not to say that virtue is not a thing to be considered here, but in this conversation, we're just following the combination of the latter two. So here's my personal, very layman interpretation of what I consider to be ethical for AI. I just want to put it out there as maybe as a seed for discussion. So I think the development and implementation of AI to maximize benefit, but at the same time considering the harm and minimizing that harm, and provide that as a service or as a tool to the greatest number of people is a really ethical goal that I personally aspire to. So one of the things I tend to think about ethics when is that if we are venturing this as a profession, as practitioners, into somewhat strange territory, unknown territory, maybe we can borrow from, the experience of other professions that have gone through some of these, are relatively mature in how they consider ethical professional conduct. So, for example, in medical field, in the U.S., they take something called Hippocratic Oath, right? So the layman interpretation is first do no harm, but really there has gone through many iterations of following this essentially the same principles, a version of this oath. In that oath, they consider openness, knowledge sharing, treating patients instead of illness, acknowledging the limits of their abilities, and essentially taking the whole profession in this ethical light. And in the legal profession in the U.S., different states have a different oath that attorneys must take, and most of them involve protecting the Constitution, having some sense of honesty, civility, and fidelity towards their patient's cause. And in the financial world, so if you have a financial advisor or fund manager that is helping you manage your money, their highest legal duty is one party to another, requiring ethically acting in the other party's interest. So in the financial sense, means that they cannot put their own interest or a third party interest before your own. So I think there are some elements in all these that we can borrow from. And also it's comforting to know that all these other professions have found that relatively mature ethical sweet spot in terms of guiding principle to help them navigate all these different principles. So here is the graphics put together, as you can see on the bottom there by Harvard University. I found this graphics to be very helpful. It is essentially a visualization helping you to navigate through a lot of these different publications. The list of, so the concentric circle, each concentric circle is a different principle. So you can see from inner to outer is privacy, accountability, safety, security, and so on. And the color coding is really the sector of our society, and the bubbles on each on the rungs represent essentially the robustness of that discussion, judging by the amount of literature and essentially anything released by corporations or anything by a government agency in that field. So what we can learn from this in just first pass is that on some topics like privacy, the discussion is relatively advanced, and it is however, in other areas, such as human rights and even in human control of technology, it is still lacking. But in particular, you can see that in the government sector, the discussion is, obviously spotty, and that is something that for the development of AI ethics is something that should be made up. So some of the ways that I kind of tend to look at AI ethics is breaking down by various principles. One of the first principles is really the idea of transparency. So I think this idea is, not just unique to AI development or AI implementation, but also happens a lot in other data-related fields, right? So how is data used to train the AI collected and curated? So consider the idea that if the data collection process is really a legacy of existing systems, and a lot of existing systems having intrinsic biases, then we should be at least be made aware, or as we're building these AI model, be aware that data is flawed and data in itself is intrinsically biased. And how the curation is very important, because a lot of the curation and transformation that happens to the data could create a bias in that process. Take an example, right? So a lot of these data labeling services are scattered all over the world, and the breakdown of the services provided generally is really done by language and done by a certain type of domain expertise, but there's very little consideration of cultural understanding. Even in the English language, sometimes as plain as different usage words. For example, in Ireland, they say grand, they mean just, oh, it's fine, it's okay. But in the United States, that word carries a much more positive connotation. So that's just a very small example of that cultural misunderstanding or cultural difference that can lead to a skew in the transformation of data. So when and where are we interacting with AI? So there's a story that about 2 years ago, New York City decided that they want to run an audit of all their decision-making algorithms. They didn't know how many they had. They didn't know where they were. They didn't know how the decisions were made and who was impacted. And after assembling a commission and 2 years of investigation, they realized that all of them are essentially black boxes. Even after all that work, they understood less than 10% of all those algorithms. And these algorithms are affecting everyday lives. They're allocating where city services go to collect garbage, fix roads. They're deciding which kid goes to which magnet school potentially, which neighborhood requires more housing assistance, and where should affordable housing be built. So all these things that regular citizens in the city might not be aware about. So having that transparency to acknowledge and letting people know that how their lives are being impacted, even when they're not choosing to interact, is important. And which services provided to us include AI components, like I mentioned in that city example, that could be definitely a deterrent to people's amount of trust. And is there also an alternative to AI-based services? So as we saturate more and more of our daily lives with technology that has AI components, sometimes we have to stop and think, well, what if somebody, for religious purposes or cultural purposes or personal preference, they do not want to choose the AI-based services? Well, sometimes what if they go the way? What if the regular human to human services go the way of fax machine or telegram? What if they are no longer an option? What are those people supposed to do? And of course, there's a trade-off to transparency, in that if studies, a few papers have shown that, especially using Lime SHAP concepts I will introduce later, techniques to essentially make a model explainable, enough of those tests to linearly approximate the model can produce enough data to essentially reverse engineer the model itself. Now that could be a really important concept, because if something that is making important decisions is reversely engineered, that opens it up to hacking for people with technical sophistication to essentially hijack and leverage that insight to their own advantage. Somewhat related concept here for principle is this explainability. So this is a little bit more a nuanced model-specific principle. Which features are being considered by the model? What weights and what gradients are being associated with that? And how? But the additional step beyond that interpretability and kind of elevating this to explainability is that last step, is the communication regarding the model's decision logic to the human. Right now, even if we do decide to, take apart a model, to really understand what it does, 99% of the time, as far as I can see, I've never seen an example where that knowledge has been translated to a language or in a communication model where that could be communicated to the end user to help them understand how their decisions were made. And this is actually now emerging, I don't know, like call it subfield called XAI or explainable AI. And on DARPA's website, here is their particular definition of it, is that they want to build a more explainable model and also enable human users to understand, appropriately trust, and effectively manage emerging generation artificial intelligence. So this is something that I think there deserves much more research, and there is already a lot of exciting stuff going on right now. But the what's falling behind here is the adoption of what's already relatively mature techniques into the existing production process. And another principle that is important here is consent, right? So does users have the option to opt out? Do they have the option to opt out partially of AI technologies? And how do and also sometimes it's not even opting out, for example, a mobile app that has AI elements. Uh, for example, if they're an avid Facebook user, do they understand the impact if they decide to not allow the Facebook to collect their data? Do they understand what services will be denied to them? Do they understand what decisions will be made by the lack of data by Facebook that might affect their user experience or the content they're being shown and the connections they're making on Facebook? Inclusivity. So this one is relatively broad, but I think the end goal is pretty obvious. Is the idea that AI's technology, especially, is one of those technologies developing in such an open source environment that it is a technology for the people, from the people, by the people. And what that means is that it should be free from biases. It should not be a tool to produce discriminatory decisions, even if the data that is used to train the model is inherited from a legacy of a bias. A good example is that there was a algorithm called Compass that was predicting prison recidivism. But of course, in prison population, there's a huge racial bias, and the data collected inherits that, essentially existing phenomena. But the model itself is still is a continuation of bias. Just because the data was biased to begin with doesn't give us really an excuse to say, well, throw our hands up, there's nothing we can do about it. Let's just build a model based on what we have. Development loops should include users as stakeholders. A lot of times these things are built behind closed doors. End users, whether it's B2B, B2C, or B2G, the stakeholders are sometimes kept out of the loop until the model is built or nearly built. And the iteration process a lot of times do not have direct feedback from the user. And that's really important because having revenues for redress and having even a broader public essentially reflect on unforeseeable impacts from these AI models is important. And then, of course, for that to happen, a lot of it has to do with the general public having improved data and AI literacy. Otherwise, it is much harder to communicate the explainability piece, but also it's harder for them to really gauge the impact on their personal level, how to adjust their exposure to AI, and what is their comfort level, and what kind of regulations proposed by politicians are more suitable or closer to their personal beliefs. Last piece is the government politician piece, is the oversight and governance. Right now, there's relatively vacuum to this. Not to say that there isn't some valiant attempts, but I think what we're lacking here is more of a discussion between all the different jurisdictions. So from cities to state to government to global level, there's lacking a more of a unified discussion on what is important and what are some of the legal frameworks that can be established, and what are the, for example, a lot of these corporations, right? They have to have their books, their accounting audited by a third party. Right now, there is no such audit, kind of services really widely available, or a need by oversight to do that. And also, that the global discussion, that private-public partnership discuss what should be some of the industry standards for approval and usage. What are some of the measurements and metrics that can be used to not only assess individual AI performance but also compare them across each other. Now, one of the technical challenges here, in addition to all those different techniques to pull apart these more black box models, is the idea of data. Imagine if we were to have a agency available that is overseeing AI algorithms, and that is affecting people and making sure that is free from bias. That agency will need to have a substantial data set to essentially as a tool set to test against a range of different AIs. And of course, that the composition and the collection of that data, generation of that data, has to be kept very secret. But at the same, and then the data set itself has to be substantial. So to adopt all the things that we talked about, how do we move forward to go from these principles and theories and ideas to actually on the ground implementation? So break it down to, so the first challenging area is legal, right? So ownership of data and data products. Right now, I don't think there is a very clear-cut jurisprudence to define, especially on the internet and social media, like once your data is collected, who owns that data. GDPR and CCPA do help define that somewhat, but of course, they're highly patchy in terms of how they define ownership and also the region where they're taking effect. But also, we're already seeing that the cost of compliance just to that, essentially our first giant step towards this completeness in legal framework is already substantial. And a regulation oversight needs to be consistent so that we don't run into necessarily a situation where like all the banks are in Bermuda, right? All the technology companies have like subsidiaries in all these different countries to hold patents. So the regulation oversight, if there is not more of a universal coverage and common understanding, then that the regulation oversight will be rendered relatively ineffective. And lastly is the governance and enforcement. So a lot of these technology-related issues depends on where they emerge in the U.S. They're either part of the Federal Trade Commission or the FCC or the Federal Drug Administration. All these different agencies essentially cover small pieces that are related or adjacent to this technology, but not necessarily directly overseeing it. And the associated Office of the Inspector Generals of these agencies, and also to more of an enforcement role, the federal agency and local governments are really lacking the expertise, the talent, or the really the mental fortitude to really tackle these issues. While if the rule is violated, what is the civil and legal enforcement revenues that they can take to make sure that people are not being discriminated against, or that AI in itself essentially is running rampant without checks. So the existing frameworks here is that we have CCPA and GDPR. Personally, I think they are a fantastic first start, especially GDPR includes what they call a right to explanation provision. So in that provision specifically spells out that no AI should be solely automated. So there should be a human in the loop, and no AI should result in legal or serious negative impact for individual. And also requires necessary assessment, providing meaningful information about the logic of decision-making process, appropriate mathematical statistical procedures, obtain human intervention, allow the end user to obtain human intervention, express point of view, obtain an explanation, and the organization that has built the AI is required to provide technical and organizational measures. So you probably, as practitioners, you probably notice that all these sounds extremely vague. None of these measures or explanation or procedures or process are legally defined or even technically defined in GDPR. So I think that's where a lot of us practitioners can step in to really bridge that gap on what these well-designed measures want to achieve and how to achieve it on the ground. Of course, there's a lot of technology and business opportunities involved in making these real and on the ground as well. And also, the Civil Rights Act and the relatively similar Employment Equality Framework Directive in the EU. These are similarly can be leveraged to essentially go after models that is resulting in biases against protected groups. So protecting people from discriminated by AI in terms of gender, sexual preferences, religious beliefs, and so on and so on. And lastly, I include FDA approval processes because, quietly but surely, there's already have been more than 100 AI algorithms and AI-based devices and AI drug development processes that's already been approved by FDA. So FDA has been quietly, essentially leading the way in terms of how to vet AI technology before releasing it to the public, and they have even you can argue that even have a much higher threshold of evaluation because a lot of these things they do will end up, impact people's quality of life or even life itself. So some of these later newer proposals are, proposed in the U.S. and the HRs essentially represents a House resolution. S stands for Senate. So these are bills that has been brought on the floor, and most of them have passed at least in one house. But as you can see from their names, a lot of them are superficial and area specific. So what we need here, ideally, for the government to send a clear message to the industry is some overarching guidelines rather than just spotty ones that target specific type of product or specific type of application of AI. Another type of adoption challenges is cultural. So region, age, education, and other demographic markers have been shown in surveys over and over again to essentially have this, almost like a gap in how people see AI, how people trust AI, and very likely leads to different degrees of adoption and different way of regulating AI. This is a data set, a survey performed by Ipsos in 2018. And then you can see that by country, light blue represents, so the question posed to the surveys is that, how do you trust AI? It's a very straightforward question. As you can see by country, it varies a lot. And what do you notice that China's on top, and its neighbors South Korea and Japan are very much on the bottom. So it's not just a regional issue, but it's also could be by country issue. And you can see the United States is more of a mixed bag, somewhere in the middle next to New Zealand and Australia. So I think this is something that to keep an eye on, because as AI emerge as a productivity tool, if adoption rate due to cultural differences and this implicit trust as society in AI is different, that could introduce another element to introduce this wealth inequality between countries, and also this essentially who is going to be left behind. And here is a survey performed by the Center for Governance of AI. This one is much more comprehensive in covering a multitude of different demographic markers. You can see that age, you'll imagine age would be much big factor in determining it, but younger people seems just to be marginally better at trusting, well, marginally more trusting in AI. Men tend to be more trusting than women. I think the biggest trend you can see here is that higher education and higher income tend to correlate with expressing higher trust. Also, what's really interesting to me is somewhere down here that you see CS or engineering degree versus no CS or engineering degree. Not surprisingly, people with exposure to computer science and engineering and programming have shown more of a trust in in accepting AI. And lastly, this is where I'm going to spend a little bit more time. The last bit of time we have left here is that the idea that what are the technological challenges? So firstly, we're talking about the cost of adoption as standard practice. As of today, the pure pursuit of AI essentially is performance. How well can your model perform in terms of accuracy, in terms of running as small of a network as possible on a mobile device? How fast does it run? How many how fast can it return result, and so on. But I think what we're missing is an opportunity here, because the techniques, as I talk about a little bit later, in helping parse out the logic in these machine learning models and deep learning neural networks, is in turn a tool to help us tune those networks and models to perform even better. But right now, that additional cost of essentially doing another step in this development cycle is not really standard practice. Industry trend to low-code solutions. So as we can see, there's definitely a lot more essentially these gray boxes and black boxes solutions that's promising to perform specific type of task very well. And also there are essentially these platforms that is telling you that, oh, you don't really need to write code. You can just essentially click buttons and select which one is having automatically better performance metrics, and then one click you're going to production. Both of these type of offerings definitely hold their appeals, and that's why they exist and then they have a niche in the market. But however, in the long term, I think a lot of these buyers of these products, government agencies, larger corporations, have to realize that they do want to adopt transparency and explainability in their models. Adopting low-code solution might become an obstacle, a burden down the road, rather than a good first step, because then they essentially rely on third parties to deliver solutions that satisfy what is industry compliant for them and what is intrinsically considered ethical to their standards. And then lastly, the trade-off between faithfulness and completeness. This isn't like more of a technical concept, is that a lot of techniques that I'll talk about in a little bit here is that is to describe such a complex system. There's, it's almost impossible, essentially trying to describe the entire planet Earth, in one sentence, right? You can say it's blue, or you can say it's mostly water, or you can say something. All of those things are true, but most likely those are only things that are true for very specific parts of it. And to really deliver that information, to balance faithfulness and completeness to the end user, is a balancing act that I think will be a challenge for a lot of practitioners and organizations. So specifically, I'll touch on four type of approaches, techniques, or tool sets here to help parse out essentially the intricacies of the model logic. Well, I just want to highlight here, a lot of these are kind of came out a couple of years ago. Conceptually, I think this was really important. I'm not entirely certain that most of these have a .NET implementation, but if they don't, I hope they get on that. So the first one is called Lime or SHAP. The concept of these, what they call linear proxy models, came out first in 2016 paper called "Why Should I Trust You?" I think it's a very aptly titled paper, right? It's a question that is getting asked more and more by end users. And what this really kind of is a trade-off between local versus global interpretability. Let's take for example, let's think about if you have a two-dimensional projection of high-dimensional clustering, and then and you're trying to do a binary classification. A lot of that really having to do is finding that decision boundary, and decision boundary might not be linear. And a lot of these models, in fact, their advantage is that they are nonlinear. Now, when you input a specific set of inputs, let's just say, dog or cat, and you input image of a dog, and then that particular image of dog might be a data point in that two-dimensional projection, all the features on one side of that decision boundary versus the other. But to know the gradient, or to know the localized decision boundary that is making that decision of a dog versus a cat, is what this technique is trying to do. Essentially, it's trying to draw essentially the tangent line of the decision boundary that's closest to that to the data point you're trying to decide in this binary classification case. All right, and then another popular techniques that is gaining a lot of attention is called GradCam. It came out in the paper in 2016 called Visual Explanation from Deep Networks via Gradient-Based Localization. Excuse me. So what this technique is trying to do is that it came out as essentially trying to explain trying to help visualize how convolutional neural networks interprets an image as a signal, and how that how those signals lead to node activation, node activation, node activations in the various layers of the convolutional neural network through occlusion. So meaning by purposely and iteratively blocking part of that image as a feature inputs, and then see how those occlusions might impact the decision outcome of that decision interest. And then by reversely, by propagating through the system to calculate the gradients in each case of conclusion, it generates a visual representation. Essentially, it's a heat map. For example, dog versus cat. It might be focusing on the long bushy tail, or it might be focusing on the more elongated face and pointy ears to identify its features that is contributing mostly to the decision that is the dog instead of the cat. Lastly is a related technique called deep lift. This is also a technique like GradCam called saliency mapping. And so this one came out a little bit later in 2017 in a paper called Learning Important Features Through Propagation Activation Differences. A little bit different. So even though it's a saliency-based techniques, what is different from GradCam from GradCam is that like GradCam is gradient-based. This one is not. This one is more of a, okay, instead of calculating a gradient, let's see if we can just do one fast backward pass through the network and then infer the weights. And that's really what we're interested in anyways. And then see if we can identify based on weights which nodes and therefore features are leading to the final decision. However, this one has a drawback that can be hard to evaluate, because for each network, sometimes for even in for each decision, the weight value are essentially evaluated relativistically. So choosing a baseline, so to compare all networks, all decisions through a single network, requires more experience and expertise. All right, just do a quick time check here. So Lucid, Lucid is a tool that is provided by Google. Came out essentially in blog post in 2018, the building blocks interpretability. It's not so much similar. It's different from the previous three that I talked about, because it's not really a technique or approach. It's more of a collection of tools. It's built with TensorFlow, has a collector infrastructure and tools, including GradCam, and some more interesting ones, including serial network-related, kind of evaluations that you can, quickly spin up and leverage to essentially evaluate the performance of a model, but also understanding how the model's making those decisions. And what's good about this is that it does have, because it's built through TensorFlow, it does have a variety of different APIs, and it includes a model zoo for all the pre-trained models, for for someone to quickly spin up, retrain the pre-trained models, and even just play around to understand some of these more novel techniques that they have included in this library. And also what's really interesting here is a lot of things I talked about before, as I mentioned, that idea that local tangent of a decision boundary, or the specifically of the process of occlusion based on a single image input, those are still relatively local understandings, meaning that you by performing it once, you understand how the model performs against a specific set of inputs. In this library, they provide some tools to help you gain some global understanding in terms of, for example, in neural networks, how the how some of the nodes are essentially there's interplay or interactions, the primary interactions between some of the more quote unquote important nodes. And that can gain some more generalized global understanding in how the model performs. So what's next? I think there's a lot. There's a lot that we have covered, that we have gone over, and there's a lot more to do because each one of really the aspects, each one of the slides really deserves a work stream or longer conversation itself. I think one of the first things that the industry can do is reaching consensus. Um, I believe that this is one of the scenarios where the industry start reaching consensus, work together, start regulating ourselves, then we won't run the risk of the government or somebody um, who is more driven by the principle and even the appearance of regulation to implement rules that is not reasonable or that's not really realistic. And having that happen to us rather than having us as practitioners and as an industry build a framework, I think you can end up having a long-term difference. Again, I want to iterate the importance of data AI literacy efforts. Sometimes I will go to like high schools, talk to high schoolers about what AI is, like what are given examples and even help them like build a quick model. Just having that initial understanding of what AI is in the general public, I think it will facilitate much better and friendlier and productive conversations in how to really implement AI ethics. And having that public-private academic partnership, essentially something that we have already seen in a lot of different scientific sectors, and even in AI, but specifically, extend that partnership into this topic. It's just having this circular flow of findings driving policy and policy guiding finding and so on, and of course the private sector providing investment and acceleration in that cycle is key. And of course, AI is an area that is fast evolving. We can always use more funding into more research. I think that's something that in the private sector, in the US at least, that's definitely an advantage. But the government is still relatively lagging behind. I think just last year, it just passed less than $3 billion in AI specific funding. That's really a drop in the bucket, especially if the government want to have a say in where the technology is going. I think more direct funding into targeted research areas is really crucial. So I have gone through quite a bit of content. It's a very rich topic. I hope that this is enough to get everybody started thinking and lead to a longer, richer conversation amongst us. And even maybe some kind of if you have more interest, please let me know. We'd love to discuss this topic. And there's definitely organizations, at least that I'm part of in the U.S. called ACT-IAC, that is currently working on AI ethics advisory to the U.S. government, hoping to gain some more attention and lay some groundwork to guide the future policies in how this area will be made real. Again, thank you everybody for your time. This online conference thing is fantastic, and I hope you enjoyed it as much as I have.
Thank you, Henry. That was awesome. So if you have any questions, you can ask them in the chat. I already have one I want to ask you, Henry. So do you think there'll be a specialization in kind of data science ethics in the future, or is it something that will just be something you have to do as a data scientist?
I hope. I think a lot of data scientists want to do it. I really do believe that practitioners, it's just, we're naturally curious people, right? We're practitioners. We like to tinker. We like to build. We like to learn new things. And to build something that we made ourselves, but not really understanding the full intricacies. I think personally, I have a lot of curiosity to want to know, and I think that curiosity is shared by a lot of practitioners. But unfortunately, I think unless, when we do work, a lot of times the time is such a crunch. We don't have that luxury to say, oh, I'm going to take 20% of my time to work on the explainable piece of this, if it is not a requirement, on a project. So I think even though practitioners would love to do it, um, they still have to have the backing and the time allocation, the resource backing from the companies, and the companies are unlikely to do it unless there's some kind of compulsion in terms of compliance or regulation. So that's how I see it today.
Sure. Okay, great. We have a question here as well. When I studied biomedical engineering, I learned how to fill out an ethics committee application before setting up an experiment. Should CS students learn the same? Should there be an overarching ethics commission for novel usage of AI?
I think that's something that is, if we can have something set up like that, that'd be great. I think, especially as I mentioned before, FDA has already approved a lot of these AI algorithms in terms of medical imaging. We already had our first antibiotics that is developed using AI techniques, right? So all these are affecting people's medical decisions. So there should be no difference in how those AIs, your data scientists or machine learning engineers should be operating compared to a biomedical engineer. So I completely agree on that front. There should be some kind of ethics commission, and there should be some kind of professional ethical code to guide practitioners.
Cool. Another question we have here is, what do you see the role of citizens and end users in this discussion?
I think, at least in a democratic society, a lot of these regulations don't happen unless people ask for it. There can be academics and corporations there, whispering to government's ear in terms of what they believe is the right path to go down. But a lot of times, they don't become, at least in the US, they don't become campaign issues. They don't become bills. They don't become, laws unless the citizens are actively asking for this. So as citizens, I think one is this generalized idea of data and AI literacy for more people to familiarize themselves is, not just conceptually how this works, but how exposed they are in their daily lives to this type of technology. But the other one is, certain type of activism. For example, we recently had a presidential candidate, Andrew Yang, right? He was more of a technocrat. So a lot of these AI-related topics were more part of his campaign platform, and a lot of support he did receive was based on his stance on those topics. So there could be a certain level of activism and organization that can drive policies.
Okay. Well, thank you very much, Henry. This was a fantastic talk, and thank you all for answering all the questions as well. You have some great feedback in the chat here from the audience. They really much appreciate this.
Oh, thank you, everybody. Thanks,
Yeah.
Alex.
And next up here at the full hour, we're going to have Jernay Kafka from Brisbane giving us talk about an introduction to ML.NET. So definitely stay tuned for that. But before that talk, we're actually going to go and listen to Mihai, who is using ML.NET in his organization. So we're going to listen to an interview with him. So thank you, Henry, and stay tuned for the next talk at the full hour.
Right.
It's great to have you on the line today, Mihai. Awesome to be able to ask some questions about this and kind of get your feeling and then your perspective and experience. Could you start off by just giving us an introduction to who you are and your organization?
Sure. So lovely to meet you. My name is Mihai Mihaescu. It's like a Michael, but in Romanian. I am a system architect for Asgard Systems. Asgard Systems is a software company solely focused on providing competitive advantages with our partners across industries. So starting for sales, manufacturing, automotive, up until the distribution chain and retail. It's what we do. We've been doing this for some time now, and quite happy with the results.
Awesome, yeah. So how are you using ML.NET in your organization?
Oh, so we have a project. We actually have multiple projects right now in development, which we are, we decided to use ML.NET for them. Our main, let's say, core project that is already, is already live and it's already has a, let's say, history behind, is a project that we've done with a retail partner here in Romania, which has the biggest chain of grocery food stores, in which we tried to optimize and actually succeeded in optimizing, food waste, which is a nice topic. Besides the fact that it's cool from a technology point of view and using ML.NET and a lot of challenges throughout the project, it's also nice to help out reducing food waste.
Cool, awesome. So what made you choose ML.NET?
Well, so we actually started using ML.NET way before the official version 1 of the software. We did machine learning projects starting from 2017, and we tested several approaches into getting the right balance between what you need, what's the expectation, what's the prediction that you need to do in our case, because we are currently forecasting food demand in stores, and you need some kind of balance in how much you do on cloud, how much do you do in the application, and how do you find the correct balance between them. And ML.NET just fit like a glove. We had projects in research and development because we focus very much on research and development and finding, catching that adoption curve way in the beginning. And we focused, in 2017, we had projects in which we could not get a technology to serve our needs. So very happy when we found ML.NET. I think the first version that we used, and we couldn't believe that it was actual production ready, was about 0.4, 0.5, somewhere along those lines. And we had internal discussions with our colleagues and said, yeah, let's test ML.NET for this scenario. It actually makes sense, and I think we're going to scale this very nicely. 2 days later, sorry, 2 days later, my colleague said, I asked him, how's it going with it? Yeah, it's done. Well, what do you mean it's done?
Wow.
But what do you mean by done, right? Yeah, so I implemented yesterday, right, and started testing it, and it's already working. I mean, like working, like proof of concept working, or no? It was actually already working and already providing a lot of added value for our use cases. So we're very happy to, and we tested it a lot because going through time as a software developer, and every software developer, I think, gets to a specific point in which you say, okay, I see a new technology, it's nice, very nice. Let's just wait, because I had a lot of issues when introducing new technologies into my current workflow. But we tested and we tested and we tested. We had like thousands of training cycles ran through the ML.NET framework, and we said, no, we can't find anything.
That's awesome.
Nothing wrong with it, right? And we went live in production with it, and
Cool.
slowly replaced our legacy solution with Python and migrated. I think we are now 95% with ML.NET live every day.
So if I may ask as well, that's great. So may I ask, how are you deploying ML.NET today? Are you deploying to the cloud, or are you deploying it on site, or? So
it's a balance. So depending on the scenario, you can deploy on cloud and on-prem. Right now, what our specific scenario, because we have a vision to get the prediction cost as close to zero as possible to engage all the prediction scenarios that we want to. We found a balance between cloud and on-prem, meaning that we keep what's important, like the data and the orchestration, in a centralized manner, and we do distributed computing on-prem using ML.NET. So we have some agent apps. You can call agent apps, or I don't know how you would call them better, which process day in and day out and forecast.
That's very interesting.
Yeah,
that's very interesting. So after using it for a couple of years now, like what are some things you would like to see added to the framework or library? What are you missing?
So because we are already live with this, so there's nothing right now. Right now, there's nothing. We don't have a specific. We can't live without this. We have everything we need, but of course, there always is room for improvement. One of the things that we would like to see added is better use cases for working with the database, because most of the enterprise scenarios are not the same as data science tutorials, meaning that you don't start with a CSV of the iris dataset and then load it. It's nice, it's good for learning, of course, but I would love for a junior developer to load data into a data table and do the regression. It's I know it's not efficient. We all know that it's not efficient. It's not the best way to do it, but it's a step towards that. Everyone can do it. I'm very happy with the technology, and that's where I see it. And also the tutorials help a lot that which you provided.
Awesome. Well, glad to hear that. Well, Mihai, thank you so much for taking the time to talk to us today. We really appreciate the time you've given us and the fantastic answers as well. And it's very inspiring to hear how you use it within your organization. And we hope that you will enjoy the conference.
Thank you very much, and thank you very much also for having us.
Thank you. All right. Well, welcome back, everyone, to the virtual MLNet community conference here. We are super excited to have you. And we had a fantastic talk by Henry just now. And now we have Journey calling in from Australia. Good evening, I guess. Good night, Journey.
Hi, everyone. Yes, I'm JK from Australia. Right now it's like 1 a.m. But it's a really good conference to be at, so I'm happy to be awake.
Yeah, we're happy to have you. Such a dedication to call in and join this this conference. So thank you very much. And Journey, you are a software architect in Brisbane, right? And just
Yes.
recently this week, you organized the Brisbane AI user group.
Yes, and it was really awesome. We actually had some cognitive services and speech APIs and showing people how we can do real-time transcription and then modify those transcription and put it back into cognitive services to improve future transcriptions, which is really, really insane.
That's pretty awesome. Well, that's fantastic. And we are so excited to have you here. And as always, everyone on the stream, if you have questions to Journey, we're going to ask them just shortly after this talk. Please put them in the different chats we have here, Twitch and YouTube, or you can also put them in the Slack community. And if you haven't joined the Slack community, do so. It's a great place to connect with any other ML enthusiasts, such as me, myself, Journey, and others. But I won't take any more of your time, Journey. The floor is yours.
All right. So am I sharing?
Yes, you are.
All right. So hi, everyone. Welcome to Virtual ML.NET Community Conference. I hope you had a really good time so far. And I'm going to continue off with Machine Learning Simplified for Developers with ML.NET. Now, some of you have seen the workshop yesterday's. Some of the parts were covered already yesterday, but I'm going to give you a little bit of a different spin, a different perspective of what you might have seen yesterday. To begin first, let the clicker first. All right, click is now working. Let me reintroduce myself. I am Yannick Kafka, and you can just call me JK. I'm SSW Senior Software Architect. You can follow me at all these social media. My blog post, jkdev.me, connect me to LinkedIn. I'm co-organizer of Brisbane AI User Group. So if you're in Australia, you're welcome to join our virtual user group. By day, I'm doing a lot of .NET Core and EF Core, but at night, I really love to tinker with cognitive services and ML.NET, and recently also a little bit with VR. And this is kind of the setup for the current times. And when I'm looking at you, I'm actually looking at this little robot. Helps me connect with the audience a little bit better. And to make sure that I'm still healthy after these times, I am also experimenting with VR and exercise. And I must say, VR has come really long way. And this looks much tougher. It's really, really tough. I recommend it. And if anyone is interested about cognitive services, I have a Blazor client-side app where you can try out without writing any code. So if you're interested, ping me. All right, so I'm going to start the session with my story. So how did I got to ML.NET? Why did I even decide to go to ML.NET? What were my goals? And once I'm going to introduce that, I'm going to take a step backwards and I'm going to show you what is machine learning. And the reason for this is if I'm just going to show you, hey, these are the buttons you have to click, the magic is going to be lost. You'll be like, okay, these buttons do this, and you'll be like, oh, problem solved. What's the big deal? But showing you what machine learning is, once we click that last button, you'll be like, oh, wait, that's all we needed to do for all that stuff? And you'll be, I hope, more appreciative with what ML.NET Model Builder brings to the table. All right, so all of my projects kind of starts with a goal. And this goal kind of was quite simple. I had bank transaction descriptions, and all I wanted is to get from this text to categories. That's all I wanted. And I, in fact, asked myself, okay, how hard is this? It's just two things, right? Well, I tried to solve this with Excel sheet because I wasn't able to get data from the bank. Then I started to write my custom C# code, first hard coded. Okay, that didn't work well. The bank transactions were constantly changing. Then I tried to write two different versions of rule engine in C#. It worked pretty good with regex and stuff like that. But then again, I had to change the rules, and sometimes that was really, really annoying. And the reason why I was so passionate to solve this problem, because I was doing manual classification of all my bank transactions manually every weekend. I really wanted to know where my money is coming to, so that I can save some money. So after a while, spending hundreds of hours trying to figure out how to solve this problem and manual inputs, I was like, hey, can I solve this problem with machine learning? It does kind of sound like a problem for machine learning, right? And how hard could it be to solve this problem with machine learning? I mean, how hard can it be? Well, one does not simply learn machine learning, is what I learned on a really hard way. And what I realized is, well, you start learning machine learning and they throw you some different phrases and you're like, okay, I need to learn all of this stuff. Now, I don't want to do the math stuff. I just want to learn what is machine learning, okay? So I want to be able to use the APIs that do the math for me. And I thought that's going to be easy, right? Wrong. Even when you exclude all of the math, you're starting to realize you have rabbit hole of a rabbit hole of a rabbit hole. Every single topic you cover is just another thing you have to spend hours learning and understanding. And after the weekend is over, you're like, I have done nothing yet. I have came no closer to solving my problem. And then I spent another weekend, and then I spent another weekend. And then I just came to realization that, well, time is infinite. It's not really infinite for me. So I decided that sometimes you just have to let go of dreams, and project failed. I gave up on machine learning for a couple of years. That is until Microsoft announced ML.NET. And I was like, yeah, right. Another machine learning framework. I've been there. And then I spotted one line that changed everything without any prior machine learning experience. That's the main reason why I went back to machine learning. And when I looked at ML.NET, there's a lot of things that I really liked. For first, it works offline. We have all the Azure stuff. It's really, really good, but I don't really want to pay for it until I know it works. And it's simple yet powerful, like all the .NET libraries should be. It's already been powered by a lot of Microsoft products. As far as I know, it powers Power BI, Visual Studio, Outlook, and lots of other stuff. I wasn't actually able to find the entire list, but that's what I remember from 2 years ago. It supports major machine learning models like TensorFlow, Onyx. So if you have already a data scientist that already done machine learning and already has everything ready, you can just say, hey, let me just consume this in a simpler API so I don't have to use all the other stuff. And one of the defining features, at least 2 years ago, was the awesome samples on GitHub. The reason for that is there was one sample called GitHub issue classification, and I did just some minor changes, and all of a sudden, I had my goal, at least a prototype of it, with just changing a couple of lines, and was like, that can't be true. I spent like 1 hour. That should be like a whole weekend thing, not 1 hour. And I wondered, and was like, yeah, it's working. I mean, data wasn't great, so it didn't work for all of the stuff, but I was like, what is this black magic? And hopefully now I hooked you a little bit on ML.NET, which I'm going to talk more about a little bit later, so that we look about what is machine learning and how does machine learning work in a really high level. I won't go too much into details, but just enough to give you a little bit of understanding why is it hard to learn. So what is machine learning like? The simplest way to explain it. Well, in classical programming, you have rules, which are usually the specification, and then you have data, which is usually from a form on a web page or something like that. And then we have the algorithms which spits out an answer. So that is the classical programming. Well, with machine learning, it's a little bit different. The rules and answers are reversed. So into machine learning, we put all the data with all the answers, and then machine learning tries to learn the rules rather than us trying to figure out all the rules for all the answers. And this allows us to have a specific machine learning process, which we now call MLOps, where we can have training data, which then we put into the machine learning training algorithms, and then that outputs a model. A model is basically a binary zip file. It could be even an XML. It basically defines rules that the machine learning learned from the data, and then we deploy that model. So that we can use it. So we can deploy it to desktop and mobile, we can deploy it to web, we can deploy it to IoT Edge. But this is not where the story ends. This is not the main strength of machine learning. This is just a portion of it. We then collect feedback. For instance, if we have desktop and mobile application or web application, the user might say, hey, this data was wrong, and this feedback comes back. Or we collect more data from IoT devices, so we learn more about their environments and where they operate, and we get that feedback back. And then we improve the data that we're getting back, and then we update the training data. And now we repeat the whole process. And this is how machine learning can continuously improve. It's getting back data, it's improving the training data, and then it can give us back a better model. And the good thing about this model, excuse me, the good thing about this model is that we can just replace the previous model, and now all of a sudden our applications are smarter with a newer artificial intelligence, if you will. So we don't have to redeploy the entire application. Okay, so we kind of have looked at how machine learning works from really bird's view eye, from really far away. Now let's have a look a little bit closer on the actual machine learning. So machine learning is a little bit hard to explain. So what I'm going to do is I'm going to split it up to a couple of types of machine learning. And I'm going to start with supervised learning. And sometimes it's called labeled data. So what this type of machine learning does is tries to learn from specific data that is labeled and tries to solve a problem, try to find rules based on what we're trying to learn. So for instance, the most simplest type of that is classification, which is further divided to binary classification. And a good example of that would be, is a tweet positive? So we're trying to do a sentiment analysis of true or false. Then another very popular classification is multi-class classification, where we're trying to classify an image into a label that we can then more easily use, or we can even generate a decision tree out of the inputs. Another one that is very popular in stock market is the regression. So here we can try to predict, for instance, house prices. But on the other hand, we have unsupervised learning, and this is a bit harder part of machine learning. So what we're dealing here is we don't actually clean up the data in the same way as supervised learning, where we have nice inputs, and then we say, okay, for these inputs, that's the result. Here we have a little bit more chaotic data. Still, we use data science to clean up things. But one of the most popular subtype of that is clustering. So what this essentially allows you to do is cluster together similar data points. And that is most commonly used for product recommendation, where for one product, you look, okay, this user like this product. Let's see what other users that have similar likes also like. So we can then recommend a product based on that. Then a little bit more harder type would be dimension reduction, which is quite interesting because what you can do is you can have a complicated table and then you can simplify it so you can generate, for instance, some graphs, for instance. And this is just a couple of unsupervised learning. You have anomaly detection and lots of other types that are also very interesting. But for time, I'm not going to cover them. And the last branch is reinforced learning. So this one you might have heard. It's a continuous learning, and it learns on the fly, and it's usually used with cars like Tesla, where you do autopiloting and it tries to learn as it goes. Now, the reasons why we don't have crashing cars physically is because Tesla is training the cars in virtual reality and then on test tracks. So we don't have to crash the cars, so they learn not to crash cars. But it's also frequently used in games as AI. All right, so there's a lot of stuff going on here. And this is by no means a full picture. This is a small fraction of machine learning. And each individual thing that I just mentioned, you could spend a month studying. So yeah, here you have like a year full of study worth of material. But I want to go a little bit deeper. So I want to say, okay, let's zoom in into multi-class classification. And if you decide to just learn that, what do I actually need to learn? Well, it turns out that is another thing where it opens up a lot of doors. And if you want to use multi-class classification, you have to learn what kind of trainers you can use on your data to get a model based on multi-class classification. And ML.NET already gives us some of the trainers. And the main difference between these trainers is based on the data you have, you might have pros and cons depending on which machine learning, which trainer you use. For instance, one is great if your data is small. Another one would be great if you have a lot of different values, where another one is great if you have very few different values. So then you have to go through every single trainer and then figure out, okay, this trainer is good for this kind of data. This trainer is good for this kind of data. And you can read all of that in the Microsoft documentation. It's really, really good. But if you want to understand the pain of data science and machine learning, you can just follow graphs like that, where you start and then it's like, based on your data, you then dig to the right algorithms, probably, that will solve your problem. So you're starting to see that there's a lot of things to learn. And while ML.NET solves all of the problems with learning the algorithms and stuff like that, you'll still need to learn a little bit of trainers, but we can go also without that, which we're going to cover a little bit later. And ML.NET supports everything you see here, except for that. So it currently does not support reinforced learning, unfortunately. I love reinforced learning, so I hope we'll have this sometimes in the future. All right, now that I scared you away a little bit with a lot of information, how do I actually start? Well, you start very simply with a scenario. What does that mean? Well, what do you want to achieve with machine learning? Is it maybe you want to figure out whether a tweet is positive or not? Then you go, for instance, for binary classification. Then you want to try to figure out the category of a bank transaction. Then you go multi-class classification. You want to do house prediction. You go regression. You go product recommendation. You go clustering. So you always start with scenario. So you limit the amount of things you need to learn. And there are a couple of caveats. Machine learning, before we move into ML.NET and demos, machine learning won't solve all of your problems magically. You will still have to understand your data. Even though ML.NET is going to solve a lot of problems for you, you still need to understand your data. If you cannot solve, say you look at the row and you hide the label, if you cannot tell what kind of label that could be, then there's a good chance that unless you have a good data scientist behind you, that the machine learning won't be able to accurately predict as well. Then usually what happens is when I'm doing machine learning, it's almost like I'm trying to guide machine learning toward the right solution. So I'm trying to modify the data a little bit, clean up the data, so machine learning has an easier time to learn how to predict the right solution. And start with something simple like classification. Classification, either binary or multi-classification, is one of the simpler ones that I was able to introduce people and they were able to get started. But you can also start with, say, image recognition and stuff like that if you have tools like Azure Custom Vision. All right, now the caveats are away. Let's look at the ML.NET and Model Builder. So, as I said, this can allow you to do machine learning without any prior. And when you're trying to get started with ML.NET, the first thing they ask you is, what is your scenario? And you can see there's a lot of scenario. We have sentiment analysis, product recommendation, object detection. There's a lot of things. And there's a lot more when you go to GitHub samples. And they're adding more and more scenarios almost every quarter or so. So yeah, that the number of scenarios growing. And what ML.NET allows you to do is, if you look at the previous slides, it basically replaces the algorithm. So you don't have to think about how to implement different kinds of algorithms, but you still have to decide for which kind of trainer you want to use for your data. Or do you? Well, this is where ML.NET Model Builder comes in. So ML.NET Model Builder is basically an extension to Visual Studio that works on top of ML.NET SDK. And the main purpose of it is that you don't have to decide what trainer you want to pick. It will pick the best trainer for you. So now we'll have almost no other decision other than what kind of scenario you want to pick to get started with machine learning. And also allows you to do quick prototyping, which I'm going to show you. So first, if you want to install the model builder for Visual Studio 2019 16.6. You will have to start your Visual Studio. You'll have to go preview features, and you'll have to enable here, enable ML.NET Model Builder. Now, if you don't see this option, on Monday, there's going to be a patch 16.61, which is going to fix this. But if you really want to get started today, and if you don't have that, and the workarounds are not working for you, Visual Studio 2019 16.7 preview 1 should work. So you can enable it through that one. All right, so let's go and try to do the demo. But before we do the demo, we need to see how we're going to have from where we're going to get the data and how the data is going to look like. So the data is actually my real bank transactions that was imported to a mobile app. I manually classified this for years, and then I exported that into CSV. So this is the CSV that we're going to work with, and I'm going to use this CSV almost raw. I've removed a couple of things, but basically I'm almost dealing with raw data from my bank. So that's why we're not going to see perfect data, but you'll see that even though I'm importing data directly from the source, we're going to be able to do a prototype. All right, so I am starting off here from the presentation showing you how to get started with model builder, because in my experience, sometimes the demo doesn't work and I have a backup for this. So first, we're going to select text classification for multi-class classification. Once we select that, we have the option to do only locally at the moment, but later we might be able to do it in Azure. So we select that. We then select the file we want to process, and we then select the first one over here is the column we want to predict, and then we select what kind of features we want for those columns. And then we do this training. And the interesting thing is when this training starts, we can see that it actually is dealing with a lot of different trainers. So it tries different trainers, and then it picks the one that has the best accuracy. And we can later use this to try to do our own prediction and see how it works. And here you can change the values and see if it predicts correctly. And if you're happy, you can go at the projects. And this is what you get is 2 new projects. One is the model. So here you have the zipped model, as well as the model input and model output, which is what you need for your applications to be able to interface to that ML.model, and the consume model, which has all the logic to be able to use machine learning. And lastly, you have the console app, which is just a test app, so that it shows you how to use ML.NET. But on top of that, it generated a model builder where you can then use to retrain your model with your data. So you don't have to go through model builder again to generate the code. All right. Now that I did this demo, just in case if the actual demo fails, let's do a live demo. May the demo gods be with me. So one thing that you have to know when you start, you'll have to have a project already running. You won't find it under File, New Project, but you already have to have a project. It doesn't matter what project it is. Then you go Add and Machine Learning. So in case you're having problems finding that, that's where it is. And over here, we treat it with several scenarios. Down below, we have limited scenarios where you have more advanced scenarios that you can check out at GitHub. But we're going to be interested in text classification, just going to do locally. Now here you can also select to be SQL Server if you like to. I'm going to select my unfiltered data. I'm going to select categories as the column I want to predict. And I'm just going to train. So now what's happening here when I'm training is it's going to read the data and it's going to do a 50-50 split. One half is going to be training data and the other half is going to be testing data. And the number that you see here, 84%, is basically saying, based on the training data, when I compare it with testing data, it was okay, 84%. So this gives you a ballpark accuracy of your model. So this might not reflect the real life accuracy, but based on the data that you gave it to it. But you know what? We can improve this with just a little bit of data science. Now, if I go back to the data and look at the table that we have. Now, if you know just a little bit about multi-class classification, what you might know is date actually doesn't help us a lot with multi-class classification. It does help us a lot with regression, since any linear values helps them to have like a timestamp, but not really with multi-class classification, at least not dates. Day of the week, yes. Month, maybe. But yeah, most likely not. So what I'm going to do is I'm actually going to remove date. And previously we had about 84%. We had 84.21%. And if I retrain, now all of a sudden we have 1% more accuracy. And that's because we are removing data that is actually not relevant to our machine learning. So now we're doing data science. Isn't that great? Now you can say you're a data scientist. You removed one column because you understand it's not useful. Now, another thing that I'm going to do is I know that income is 0, so that's not useful. Currency is always the same, so that's not useful. The expense amount and in main currency is always the same, and currency and main currency is all the same. So I'll just remove all of that because that's all not needed. It's going to make your training faster, and you basically deal with less data to begin with. And it might even increase the accuracy because you have less noise. You have more useful data for the machine learning. So right now we see here we have slight decrease of accuracy, about 0.4%. But remember, we have a 50-50 split of data. So there's going to be always a bit of fluctuation of accuracy. But you know what? There is one little problem I have with this as well, with the data. Now, I understand my bank transactions, and I know, for instance, INZ Rewards is my credit card, where online shopping is a debit card. Now, what that means is, if I decided all of a sudden that I want to buy everything with debit cards, the things that were trained against my credit card will suddenly not work well with debit card because it said, hey, this transaction is supposed to be with credit card. So I'm just going to say, no, it's not that category, or I'm going to have it as a lower probability to be that category because you're not paying with the same card as you did before. So that's not really useful, especially if you change your cards or if you switch from credit cards to PayPal or something like that. So I'm going to remove that. And what's going to happen is there's a good chance that our accuracy of the model is going to go down. But I'm happy with that because I don't want my machine learning model to predict what kind of category is based on what card I'm using. At that stage, it's just like guessing, okay, if it's using credit card, it's probably that. I don't really want that. So now I'm quite happy with the data I'm currently using. So I'm going to go to evaluate, and I'm going to play around a little bit with data. So if I'm going to go with predict, you can see it's 93% sure that it's leisure. And I'm going to go to my snippets, and I have here a couple of things. So this one should be home and utility. Let's go this one. This one should be coffee. Well, looks all right, right? Well, I would say yes, but I know there's a big problem with my data. What happens if, for instance, I have a really expensive coffee? It works. It's still sure that it's coffee. Okay. Now it's no longer coffee. Why? Well, all my big transactions are only transfer or reconciliation. So what happens is when the numbers are higher and higher, it now has a bias for transfer and reconciliation because it thinks, okay, it's a high number, so it's probably that. The description doesn't matter. But I know that the description matters more than the expense. I can just go for a really expensive coffee. It's still coffee. Well, the good thing is I actually learned that I don't need expense. I can actually remove it and my model would work perfectly fine. But if you find a similar problem like this, you can basically just try to balance the value. So you don't go too much into extremes. So for my example, I'm going to now also remove the description. Oh, not description, sorry, expense amount. So now we have a nice model where we have only one input and only one output. Nice, isn't it? And it's going to be almost exactly the same accuracy without expenses. So we essentially, from the beginning, we almost sacrificed no accuracy and we removed 7 columns. And this is what data science can help you out quite a bit. But there's also a little problem with that as well. So for instance, if I change the letter a little bit, all of a sudden, it's not the right one. It should be leisure, but it's now food and drinks. Now, this is a problem with my data set, and the model builder has a little bit of problem recognizing that this shouldn't be a category, should be free text. And if you have this problem, what you can do is you can just go to Excel, you quickly go to conditional formatting, you do highlight cells, I'll select this full one, and duplicate values. Now what you see here is there's a lot of duplication. And what that means is the model builder thinks that this description, because there's so many duplications, it's a categorical value. And then it hashes every single value rather than takes it as a string. Now you can solve this problem easily by just going data and then doing, sorry, where is it? Where is delete? Okay, it's a smaller resolution, so I need to find. Okay, so over here, it should be delete duplications. Okay, it's over here. It's a smaller resolution, so the icon got reduced. So what you can do over here is just remove all the description, all of the columns except for description. You press OK, and now we have here that 1900 duplicates have been found, and only 700 unique values were there. So now if I go to data, and I'm going to just load this filtered one, and I'm going to select this one as that. When I train this, now what's going to happen? Takes a little bit to train. Now this is a bit cleaned up data. You'll see that the accuracy has reduced pretty significantly. And that's the reason is because now we have only unique values. If something exists only once, then that data might go into testing, and then it cannot be trained against. So you sacrifice that. So that's why I wouldn't recommend to do that and just call it a day. But what it means now is I can just say Spotify, and it's now 88% sure that that's it. But the problem is, when I retrain a couple of times, it might happen that the Spotify or some other training data might go on the testing side and may not be included in my model, and it won't work. So if you have this problem, what I'm actually going to do is I'm going to close Excel, and I'm not going to save. There's an alternative to this. If you're happy with the previous unfiltered data as before, you can clear all the data, go to description, train it, and we're going to generate the code. Because what we can do is, after we trained and generated the code, we can actually change the type of the column the description is. So we'll do code, add project, save. So over here, as I mentioned earlier, we have the input, model input, which represents all of the data structures that we have as an input. Output, we have the prediction, which is the category, and the score. So for all of the categories, we get a numerical probability. And consume, which is the actual API that you can use in your application. And ML model zip is the actual zip file that we read and use in machine learning. Now I'll speed up a little bit because I might not have a time for a full demo. I'm just going to show you what we get when we run this. So here you can see we're getting prediction category leisure for Spotify. Now what I'm going to do is just to show you a little bit better view on this. I'm going to replace Microsoft output with my own. Did they change? Need to just add link. And I run this. Okay, now we have a nicer view. So you can see here we have leisure, it's 95%. And we could see all the other products. And I'm going to use this example, which should be investment 93%. And you can see how sure it was for all the others. Now, if I change this by just removing, or let's say just changing one number, we're going to still have the same problem where it selects wrong one. To fix this, go to build a model builder. And this is the code that is actually used to train your machine learning. And over here in build training pipeline, we have description as categorical one hot shot encoding. So a couple of friends had the same problem. So that's why I'm showing to you. A lot of people have a lot of duplication in their data and they don't understand why this doesn't work. So what I'm doing here is I'm just changing this description column to be text, featureize text. And this solves so many problems because now it will split up the string of description and it will try to identify each individual string rather than as a whole, as a hash. And to pre-train, what I'm going to do, model builder, and create model. And I'll just return it. So I'm going to just build this and exit it right away. So what we're literally doing is we are retraining our model with the same configuration we had before with model builder, but we have tweaked the machine learning pipeline to be more aligned with what we want. Now, one important thing to do before we rerun this, you need to rebuild it because it needs to copy a new set of ML model into bin. And I'm going to rerun this. And voila, investment. And now it's 99.7%. It's even more sure than before. And to prove you that this actually works with just a little modification, I'm going to remove almost everything. And it's still pretty sure it's an investment. So if you have this problem and you're happy with the data you have, you're just not happy with the decision that it's categorical instead of text, or you have this weird problem where you just change one thing and everything changed, you can still go ahead, generate, and just do a little tweaks. And yeah, with that, I hope you have learned how to get started with machine learning, how to get into ML.NET. You can see that you can easily get started by just importing CSV directly into your Visual Studio. You can tweak your columns to get better results, generate project with ML.NET Model Builder, tweak a little bit the generated code to just get the results you want. In case the model builder, you can't just tweak it enough. And generally speaking, I'm also showing demo, but I ran out of time a little bit. If you happen to have a data set that is less than 100 rows, the model builder requires you to have more than 100. Now, I don't quite recommend this, but you can actually copy the data so many times that you get more than 100. But you know, I've done some simple tests and it works. So if you have a data set less than 100, that's what you should do. And if you want to learn more, I actually have an interview going a little bit more in depth on the data science part for developers in my blog in this interview. You can ping me if you want to have the URL. And I have achieved my goal. I actually have this solution running and it's classifying my bank transactions, and I'm quite happy with the solution. My weekends are now free. I don't have to spend classifying my bank transactions. And with that, thank you.
Thank you very much, JK. That's amazing. Great presentation. You have some amazing feedback here on the chat of this as well. We'll ask you some quick questions here before we go to the next talk here. But we have one question here from OSI that asks, given the example CSV about expenses, how would a model training look like if you like to predict future expenses?
Future expenses. I'm actually not quite sure. But what you would probably do is a mixture between regression and, yeah, you probably would, I would personally do per category or per transaction, and then count when they happen, and then regression could potentially tell me when the next transaction would happen. But yeah, it's a really good question. I would probably look at regression.
And I think there's also something like time series forecasting as well, right? That could help you with that.
Yes, that's correct.
Awesome. And last question here is, let's see, Prashant here has a question. Did the model builder select different models after JK changed the columns that were picked for training? Or did it select the same model every time, indicating that for a given kind of problem, the model selection is consistent?
So that's a really good question. Back in the beta, from 1.1 to all the way, I think, to 1.3, it actually did switch between average perceptron over, and what was the other one? There was another trainer, and it was switching between them, but it stabilized after 1.3. And I believe it's because, if I'm not mistaken, ML.NET is now trying to guess which trainer would be the best ahead of time, and tries to do the parameters better tailored to that trainer, so you always get the same trainer for this particular case. But if you change data significantly, you would get a different trainer.
Okay, great answer. Thank you. Well, thank you very much for presenting here with us today, and the community, I think, really appreciate that. Thank you so much for the late evening, and I hope it wasn't too much of trouble. And yeah, coming up next year in just, I think, 8 minutes or 9 minutes is the Q&A session with a Microsoft data scientist. Justin will join us shortly, and he will answer all your questions. So definitely put them in the Slack community channel here, questions to data scientists, or start posting them in the chat for Twitch and YouTube. And we'll see you just shortly. Thank you. All right. Well, welcome back, everyone. That was quite a talk from JK there with introduction to machine learning and ML.NET. So that's awesome. But with us today now, we have Justin Ormond here from Microsoft. Good morning, Justin.
Hello. As an intro for myself, data scientist at Microsoft in the AutoML team. I was previously managing data science for ML.NET and the predecessor product called TLC, which was the internal variant of what we have released as a awesome product for .NET developers.
Wow, that's great. So you're actually a real data scientist.
So I'm told.
So I'm told. That's awesome. Well, I know it's early for you there. I think you're in Seattle, right?
Oh, I'm in Silicon Valley. Yeah, it's
Okay.
same time zone as Seattle, and it's a very good place for any type of development. There's a lot of fantastic data science meetups in this area to go to. Seattle also has quite a few too. And today I'm very happy to be answering any questions that anyone has. Please post them in the chats. There's a couple different places for it. There's Slack, and there is on Twitch also, and also YouTube if you want to post on there.
Yeah, we have tons of them already, so I won't waste so much time yet. And anyone who wants to have any questions to Justin, just as Justin said, post them and we will try to get to them. But we got quite a few, so we're going to get the conversation going and kind of see where it takes us, right? The first one we have here is, do you think reinforcement learning will ever make it to ML.NET?
I'm not sure if it's reinforcement learning is very good for, say, solving a particular game. Reinforcement learning is very good for a lot of tasks, but MLNet is more focused on what's important for the most common scenarios along machine learning. And reinforcement learning doesn't solve most of those tasks as quickly or sometimes as well as some of the more traditional techniques, like just standard classification. Reinforcement learning isn't generally the answer for a lot of the questions being asked in ML.NET. But you can ask inside of the repo. If you find a use case that's important and there's enough support for it, it'll get built.
Absolutely right. Well, thank you for that. John?
Yeah. Actually, want to do my first question as a question I personally have for you, Justin. How did you get into the data science field in the first place?
Oh, that's a long stories here, but a lot of my graduate work was in machine learning topics. For instance, computer vision topics of how to locate where a cell phone is based on what the camera sees. So for instance, you could hold up your cell phone and recognize what's across from you. So recognize the building across the street from you versus, say, a Google Street View image, and use that to geolocate the phone. I was also doing a bunch of other topics within grad school. This was like 10, 15 years ago topic. And then I hopped into Bing as my first full-time job. There's a bunch of ranking work in that area, which is all machine learned ranking, which MLNet does support, by the way, and is the product that was being used then inside of Bing for doing ranking. There's FastTree, which is in MLNet, which is one of the primary things that was used inside of Bing for making ranking models. I can go as long into depth here, but we should probably.
Well, that's very fascinating. That's interesting. Well,
some other questions here.
Yeah, thank you for sharing that with us. We can go to the next question here, which is a more technical one, and that is, how does AutoML find the right algorithm?
Oh, that's a fun topic. So what it's doing right now is it's looking at your data set. It's deciding how to split your data set. So for instance, is it a comma delimited file? Is it tab delimited? It looks at your columns. It tries to decide what the purpose of every column is. So for instance, do I think this is a categorical text column or a free text column, which the last speaker got into slightly. It looks at numeric columns, whether or not it has to fill in missing values. And that goes on towards the model selection part, which is the actual question. So right now it tries the defaults on top of the featurized data set. for every different model of that class. So for instance, if you're doing a regression problem, it tries the defaults on top of the feature vector that created previously. So that's about 12 model types for regression. It will go through each of those, decide, check how good each does. It will call those to the top 3, and then go on to hyperparameter selection. So it uses a Bayesian optimizer called SMAC, which is a well-known algo. So it does an exploration phase of the hyperparameters, and that goes into the Bayesian phase, where it then uses the knowledge it learned from exploring this multidimensional hyperparameter space to hone in on the areas of the models, which models are best, and which hyperparameters, what areas of the hyperparameter space are best for it to explore. And it selects the one model that did best on the validation data set. Sorry, that was a rather long, in-depth answer.
No, that's very fascinating. I mean, I think that's something. AutoML is something so simple to use, right? But it's fascinating to hear how complicated and complex it is under the surface.
Yeah, and it's all open source. You can go look through exactly what it's doing in the MLNET repo.
Awesome, yeah. And I think just a related question to that as well is, can you apply AutoML to deep learning models?
Oh, certainly. Right now, we're only using it for the image classification part, where we're using a TensorFlow model. Right now, that one is trying for local mode. It's trying, I believe, a ResNet 50 model or a ResNet 101 model. If you're doing the remote scenario, it's using a more advanced recent model, SE ResNext. For the multi-class classification case, the nicety about the remote case is that you don't have to have a GPU locally. So you can spin up an Azure VM that has a strong GPU behind it, and it's then powered by Azure AutoML, which is the same product as AutoML inside of ML.NET and developed by the same team. So they're the same products in a different form factor.
Okay, great.
The ML.NET one is for the .NET developers to use directly, and through Model Builder you can use the remote mode, which lets you scale out once you get towards bigger data sets. You can handle all your millions of images if you want to run a very large job.
Cool, that's awesome.
Yeah, it's interesting. Let's see, I got one. I think we hit on it a little bit in the workshop yesterday. But what's in the ML.NET model files?
There is your feature engineering techniques in a trained form. So for instance, you did a text classifier. Inside there you have a step for tokenization. You have a step for normalizing the word, so lowercase it, whatnot. And then you have a dictionary of all the words, so you know where to map it from the word cat into slot 5. That information for the feature engineering is stored in the model itself. And then the model, what most people consider a ML model, is the actual final algo in the pipeline. For instance, your trees or your linear model, the weights for that is stored within the model itself. So it's meant to be a little more self-encapsulated of a model than some of the other model storage formats, because it also includes the feature engineering. The only piece that's not inside there to make it fully end-to-end is the data loader. That was a decision that allows users to now export their model more easily. So for instance, you might want a slightly different loader when you run the model than when you train the model. So we no longer store the loader within the model itself. For instance, you could train it on a flat file, but then you run it live from, say, a web service or connected directly to a database. So the loader function is going to look different.
Okay.
You can zip them and look at them. You'll find if you hone in on biggest files in, say, a text classification, you'll see all the words that it has used. You can also look at the weights in there. You can look at how the normalizer gets added, what is actually behind the scenes in your model. It's really quite interesting if you dive into it.
Yeah.
Yeah, I'm going to have to do that.
That's fascinating. Well, another question we have, we'll jump back into non-technical questions here, is what does the life of a Microsoft data scientist look like? What is your day-to-day work, more or less?
That's a very interesting question. Data science topic is very widely defined as different tasks. So in some areas, it's more of a data analysis style. Some it's the ML training. Some it is the people that make ML tools itself. I am closer to making ML tools myself. I focus on making sure that our team is making a useful product for the users. So that's handling some of the benchmarking sides to decide what areas that we need to invest in further, what techniques are useful for us to try, deciding what data sets are representative of our users to be able to test our systems against actual user style data sets. It's a wide topic, and on a given day I'm doing many different things.
Cool. That's fascinating, though. It's good to hear your perspective on that. John, do you want to jump into a technical question?
Actually, I got another non-technical question. Let's see. What do you think about the current growth in data science university programs around the world? And do you think they produce quality or just churning out degrees?
Oh, it's fantastic. So people now have a background in AI ethics, like what was being discussed earlier today, which I'm incredibly happy that people are starting to get into. It also gives them a very good background on what target leakage is, which is a problem that a lot of people have, where they, for instance, have an extra copy of a label column and they don't realize why their score is very high. That's a topic we should get further into later. It's a very in-depth, interesting topic.
That's great. Thank you for that. So a more technical question here. Bias is in general a bad thing in data science. But what about if you want to introduce bias by purpose? For example, I know that my feature is 3 times more important than other features. If I don't normalize, it's bad for the rest of the features. If I normalize, I'm losing the intentional bias previously mentioned. How do you deal with that situation?
The models will generally learn around the bias anyway. So if you try and just scale up a single column, it won't make much of a difference. But what you can do instead is find examples within your data set and apply a weight column. What that does is it says this row of data is worth, say, 10 times as much as some other row of data. So for instance, if you have a high label skew where you have a column, you have very few examples of label 1, but you have a lot of examples of label 0, you may want to apply a weight column that makes your label 1 rows worth 10 times as much. And that applies both to the model training steps, the featurization steps, and the metric scoring steps. And that will upweight those specific examples.
Okay. I think we actually have a question similar to that yesterday as well in the workshop, which is good.
Yeah, we did. It was very good questions in the chat yesterday, and hopefully we can keep those going here.
Absolutely. John?
Yeah, so you mentioned leakage. What are some other kind of gotchas that are pretty common when doing training?
Well, one of the most common ones are people, there's a lot of different types of leakages. One of the most common ones are people trying to pre-featurize their data set before they split their data set. So for instance, they'll learn a normalizer before they split their data set. What you always want to do is learn your feature engineering on top of your training set and then apply it to your validation and test set. Otherwise, you're feeding information between the different folds or splits of your data set. And that artificially increases your score. So let's assume that you're trying to guess what the price of something is, and you have a column that has, say, the sales tax on a house. That would be a direct example of a leakage. because you can just multiply out the sales tax to get the label. But there's slightly more insidious forms when you split it that you wouldn't notice, because you can normalize a column and you know what the average of the values are for the training data set. And then for the test data set, you can go back and then calculate based on what was normalized as into the how the test set would have, what the missing values would have been to get that normalization factor, or the model can figure that out. That's a rather weak form of leakage that can be a bit insidious and hide within your training process. AutoML is nice because it will help you avoid all these, because it instills within it best practices. So it will know to learn your feature engineering only on the test data set and apply it to your validation and test data sets, so that your scores are representative of how your model will actually do in production.
That's good. Perfect. Thank you. Another question we have here from the chat here is, do you think that GANs and style transfer will make it into MLNET, or should we stick to other deep learning frameworks for those tasks?
Well, what you can do inside of ML.NET is take one of the pre-trained ONNX models and use that as a step within your ML pipeline. So you can take a GAN model from the ONNX model zoo and run it within ML.NET. And then you can launch your model the same as you would with any other MLNet model inside of, say, a web service if you want to host a really cool service and show everyone how to do style transfer. It's an elegant way of doing it. For training a GAN model, I'm not certain if it can be done currently. I think the TensorFlow model can learn a GAN model, although I don't know that anyone has explicitly tried it. Please try and send feedback and tell us if it works.
Exactly. Well, I think the question, Gregory asked a question. Let us know if you make it work or not. We'll be interested to hear more about that.
Yeah, and send feedback into the GitHub repo, either the MLNet, github.com/.net/machine learning, or the machine learning-model builder for the model builder specific topics.
Absolutely. All right, John.
So question here, what compelling reasons do you see for data scientists to choose .NET or ML.NET specifically over like scikit-learn and Python or something similar?
Oh, that's a really good question. So one of the primary determinators is whether you're under Python or .NET. .NET developers, ML.NET is the best answer for .NET developers. There's a lot of advantages to ML.NET over Scikit itself. For instance, speed, memory utilization. It can handle very, very large data sets. I've run terabytes of data through it. This has been hammered on inside of Microsoft for more than a decade at this point. It is a rather battle-hardened product, which is why we put out a pretty strong release long before the 1.0, because this was a decade in production beforehand. So it's calling it a 0 point was mostly pulling punches until we normalized the API surface. We didn't want to call it a 1.0 product. It wasn't because the underlying code was unstable or not good. It's just to stabilize the view of the code.
All right, awesome.
Scikit is nice. It has a very good Python interface. So if you're primarily in Python, you may want to prefer Scikit. But there is Nimbus ML, which is ML.NET for Scikit, that offers a Scikit interface. So you can switch from Scikit directly into Nimbus ML, which is then backed by ML.NET. And it's a couple line code change from your Scikit product.
Interesting. I didn't know about that. Thank you. Another question we have in the chat here is, do you often see decision makers come to you to ask specific questions about available data and disregard your insights if they don't like the answers?
About available data. Normally, like the data that they have available, I'm not quite certain on what the question is in this case.
Yeah, we can move on to another question. And Gregory, if you want to clarify that question, please do so in the chat, that we can ask it a bit later as well. I think I'm going to ask Praveen's question instead here in the place of that. A DNN model's validation accuracy is one aspect of validating it. There are other ways to validate it, such as grad cam, that allows to visually check where model is looking. When shall we see such features in ML.NET?
So model explainability is a very important topic. Within MLNet right now, we have PFI, which I believe Bree touched on slightly yesterday, along with the feature contribution calculator. If I recall, the one that you mentioned is a image explainability that is a local image explainability that will tell you about why it's selected a specific class for a given example. That's closer to the FCC model, FCC algo that we have in ML.NET. Specifically for images, we don't have a explainability hooked up to it currently. We will do that for the remote case. I expect that to come out first. I don't know if we currently have a plan for the local explainability for images. We haven't gotten too far into that topic yet. The remote case, though, the explainability for images then would run through an Azure service that is probably going to come out first, although we don't have a timeline for this so far, and that work has yet to be scheduled.
Okay.
But it's an important topic. You should know that your models are choosing the class, even if it chooses the right class. You want to know that's choosing it for the right reasons.
Absolutely, yeah, definitely important. And I think I guess I feel like we hear more and more about that every day, about how important that is.
Definitely.
John, do you want to ask the next question?
Yes, let's see. Here's an interesting one, especially since we just had a talk about Model Builder. How long should I train for Model Builder or in the CLI?
Another great question, and it's a hard one to answer. So one thing that you can do is run for a short time once. So try 30 seconds, try 10 minutes first, depending on the size of your data set, and see how long it takes to make a model. What's going to try first, for at least the multi-class classification case, is average perceptron that is often the winner. That's a linear model that tends to be faster, but you can use that as a basis for how long you should train. You want to aim for about 150 models total, which gives a Bayesian optimizer time to locate a good position in the hyperparameter space. Because what it does is first the random exploration of the space and then drops into the Bayesian step around model about 70. And then from 70 to about 120 is when you get most of your final gain. So it starts to plateau at that point. So about 150 models seems to be the optimal point. So you can see in the output how many models that it tried inside Model Builder. In general, more time is better. But you can, of course, just make one model, and maybe that will be good enough for you, depending on your use cases. Plus, it will toss out the code for you also, and you can dive directly into the MLNet portions from there.
Yeah, which is very nice. It's a good seed, I think, for future development and exploration. So a question we have in the chat here, Justin, I think that you may have seen as well before, is that Scombra asked, is it really a split of 50-50, not 70-30 or 80-20? And I think referring to the AutoML split, I think.
AutoML right now, by default, chooses an 80-20 split, although it automatically goes between cross-validation and train test depending on the size of your data set. Right now, I believe we have the cutoff around 15,000 rows of data, at which point the train test is less than... The train test gives you an accurate enough score. Right now, for small data sets, cross-validation is important to run because it reduces the error bars on your metrics such that you can have confidence in the metrics that it's producing. If you have too small of a data set for a train test mode, you can be dominated by noise instead of what the actual metric value is. Cross-validation gives you both the error bars and it gives you confidence in that you're reducing the error bars by repeatedly doing the cross-validation step and trying different folds of the data and averaging across.
So would you say that cross-validation is recommended to use even for larger data sets?
It depends. The value goes down as the size of the data set goes up. But what it can always give you is a confidence on top of your data set. Producing, say, a 95th percentile confidence interval gives you error bars on top of your on top of your metric. So you know that in production your model will perform within this bounds. A trained test score doesn't give you that. It just gives you a score. You don't know how much that score is expected to vary.
Mm-hmm. Do you get those metrics as well from the metric, I guess, output from cross-validation? I don't think I've actually inspected it too much.
You would have to run inside of the API, and you'll have to then push the scores into. There's a class in MLNET. I think of what it's called. That is a cross-validation metric score that calculates confidence intervals for you. You can place your metrics. You can push every metric returned into that object, and it will tell you the confidence scores back.
That's great. I have to check that out myself. All right, John, do you want to post another one?
Yeah. I'm actually curious about this now that I saw it asked. How is Azure AutoML related to AutoML and ML.NET? Because I think those are two different products, right?
They're in essence a singular product for the AutoML side, developed by the same team. The MLNET AutoML was coded by people in the AutoML team to be another variant of what is run in the remote scenario, except it runs, of course, locally to your one machine and is in .NET also. The Azure AutoML is how you'll scale up your project. So you want to run locally, and then it allows you to move to the cloud, and that offers all kinds of extra advantages. Some of them are more related to corporate usages. So for instance, it offers lifetime track of the model, who trained it, when did they train it, what was it trained on, some of the important pieces that corporations very much need to track. It will also offer ability to retrain a model easily, data drift detection, offers explainability, those kind of topics that aren't available locally at this point.
Oh, that's interesting.
Perfect. Yeah, thanks. Another question in the chat here is, are there any good code example of transfer learning with ML.NET? Want to take a pre-trained open source model and do transfer learning on it with MLNet?
That's another fine question. So right now, that's already done for you automatically in some cases. For instance, in the image model, that's using a pre-trained model learned on ImageNet. It's a very large data set that's well known across the ML industry. And for images, it learns how to recognize 1,000 ImageNet classes, like different types of cats, dogs, cars, whatnot, and then uses that to fine-tune. That model is then used to fine-tune a model specifically for your data set. Another example with an MLNet is a word embedding that's available. So that's learned on a large text corpus, where it has learned what different words mean, and it doesn't have to relearn it for your particular case. If you want to do that yourself, you can also import a custom word embedding model. And for the image case, you can use Onyx as to run your custom image model and use that as a featureizer. You could also use it to refit to your new data set if you want to refit instead use as a featureizer. There's a couple more examples, but we should probably.
That's great.
So I got one from Zal. Which ML model should I use for something like autocorrect or spell checking? And would you need a custom model for Unicode-based language?
That's a hard question. It depends on how you want to pose that as a machine learning task. I have not built a spell correction model myself. Perhaps you could pose that as either a ranking problem might be the most sufficient. I was thinking multi-class would be an interesting way to go, but a ranking class would be a lot more scalable. Multi-class won't scale to the number of words. So you're going to have issues with that. You'll end up with an enormous model, and it'll take a long time to train if you do it as multi-class. Another route is as a binary classification of misspellings on the left and the correct spelling, correct or incorrect correction on the right. That may also do well. Your feature engineering techniques are going to become even more interesting there. The default tri-charactergram may do quite well on that.
Interesting. That's a great answer.
Some custom featureization in there also. It'll be very, post the question in the repo. I'll answer over there and we'll see if we can find a good answer for you.
Yeah. Awesome. Yeah. So I'll definitely post that in the repo. I would love to follow that discussion as well. All right. We have another question here. And this one is, how do you see AutoML and data scientists working together?
The nice part about AutoML is that it can take a lot of the workload off of data scientists. So a lot of the work in data science is the iterative process of trying a bunch of different feature engineering techniques, analyzing the data set, trying to try different models, different hyperparameters in the model, and they can accelerate that process extremely quickly. So for instance, in one of the previous talks, you saw the enabling and disabling of different columns. Behind the scenes was still the sweeping process that AutoML does. So it was accelerating the process that we saw before by just allowing the data scientists there to easily add and remove the columns and see the effect of it, including the sweeping process that AutoML does. It also allows a data scientist to learn novel techniques, what works well on their data set. So you can just toss AutoML and see, well, this gets me extremely close to a good model. Now I can use that as a kickoff point to make an even better model by hand optimizing it after AutoML outputs the direct source code for making that model.
Great, thank you.
Yeah. And speaking of some feature engineering, what type of feature engineering will be most useful in ML.NET? I know we saw some dropping of columns, but are there any other techniques that we can use?
Well, for basic types, AutoML will output the code that is suitable for your data set. Right now what it uses is mainly n-grams. That defaults to bigrams and tri-charactergrams. For categorical columns, you can use standard one-hot encoding. For numerics, you normally want to normalize that. And there's not much that you have to do with most numbers besides fill in missing values. For categoricals, there's a bunch of interesting techniques to try. There's one that used to be called Dracula within our repo that does counting, which is why it was called Dracula. I decided to rename it to something a little different. I believe it's called target encoder because it's a form of target encoding. There's really advanced techniques that you can try within MLNet beyond just the basics for yours. So one really fun thing that you can try and is quite useful is training a k-means model on your numeric data and using that as a stacked model within a bigger pipeline. So what that does is it learns to cluster your space of numbers here and uses the output distance from the centroids of every one of those clusters as a new feature into your final model. There is so many very interesting ones. There's one called tree featureizer, which is another form of a stacked model. So you're learning a tree for all your data, and then you're using what leaf node the current row landed in as a new feature. So you have, say, 100 trees. You're going to have 101 ones inside of your output vector from the tree featureizer, plus a bunch of zeros that current example didn't land in. What that allows you to do is learn a subset, a tree on a subset of your data in a very, that allows it to learn the interaction between the different features using a tree. And then you can scale up into multi-terabytes of data by feeding that tree that was trained on, say, 10 gigs of data. And then you can stream through that tree into a linear model that can relearn the output weights on the tree. And then you can run multiple terabytes of data through that model, which wouldn't otherwise be doable with the tree itself.
Great, thank you. Kind of following along the same lines a little bit here, how can I handle text in MLNet?
Well, there's a few ways of handling text. The most common way is running it through the text the text featurizer, and that does a bunch of sub-steps behind the scenes. For instance, it will tokenize for you. It will remove diacritics, which are like accent characters that you see on top of like the accent characters on top of, say, Spanish text. It will remove that and normalize the text. It will, by default, lowercase for you. You can also use it, have it remove stop words for you. And then it will create, by default, bigrams, which are pairs of 2 words next to each other, and tricharactergrams, which are a sliding window of 3 characters in a row. The 3 characters in a row method helps you a lot for out of vocabulary issues. So for instance, let's say in your test data set, there is the word running, but in your training data set was only the word runner. If you used only n-grams, you'd only know about the concept of running or runner, and if your test data set had running, it wouldn't have any basis of that. But the tricharactergrams would extract the RUN portion of that and learn a weight for the RUN as a concept of a person moving quickly, as opposed to having to individually learn the words. There's also the word embeddings within ML.NET that is, like we mentioned before, a method of transfer learning where you have this big corpus of information that was used to learn what every word means. There's also an external project that was kind of interesting that I saw, that someone made a BERT model for ML.NET. That's an interesting one to look at also. That is going to be incredibly slower, but BERT is what is taking over the world, the different transformer models. That's something that we should consider pushing into ML.NET proper. Right now, there's an external project of someone demonstrating how to do it, which is super cool that we get external people doing really impactful things like this. These are things that should be contributed back into the main repo. They're fantastic.
Awesome. I think, John, do you want to ask a question that's kind of following along the same lines there?
Actually, you just answered it. If we can use BERT within ML.NET.
Yeah. Someone made a fantastic example of how to do it.
Yeah.
What's the repo address, or like who's the user?
Oh,
let me go look up quick.
I think we can put that in the chat real quick for anyone who's
curious. And I guess while you do that, are there any other?
Just look up BERT-MLNet.
I will do that, and BERT-MLNet. Okay, and then I will put that in the chat.
Yeah, it's so cool that somebody built that. The hardest part on there is actually building the tokenizer, because BERT uses really interesting, novel tokenizer that does sub-token matching when it doesn't know the word. It's novel in its interest, and the code for that is a little more complex than our current tokenizer in ML.NET.
Awesome. Let's see. We'll find it later, and maybe you can put it in the chat after your session as well, Justin. Oh, we got it. Thank you, Louise, I think. Awesome. Hayan Vlot. All right, perfect. So a question I have personally as well is, do you have any suggestions or recommendations for, let's say, .NET developers out there that have been developing software engineers for the whole career and then want to transition more into the machine learning space here and are fascinated by MLNet and wants to start using it? What are some things I need to do and think about to get there?
Oh, certainly. There's a lot of people transitioning that route. Like, I expect machine learning is one of the core things that get taught in comp sci these days. Back when I was doing these courses, darn near 20 years ago, it wasn't a primary focus of the comp sci world. It certainly was around, but it was less upfront than it is these days. What you should do in ML.NET is just start playing with it, start using it, start running through some of the examples. Pull open Model Builder, run it through a dataset, run on Kaggle, see how you do. With MLNet, with the CLI and with Model Builder, it will make the full training pipeline for you in code, so you don't actually have to know the data science behind machine learning. You don't have to even know what to try. It will make a full pipeline for you, and then you can use that as a learning stepstone into machine learning by seeing what it produced for your data set. And then you can work back on why it shows that type of feature engineering, why it shows that type of model, and use that to learn machine learning itself. One other thing about BERT is as Model Builder adds remote classification for non-images, Azure AutoML does use BERT in the background. So that will become alive for the remote scenario as soon as Model Builder adds connectivity for training on standard tabular data sets instead of strictly the image classification. So you can then do text classification within Model Builder through the Azure Remote Mode, which currently has, Azure AutoML has BERTs backing it, because it does extraordinarily well. It is what the state of the art is currently.
Fascinating. Yeah, great. Thank you for the answer.
Let's see.
We just got another one here from Jeremy. Do you want to ask that one, John?
Let me find it. All right. Is there a good resource for learning simple data science that help us clean up data based on the scenario that we're targeting, such as product recommendation or binary classification?
Is this more focused on the data cleansing part, or just how to set up a start making a model itself?
I think the data cleansing parts.
Oh, that's a really deep topic of how to best clean data. A lot of it you may find is it's important to have clean data, but you should just test if it works first. Sometimes really dirty data, you can still make an extraordinarily good model on top of. Machine learning is meant to be robust to this, and over the last decade, we've made MLNET rather robust to having dirty data be fed in, because around Microsoft, people, of course, clean up their data, but some people don't. So we need our models to be optimized for both scenarios. But generally, just open your data set, look for the columns you want to see that everything is aligned properly. So some of the big things that can go wrong is, so some data sets you will have a misalignment. So when you export it, you had, let's say you're pulling together multiple files. A lot of cases I've seen is misalignment in the data sets. So one span of the data set had 10 columns, another one had 11, and it just directly got joined together and concatenated. You'll see examples like that in the wild, like the New York taxi data set is wildly shifting around in the number of columns if you directly append the different types of the New York taxi data set. There's all kinds of data quality issues that you always run into, and upfront you have to spend a lot of time just ensuring that it is correct. But if it's reasonably correct, just toss the ML at it and see how well it does. If it doesn't meet your expectations, go back, fix things. Data science is an iterative process, and data is always dirty. That's the nature of it.
Awesome, thank you.
I've actually noticed ML.NET is they can handle when you feed in missing data. If I do the same thing and scikit-learn, it's just going to yell at me. So.
I had a similar experience actually when I started with ML.NET, and I had the same data on scikit-learn and MLNet with just the defaults. And scikit-learn threw out of memory exceptions and never got me anything. And MLNet was done in 20 seconds and with a really good model.
Yeah, we have a whole paper on the topic from, I believe, KDD last year, showing how MLNet scales better than scikit. And that's because internally in Microsoft, we had to. Big data sets are the norm inside of Microsoft. People aren't coming generally with the 100 rows of data. They're like, oh, here's 10 gigs, here's 100 gigs. Oh, I want to run a couple terabytes through. We're like, okay, go ahead.
All right.
On both the high end and the low end, because it's quite varied in the use cases. And we've spent a lot of time optimizing defaults and choosing, say, defaults on what the text classifier, the text transform will do, what the defaults are in the models. We've spent a lot of time optimizing so your first run is good. This is how the AutoML that backs it is also good. It's standing on the shoulder of giants.
Awesome. We'll get some questions coming in right now here. So a user says, heard about turning NLG. can that model be used in any way with ML.NET? Turing.
I'm not aware of that model. I'm sorry.
Okay, that's fine. We can ask another question here. How are dates and numbers treated in ML.NET? How does it know what the date is?
So there's a datetime type within ML.NET. So you can use that as your import. So in your input class, you can have a type of date time. And then what you do with it after that is you feed it to the time date transform. That was added, last few months. Previously, we didn't have any external way of handling dates besides the custom mapper. But what that does is it produces the time of the day of the week, the day of the year, the month, the date, and splits up and featurizes dates and times. It's very proficient, especially for time series forecasting is one of the more important areas for that. There's also some gotchas in the territory. For instance, you don't want your model to learn that last year the value is high, because then your model won't generalize to next year. It will learn that in 2019 that more oranges were sold than 2018, and not necessarily be able to generalize. So it can be useful to not include, say, the largest time value within there. Something to try. Try and remove it, see if you get better on your test data set. Also, it's important to split up your time series data sets on time and have the newest in your test set and the oldest in your training set and the middle part for a validation data set. It goes back to the topic of leakage. There's a fine Wikipedia article on machine learning leakage. It's a good thing to read through. I use Wikipedia as my scratch pad for ideas. So look up my commits on Wikipedia and you'll see a bunch of machine learning topics I'm interested in.
Great. John, did you ask? I think we can have a last question actually right now before we have to hit the next topic.
All right. Let's see. How does AutoML handle outliers and missing values?
So the outliers are handled pretty nicely by trees, and also in your test data set, the outliers will affect the linear models pretty much, but the trees are very robust to it. So the AutoML will hone in on the trees that are more robust to it by running through the test set and measuring the difference between the expected score and the actual score based on the test data set and the metrics that produces. It will hone in on the models which are more robust to outliers, so it will generally avoid linear models and go, like I mentioned, more towards trees. For missing values, it automatically AutoML will fill in with the NA handle transform, which will, for numerics, I believe it auto-fills with a 0, which works well for both linear cases and for trees. Another thing that you could do manually is before the data comes, you can add prefeaturizers. If you're using the AutoML API, you can add prefeaturizers to custom handle it. So for instance, if you want to prefill your values with, say, the average value, you can append that as part of the API call where you tell it the transforms that you want to be run before AutoML appends its own featurizers. Another piece that is in AutoML is it does, along with the imputing, it also does an indicator column to say, hey, this value was missing, which can be important of its own.
Awesome. Well, Justin, thank you very much for answering all those questions. That was a lot of questions in 15 minutes.
Yeah. Any more questions, feel free to post in chat. Feel free to drop on our MLNet repo and try out the remote scenario of Model Builder.
Yeah, absolutely. That sounds great. Thank you, Justin. And what we have coming up right now is actually an interview with Michael Gerfen, who is using ML.NET within his organization. So definitely stay tuned for that. And on the full hour, in just 10 minutes, we're going to have Luis Beltran presenting on transfer learning for deep learning from custom vision to TensorFlow and ML.NET. So that would be a very interesting and fun talk to listen to. So definitely stay tuned for that in 10 minutes. But for now, thank you so much, Justin.
very, very happy to assist people here. Thank you so much for letting me.
Thank you, and enjoy the interview.
Thanks. Bye.
Mike, thanks for agreeing to do this interview with us. If you don't mind, can you just do kind of a quick introduction to yourself and what you do?
Sure. Yeah, my name is Michael Gerfin. I'm the founder and executive partner for Evolution Software Design. We were founded in 1995, so we've been around for a while. Real small, kind of boutique software shop, but we have some fairly large customers, you know, CDC, ACLU, and then a bunch of smaller customers in various industries, anywhere from e-commerce to healthcare to agriculture. And you know, we generally get hired to either fix really nasty problems that are already existing or to solve really hard problems, you know, in the field. So, and that's kind of with this hazelnut monitor, you know, I have a business relationship with my father-in-law who is pretty big in the hazelnut industry, and that's how we got pulled into this project.
Oh, cool. So I guess that's a good segue. How are y'all using MLNET in your projects?
Yeah, so we're using it to predict the moisture of hazelnuts in the commercial drying process. And historically, the drying process has kind of been error prone. A lot of people who do it and have been doing it for a while, they'll stick their head in these huge commercial dryers, and if their glasses fog up, they know the nuts aren't quite ready. If they don't, well, then maybe they are ready. So the reason that it's important to get the moisture right is if you don't dry well enough, you get spoilage during storage. If you dry too much, you're losing money. And so what we're trying to do with ML.NET is predict that moisture. And there's all sorts of variables to take into account. The type of hazelnut, the location, the weather, the temperature, the humidity, all these various things. And the weather plays a big part in it because the nuts fall on the ground, and so they can absorb moisture if it's a wet year, or they can dry out if it's a dry year. And so from batch to batch, you just don't know. And they're mixing large quantities. So each one of these dryers can hold 50,000 pounds of nuts. And they're coming from all different farms, all different locations. Some growers will wait till the end of the season to bring their nuts to be dried. Some do it throughout the whole process. And it's a short season. It only lasts 6 weeks. So, you know, from year to year, especially in Oregon, the weather plays such a big role in the quality of the hazelnuts that are produced here.
Interesting. Me having glasses, I definitely know about those things fogging up.
Yeah, definitely.
Yeah. So what made y'all choose ML.NET for this project?
Well, we're pretty much a .NET shop. And, you know, to be honest, when we first got started in this, I knew very little about machine learning. And so I was really pleased when I saw ML.NET was in beta. We actually started with 0.3 release, I think, with it. In the first year was we actually went on the 0.4 release, and so it was a nice entree into machine learning, and the fact that it was based on .NET and C# made it really easy for us to integrate it into our solution.
Yeah, that's interesting. So ML.NET actually made it real easy to put that machine learning into your product.
That's correct, yes.
Oh, cool. What was the impact that ML.NET had on on your specific project?
Yeah, well, we were able to go from having very little experience with machine learning to having a fully trained model in a very short amount of time. In that first season, like I said, we only had 6 weeks. And so we had a fully trained model within the first week of data collection. And then it just started to improve as we got more and more data. So, and we've gotten within 3% of real moistures, you know, and so while it's close, it's not close enough yet, you know, and so we're going to need a couple more seasons, and probably another 3, I think, until we have enough data to make everything kind of smooth and get close.
All right, cool. Be interesting to hear how that goes.
Well, I'd love to share the story. It's been a really fun project, and it's kind of neat to bring technology to agriculture, which is, sometimes can be on the cutting edge, but a lot of time it lags. And so being able to bring a modern framework and solve a real world problem has made a really, really neat project.
Yeah, it sounds really neat. So now that you've had experience with ML.NET for a while, is there anything missing in it that you would want, like in the future?
In terms of the framework itself, no. For my own personal perspective, more resources around understanding which algorithms to use, those sorts of things would be helpful to me. The examples that were available at the time we started this project were very helpful. So any of those sorts of things would be, I think, a really good addition. Especially things that are closer to the real world. So, for instance, we chose the regression algorithm, fast tree regression algorithm, and based, some on some research, but also, the sample. There was the taxi fare prediction model. Yeah, and so that, that certainly was a great way to learn about regression algorithms and choosing that algorithm.
Yeah, cool. It's nice to know the samples are helpful there.
Definitely.
All right, welcome back, everyone. That was a great session with Justin. Thank you very much, Justin, for answering all of our questions. I had a lot of my own answered, honestly, which is great. So Justin is still on the chat on Slack. So if you have any questions to him, definitely post them, and I'm sure it will help. But now with us, we have Luis Beltran here. Hi, Luis.
Oh, hi, Alexander. How are you doing?
Good, good. We're awesome. We're so happy to have you. And you're calling in from the Czech Republic, right?
Yes, exactly. I have been here for the last 5 years. I'm from Mexico, but I am been studying and doing research here. And yeah, it's a great country to live in.
Awesome. And you're pursuing a PhD, is that correct?
Yes. It's a PhD in engineering informatics. The topic is actually deep learning and face recognition, face detection. So all about TensorFlow and Python, and yeah, that's my. I ate that for lunch.
Wow, so you're an expert on this topic. This is fascinating. That'd be great. And in addition, you're also a Microsoft MVP. That's correct, right?
Yes. In AI and developer technologies, I love, let's say, mobile applications. So that was my first one, and also. I have been studying about ML.NET and cognitive services, custom vision. So yeah, it's also helpful for acquiring experience in AI.
Oh, that's great. Well, I'm really excited about your talk, and I'm sure the audience will be as well. And as always, everyone, if you have any questions to Luis here, just post them either in the Slack channel, or you can post them on Twitch and YouTube, and me and John are going to moderate them afterwards. But I don't want to take any of the time away from you, Luis. I'm really excited to hear this. I'm sure John is as well. So yeah, the floor is yours. Take it away.
Okay, thank you very much, Alexander and John. So also thank you everyone for joining this presentation. I hope that during the next hour you will learn a lot of things that maybe we can transfer this learning from this topic to you. So yeah, just contact me or send me any questions, and I will do my best to answer them. So the topic today is transfer learning for deep learning, TensorFlow and ML.NET for the ML.NET Community Conference. I'm quite happy to be here. As I was saying, I live in Zlín, which is in Czech Republic, and I enjoy everything about mobile applications, especially with Microsoft technology, AI, and also cloud technology. Here in this slide, you have my email and also my Twitter handle. So feel free to contact me with anything about the topic or something related with mobile technology and artificial intelligence. So let's move into our topic. You know that in supervised learning scenarios of machine learning, we usually train models for specific tasks in a certain domain. For instance, detecting food, okay, this is a chocolate, this is a cake, this is, I don't know, some specific elements within a domain. And we assume that we are provided with labeled data for the same task and domain. So yeah, we have a file maybe which contains the information, okay, this image is a cake, this second image is a chocolate, and so on. So the idea is that, well, if there is another domain, we might have problems. We would not be able to recognize objects because, of course, this second domain has their own tasks, their own objects. So the task and domain of training and test data of our model A is the same. A task is the objective that our model aims to perform, such as recognizing objects in images. And the domain is where our data is coming from. For instance, images that you can easily find in a coffee shop or in a restaurant. So we usually train model A on this data set, and we expect to perform well. We use several algorithms until we reach, let's say, good performance or good high accuracy. But when we have this second domain, we require label that data of the same task or domain. So we can train a new model V. The supervised learning paradigm is not useful when we do not have sufficient or enough label data for this task or for the domain that we care in order to train a reliable model. So we cannot reuse an existing model as the labels between these two tasks are different or differ. Okay, so that's one problem. Second one is that, okay, training an image classification model from scratch usually requires setting thousands or even millions of parameters, quite enormous labeled training data, and of course, a vast amount of compute resources, especially if we are talking about the deep learning field, because we might need or require hundreds of GPU hours. Of course, we can provision cloud services which provide these high computational resources for us, but of course, there will also be a cost there or related. But usually, if we have enough data and also significant or relevant data, the performance of these models and the accuracy of what we are building will be better. But yes, we need high computational resources. So this is a second problem that we might encounter when we are training our data or when we are training some algorithms or using some algorithms. And then we have transfer learning. Transfer learning is a machine learning method where a model that we develop for a task can be reused as the starting point for a model on a secondary task. The basic idea is to use the knowledge that we gain while we solve the initial problem, and we can apply it to a different but related problem. Transfer learning, it's a popular approach in deep learning because we have several pre-trained models that we can use as the starting point on computer vision, but also on some other tasks such as natural language processing or even speech recognition. We might have used computational and time to train this initial model. Maybe it is a big, huge model. We might talk about neural network models, deep neural network models on these problems because we have or we require a lot of resources and skills. So in other words, transfer learning is an optimization that allows fast progress and also improved performance when modeling is the secondary task, when we need to generalize, yes, some of our initial labels. So just to compare traditional machine learning versus transfer learning, the traditional learning is an isolated task and occurs based on specific tasks, specific data sets, and training, separated models on them. The knowledge is not retained, but in transfer learning, we can leverage, we can take advantage of the knowledge that we gained before. And what is knowledge? Okay, it can be features, it can be weights, it can be layers, yes, from these previously trained models. and we can use them to train, yes, newer models and even tackle new problems. But we will not require high computational resources. We maybe have less data for these newer tasks. Think again that for our initial task, we require huge data sets, but for the second one, maybe we have less data. We can build a classifier, a custom classifier from there, okay? So how does it work? If we go, let's say, a bit deeper, in transfer learning, we first train a base network on a base dataset and task. Then we delete what is known as the loss output layer, which is the last layer that we usually is what we usually use, yes, to make predictions. Sorry. And replace it with a new loss output layer for general prediction. Okay, so there is a replacement there. This new loss output layer is fine-tuned, and it also helps to determine some penalizations from the label data and the predicted outputs. You will see that when we are talking about the demo, we will have this loss metric or statistic. And it is a good indicator or metric if our new model is has a good accuracy or not. Okay. Then next, we will take this smaller data set for general labels and train it on the whole N layer neural network, or the last few layers, or maybe even the loss layer alone. By applying some transfer learning techniques, our output on the new network, maybe a convolutional neural network, will be able to identify general elements. Okay, so this is something important. Transfer learning only works in deep learning if the model features that we learn from the first task are general. Okay, more on that when I talk about the data sets. Yes, but usually in our secondary related problem, we will create generalizations. Okay, like maybe, for instance, at the beginning, we built a model that distinguishes between very specific types of or classes of dogs and cats and other animals. But in the secondary task, we would like to know, okay, if we have a cat, we have a dog, or we have some animal, groups of animals, okay? So, yeah, that's important to know. We mentioned or we talked about pre-trained models. Of course, to solve the problem, we need a pre-trained model of the similar problem. Instead of creating a model from scratch and then require a lot of computation, a lot of features, yes, to solve a similar problem, we can use this starting point, this model that we train on the other problem, yes, as the starting point. And what kind of pre-trained models we might have? Okay, so first, maybe we have images like this that are very diverse, that they have differences in size, for instance. We might have pictures of dogs that can be any of the following that you can see in this slide. So you can see that in some of them, the area that where the dog is present is different. In some of them can occupy the whole image, and in others it's just a small fraction. Because of this huge variation in the location of the information, yes, of the relevant information, choosing some parameters such as the kernel size for convolutional operations is a tough or a difficult task. If we are talking about convolutional neural networks, we usually select a large kernel that is distributed globally. And well, a smaller kernel can also be useful if the information is distributed locally. One problem that we might find in convolutional neural networks is that if they are very deep, they might overfit, and it might be difficult to pass gradient values updates, for the entire network. So we have something which is called the inception network, which was an important milestone in the development of convolutional neural network classifiers. It was very complex, yes. It uses a lot of tricks to push performance in terms of speed and accuracy. So it is actually, or today we have the Inception version 4, yes, ResNet and GoogleNet that you might have heard of. Each version is an iterative improvement over a previous version. So understanding the upgrades can help us to build custom classifiers that are optimized in speed and accuracy. You can see in the left picture the initial or naive inception module that performs convolutions on inputs with 3 different sizes of filters, 1 by 1, 3 by 3, or 5 by 5. And usually we use something called max pooling to create these pooling layers. So we select the highest number in each subset. Then the outputs are concatenated and sent to the next module. To make it cheaper, to overcome this problem that we might have computationally expensive deep neural networks, the creators of the Inception network limit the input channels by adding a 1 by 1 convolution before the rest, before the 3 by 3 and 5 by 5 convolutions. So this might not make sense, but actually the reduced number of input channels help. And yeah, also the dimensionality was reduced. So after using this inception, a neural network architecture was built. And this is popularly known as GoogleNet or Inception version 1, which we are going to use for this demo or for this scenario. So yeah, you can see the ImageNet, which is a data set which contains several classes. We have labels, as we were talking about supervised learning. So we have the labels for some of our classes. Okay, we have a Kit Fox, English Setters, Siberian Husky, and so on. And you can see some examples of these tags or pictures. Okay. So of course, we have millions of or thousands of images. So you can imagine that creating an image classifier to let's say predict or detect what is happening in new images. Yeah, this will take training a model or training a network for this takes a lot of time. Okay, but what if we would like to simply identify, I am talking now of a second, let's say, task, yes. What if we would like to determine generalizations? Okay, we have a food here, we have a toy. We don't want to say, okay, this is a teddy bear or this is a pizza. No, we just want to group, okay, we have food, we have toys, or we have some kitchen items or appliances there. Yes, so that's where transfer learning enters, okay? The inception model has already been pre-trained on thousands of images. So we can leverage, we can gain, just learn from this previous experience to build this new, let's say, custom model for us, transferring the ability to recognize and classify the images for this specific case, specific, but in the end, general, let's say, cases. Okay, I want to say specific because it's only these three cases or these three categories. Okay, a second option, of course, is to use custom vision. Custom vision is part of the cognitive services, and with custom vision, you can also create an image classifier. In the end, you will have you can train by submitting images in the portal or also by using the SDK. You can create the image classifier, which you can export as a TensorFlow model. And this can also be your starting point for the transfer learning. Okay. So now let's talk about transfer learning in ML.NET. So we are now to the point that we have an inception model, or we have a TensorFlow model. You know, you have your NV file, TensorFlow, which you obtain from previous training, okay, by you or by some company. So now we have our data, and you can see that this is a quite a small data set. You have 8 images, 8 pictures there. You have your labels, your tags for your new task. Okay. You have, okay, some broccoli that you will say, okay, these are food, these are toys, these are examples of appliances. Okay. And you have your tags. In your project, okay, you will just get some references to your files, okay? And I also have another picture, which is not listed here, but of course, I am using this one for testing, yes, for evaluation. Yeah, I could have also used this toaster tree, which is not included in the input, but okay. Yes, and you can see here our TensorFlow model, okay? Then we have our input data model. We have the image path and the label. This is just the structure that our new model will, let's say, use, okay? We have the image file and also the tag or the label. You saw it there. We also have the prediction model, which contains the first two properties, because you can see that it is using inheritance from this class. And also we have an array of scores. Let's say every new tag will have some probability. Of course, the top one is the one that we are prompting to the user, which is, let's say, the one that the model detected that it is. And yeah, the predicted label value. We also have these inception settings. Actually, this is quite important. This is from our TensorFlow file. We obtain this, the size, the height, and width, yes, from our structure, from our data. Yes. So it is important that you analyze a model, your file, your TensorFlow model, maybe with Netron or with other tool, to determine if the size is correct. For custom vision, the size is 227, I believe, or yeah, I think 2027. Because if it is not correct, you will get an error that one size was expected. I can tell you where. So it is important to know this in advance. And yeah, also the mean, the scale, and so on. So this is where the transfer learning actually is happening. This is one of the important or key elements, the multi-class classification, which is a supervised machine learning that we can use to predict categories of instances of data. In machine learning, in ML.NET, you have the following training algorithms. You have multinomial logistic regression algorithm, which is the one that we are going to use. There is a naive Bayes, there is one versus, and there are others. There is also image classification, which expects, let's say, images rather than the image paths. That's another one that you can use. And for all these algorithms, you need the inputs and outputs. The inputs are labeled and feature columns, and the outputs are the score and predicted label, which actually are in accordance to what we mentioned here. Okay, the input data model and also the image prediction model. Okay, so that's there. And we are going to add this machine learning task, let's say our algorithm for our secondary task in the model pipeline. So, okay, this is quite a lot of information, but let's dig it little by little. So the ML.NET model pipeline is a chain of estimators. Actually, we saw some of these in the workshop yesterday. So the pipeline, these estimators create a pipeline for the model, train the pipeline to produce the new ML.NET model. And we can also evaluate the model against on-scene tested data. So the first part is to add the estimators to the model, to load the information, resize, and extract the pixels from the image data. So you can see here, we firstly load the images from our image folders, only the 8 ones that we had. Then we resize it to the image width and height that we specified. And we also extract the pixels, okay, that are for our new training, okay. So of course the image needs to be processed in the format that the TensorFlow model expects. So that's what we are using, that dimensions. Then we add the estimator to load the TensorFlow model. You can see it here, load TensorFlow model. And inception TensorFlow model, it's the reference to our file, okay? So we process the vectors of the pixels, yes? We apply the inputs to a deep learning model, and generating the output is referred as scoring, yes, this scoring part. That's basically for the inference or for the prediction. In this case, we want to use all the layers except the last one, because the last one makes the inference. The output of the previous to last layer is known as softmax 2 reactivation. If we check the model in Neutron, which I think I have it here, yes. You can see this name here. Okay. Let me show you. Yes. We have it here. Okay. Yes. So that's the name that we use. Okay. Softmax 2 pre-activation. It's here. It's the previous layer. Okay. And this is, of course, our file, Inception Graph PV. And the rest is just mapping the string labels in the training data to the integer key values. Also, well, using the labels and also adding the prediction or predicted label value. And yeah, basically that's it. Of course, the code is not executed here. I mean, we are just preparing the estimator. It is actually performed, or all these tasks, all this training is performed when we indicate, okay, let's now train the model. So as an input, we take, of course, our tags. Yes, we load the text from the text file. And we use the fit model to actually perform the training by applying the pipeline. Okay. And of course, you can use or you can get this information from databases, not only from text files, even from memory. You can obtain from enumerables and so on. Okay, we load, we transform the test data. You can see it's similar. We also use the iData view, but now it's for the test part. We transform to get the predictions. Yes, and we evaluate the prediction set. Yes, and I mentioned you, or I told you that we would have this log loss, and also, okay, the log loss is the general one, and we can also check, okay, for each category, for each class, what is the performance or the accuracy in the term of the log loss, okay, logarithmic loss. You would like these values to be closer to 0. If it is higher or closer to 1, yeah, you have errors there. And okay, the last part is to run the application. So basically, we just call this generate model and we classify. Yes. Okay, so I can show you. Okay, this is the full code that I just explained to you. And let's run. Of course, as I told you, to create this classifier that was based in thousands of images, you can imagine how much time it took. But now just check how much time it takes to create a classifier for these 3 classes or categories. So it is running now. This is the picture or the image that I'm going to analyze. Okay, I should not open it like this. Okay, just give me a second. So this it's analyzed, and yeah, it was detected as an appliance. Yes, and you can see, okay, the log loss is 6%, 8%. Okay, so yeah, we could use more maybe images, or we can tune the parameters to decrease these values even more. And yeah, basically that's it. As I said, well, we could use other algorithms here in the check. Yeah, in these trainers. Yeah, we could use naive AEs or one versus all. Yeah, but each of them have their own requirements. And yeah, this is a way to create the transfer learning part with ML.NET. So you can compare, for instance, what we learned in the workshop yesterday, that we create classifiers or regression models but we add the pipeline. We add in the pipeline more, let's say, steps. We part or we start with this TensorFlow model, and the rest is just taking this knowledge to create your custom classifier. Basically, that's the main idea behind it. And okay, well, yeah, just to finish this part, why you should care about transfer learning. Well, according to Mr. Andrew, transfer learning will become a key driver of machine learning success in industry. You can see some, let's say, predictions there, and transfer learning is set as key element here. So yeah, that's it. I would like to know if there are some questions about it. If yeah, what are people saying?
Yeah, thanks, Luis. It's a great talk. Let's see. I think there's only one question I see, and someone's wondering if the code that you have is that on GitHub or somewhere that they can look at it.
Yeah, I can share it on my GitHub. It is actually based on the demo that we can find on the docs, but yeah, I can share my GitHub. I have not uploaded it there, but of course I can share it. Just I think I can add my address. It's icebeam7, but give me a second. Oh yeah, it is this. I will add it in the chat later, but yeah, I can post it in the next hour.
Okay, cool.
Yes.
I think that's all. Praveen is asking what all hyperparameters that would be configurable.
Parameters that would be configurable. Okay. Yes. Well, for instance, here in the classifier, you can check enforce non-negativity if you don't have negative classes or history size, or you can even have weight columns, yes, or regularization or optimization tolerance. In each of your classifiers, you might have several parameters that you can tune there. So this could be a starting point to try or to compare several of your new trainings.
Yeah, that's like quite a few things you can experiment with there.
Yes, yes, yes. As you can see, most of them are optional, but we use only a couple of them, the column names and features.
Cool. There's another one here. What type of projects are you excited about trying next that use deep learning and ML.NET?
Well, that's a very good question. Well, my research is mainly about face detection and also emotion recognition. So I'm working mostly on that field. I usually, let's say, working on how to optimize when you have to distinguish between two emotions that are similar, such as sadness and also like indifference. Because in sadness you are like this, but in indifference you are like right? But still in some of the research or in some of the let's say algorithms, the results are confusing between these two emotions. So I'm always working or finding new research. Right now, I am experimenting with the activation function, and I am learning about exponential. There is ReLU, rectified linear unit, but in new research or in new papers, you can see that the exponential linear unit is performing or getting a much better performance. So I am working on that part. Yeah, I wonder if I can do the same with MLNet. I might try and see.
Yeah, that would be interesting.
Yes.
Let's see. Have you used transfer learning in any other of your projects? And if you have, has it worked well?
Well, yes, but let's say not with ML.NET. I mean, with TensorFlow and also with some Python code. Yes, basically actually it's similar. Like we use ResNet or other data sources and also other models that have been trained. The Inception version 3, version 4 maybe, and we use it to categorize different, let's say, classes or different sets. Also, well, it was for learning, also for research, but yeah, not yet in any, let's say, practical or some like production, let's say, task yet. But it's part of the research, always learning and reading about newer technologies.
Cool.
Yeah, if some of you are interested, yeah, I can share some of the work. Just drop me an email, and yeah, I would be glad to share and collaborate, definitely.
Yeah. Let's see. Another one, since your research is mostly in the Python and TensorFlow, what are the main things that you miss from ML.NET in comparison with those other tools?
Okay, yeah, that's an interesting question because, well, ML.NET, I really like it because I am a C# developer before coming, let's say, to the artificial intelligence field. I was developing a C# application. I'm still developing because I am mobile. So maybe one thing that I miss, but there is a workaround. One thing that I miss is to export, let's say, the model as a TensorFlow model. I don't know if this makes sense. Of course, we can convert it to, as we checked yesterday in the workshop, as a zip file, and then we can put it on a web API so our applications can consume it. And it is possible in mobile applications to use this TensorFlow model directly to create image classifiers or even object detection capabilities. But to, let's say, directly integrate this model that we created here directly is not possible. I think maybe I'm wrong, but I cannot, let's say, export or create a TensorFlow model from here to put it directly on my mobile application. So I need to export the zip or the model, the ML model, yes, MLNet model, and put it somewhere and use it like, let's say, as a bridge here. So yeah, that's the workaround, but it's still possible, let's say. And I have not explored all the algorithms here that are present for the classification or for other tasks. So I don't know if, for instance, we can add our own, or if this part could be open source, maybe like the ML.NET team can benefit from algorithms that are developed from the open source community or from the research community. I don't know if that is possible, if we can bring our own. So, but that's also interesting for me because that's another thing that I can learn.
Yeah, definitely. So I guess one more quick question. Do you know of any data augmentation techniques in ML.NET, if there are any available?
Wow. To be honest, I have not explored that part. That augmented reality, it's of course interesting. It's one of the topics. Well, one friend is organizing a submarine event, and that was one of the topics, augmented reality. That was one of the topics that people, let's say, requested. So yeah, I see. But I know that there are some libraries that you can use, let's say, outside, but not in ML.NET. I mean, I don't know if in ML.NET could be possible, or if that's from different fields. To be honest, I'm not sure about it. And maybe someone from the team can respond that, or could help me with that. But definitely, it's an interesting topic that is part of, let's say, the future or even the present.
Yeah, it will be interesting. I'm not sure myself, so it might be something we need to open an issue and ask a question on.
Yes.
Well, Luis, thanks for your presentation. It was great. Thanks for coming on.
Thank you for joining. I'm quite happy to be part of the event, and I will be also in the Slack community chat answering more questions if you have, or if you want to talk to chat. I will be there. Thank you all for joining, and good luck with your research. As I said, if you want to collaborate, my email is there. And have a nice day, everyone, and thank you all of you for organizing this.
Thanks for being here.
Goodbye.
All right. Well, welcome back, everyone. This was a fantastic session by Luis just earlier. Thank you so much for that with transfer learning. And we learned a lot of things there, especially about deep learning and image classifications. But with us now, we have Daniel here calling in from Holland. How you doing, Daniel?
I'm fine. It's a nice weather here, so I just can get to enjoy the weekend tomorrow.
That's awesome. And you're a Microsoft MVP, right?
Say again, please.
You're a Microsoft MVP?
Oh yes, recently.
Yeah, trainer and speaker, and you've done 1,200 hours of developer training over the last few years here.
Yeah, I had classes with .NET students, beginners, but it helped me a lot to get into the details.
That's awesome. Fantastic. So can you tell me, like, how did you first come in contact with MLNET, and what's your story there?
Well, about 2 years ago, I had a presentation related to .NET Core on Linux. So I have used Raspberry Pi. And I realized very soon I cannot get too much sense from all this data from the sensors. So I tried to find something to do with this. But you know, the larger the data, the bigger the chaos. And my first thought was I don't want to go to Python or other platforms. And it was very new at that time, MLNET, it was the version 0.3. So I jumped on it, and I'm very happy now because obviously I have found something in .NET ecosystem, and maybe that's why I'm here today.
That's awesome. And today you're going to talk about the Jupyter Notebooks in .NET, right?
Yes.
Awesome. Well, we are very excited to hear that. And as always, everyone on the stream today, you can ask Daniel questions in the chat or in the community Slack room. And I believe also, Daniel, that you are doing your own streaming on Twitch as well, right?
Yeah, I have left the slide some details about the channel.
Perfect. So people can kind of tune into your Twitch streams later as well to ask you questions if they have anything to follow up on.
Sure.
All right. Well, Daniel, the floor is yours. We are looking forward to it.
Okay. Thank you. Well, why this title? It's not related to the pandemic times, but it could be. Machine learning is as good as its data. That means a bad data set drives to a bad machine learning model. A good data set is better than a smart algorithm. And in other words, your model cannot be better than your data set. I'm not talking about only bad data, like reading errors or duplicates. Be very careful when preparing the data because your biases are encoded there, are left there. Let's say the DNA contains all kinds of biases we want to avoid. Well, Microsoft ML.NET, it's not another machine learning framework. When thinking of data science and machine learning, of course, Python programming language is making the rules. In addition to that, the existing frameworks like TensorFlow, Keras, Torch, you name it, are not easy to integrate with .NET projects. So worry no more. ML.NET is designed for .NET developers. And as developer, you have access to the entire life cycle of a machine learning model. You can prepare data, you can train it, validate, evaluate, and finally consume the model. Now, from bottom up, ML.NET is built upon .NET Core and .NET Standard, inheriting the ability to run on Linux, macOS, and Windows. And is designed as an extensible platform. Therefore, you can consume models created with some other platforms and frameworks like TensorFlow, Onyx, CNTK, and more. And more later, I guess. Infer.NET is some other example. Microsoft ML.NET is more than machine learning. It includes deep learning and probabilistics and you have access to a large variety of machine learning scenarios, like image classification, object detection, in terms of extensibility. And we have a full arsenal here. We have API, of course, but in addition, we have CLI and UI, which is a model builder. We can use all of these in on daily basis when we are developing its API, but maybe in some DevOps scenarios, we might need the CLI. And of course, if we want to try something quickly, we can rely on a model builder. Actually, it's a very good start for a developer, because I want to let you know I'm not a data scientist at all, and for that reason, do not rely entirely on my interpretations. But from the code perspective, I really hope you will find out good information in my talk. So what do we have here? We have a flow which we will talk in the next slides. For example, talking about data loading, we have a data set. The data set anatomy, it's like a list of features, but one of the features is a special feature because it's the feature we want to predict. This feature is called label or target feature. All these rows with data are called observations, or let's call it readings. For example, we have a data loader, and this is responsible for loading the data from the external source. That can be a database, a text file, or can be the memory. In addition, you can stream data while training without needing to load all the data in memory. And that's very cool, thinking of it like an enumerable being lazy evaluated. That means until you are hitting fit, the data are not there yet. And that brings performance, of course. Data view, it's a very important component of ML.NET. And it's a data set represented like something like a table with rows and columns. The schema of the data is there. The types of the fields are there. And very important, all the components are working with data views. Data loaders, transformers, savers, trainers, estimators, you name it, anything in the ML.NET are working with data views. First, I would like to talk about another way of seeing data, and it's data frames, which is not directly used by the ML.NET, but it's another object which is actually it's very new. I think it was released last autumn. It's very good to inspect, to visualize the data and find answers to questions like how many observations do I have, how many features, the types of the features, categories or classes, and very important, which one is the label feature. This is, of course, this is correct if we are trying to do supervised learning. In that case, we need a label. Well, do not look at this like something very rigorous. I mean, it's just to visualize by your eyes or run a few interrogations on this object. And let's talk about Jupyter Notebooks a little. This is very known in Python world. And recently, we have support for .NET Core kernel. Creating a model is an iterative process, and you have to experience a lot with transformations and trainers, measuring and improving the model many times, or tweaking the hyperparameters. And during the process, you need to analyze the data again and again, ideally in a visual way. By the way, I'm a very visual person. I have to picture it to understand. And that's true with the coding as well. Well, Python, Jupyter Notebooks, it's a wonderful platform which we can now use with the .NET Core. First, I will explain just a little the real-world scenario which I have modeled here. We have a problem, and we try to find a solution. Let's suppose we have a system able to read data from sensors like temperature, luminosity, infrared, the daytime when they were created, and the distance to a source. Which source? The source which gives the heat and the light for the sensors. Well, and of course, let's hope we have at least a few hundred observations. These observations have to be labeled because we are planning to do some multi-classification. They have to be labeled. That means we have a feature called source in our problem for every observation. And actually, the source from the sensors is generating these observations. Now let's take a look inside Jupyter Notebooks and data frame before jumping further to more serious stuff. Maybe you are familiar with Jupyter Notebooks. I will spend only a minute here. There are some special commands. For example, lsmagic, which is listing the supported commands. Do not rely entirely on this. The list might be longer. And that's the command about, which is good to see if we are up to date with the latest changes. And for example, when we are registering a new object in the environment, we can interrogate the environment to see what kind of objects do we have. Or maybe we need some more information like the type of the objects. And then we can run whose command. And a very interesting feature which I have found here in ML.NET, because it's very new, it's object formatters. That's a very cool feature which is able to intercept an object which we are sending to the console, and it's formatting on the fly. For example, I have here a very minimalistic object named person, and then I'm telling to the formatter for every person, intercept and write to the console this content which I'm formatting here. Well, take care on this type. It has to be a concrete type. I'm having my biases here. I struggle a lot to identify why it's not working with interfaces. It's not. It has sense. And do not forget to control here the my type. We can just call the display command, or we can simply up there the name of the object. It's an interpreter, so it will be interpreted, but in our way. If you have problems, because debugging it's not very friendly, you can run the command log, which helps you get more information from the platform. Well, let's see a data frame and how this can help us visualize the information. And let's run a little cells here. And for example, I'm loading the formatter from an external file because if you are not careful, this notebook it's getting clunky easily. A lot of information is very hard to control. So I have tried to do not repeat myself, of course, and I'm keeping my data in some external C# scripts. Formatters as well, because formatters are really ugly. I mean, there are a lot of lines there and not hard to understand, but hard to maintain. Well, the same, I had put my models inside another C# script file and planning to load from here and to not repeat myself. Let's go back to the Jupyter Notebook. I'm running these data frames here. As you can see, the data is loaded in a table fashion way. And we can see here, by default, there are only 10 records. You can set to see more, but be careful, you don't want to block your environment. And then you have some possibilities to see the information in a different way. This is very similar, actually. It's kind of porting pandas from the Python in .NET. When you're ready, you can convert it to IEnumerable and then import it in your data views. Well, let's get back to the presentation. We have here another chapter, it's data visualization, where I have invested some time to make the things nicer. And after I have read the information from a CSV file, I have split the information in training and testing data set. I have converted in a enumerable collection. Then it's time to visualize the data. Of course, data, when there are a lot of observations, it's not telling too much because it's hard to comprehend. So we have a few kind of investigating data provided by a very nice library. The name is XPlot. And you can see the data in a visual way. For example, we can see the categorical distribution to see how many samples we have for each class. It's very useful information. Or we can see how is that data distributed along the minimum and maximum values using numerical distribution. And very nice diagram, we have box plot segmentation. This is bringing more information, and we can see now very important information here. We can see which is the range of each of these features and how are data distributed. For example, we can see here temperature has a lot of outliers, which is not necessarily bad, but the mean values are somewhere around 20 degrees, which is normal. And for example, the distance, it has a larger range. I'm expecting this to have greater impact on the model, which I most probably don't want. And it's a first serious way to look over the data. Then it's another kind of diagram. It's named correlation matrix. It sounds cool. I jumped on it and to see what's that matrix. Well, you can see how are the features correlated one to each other, and maybe you already asked yourself if we really need all the features. This is a good way to see if we really need all the features, because most probably some are less important than others. And as you can see, we have here the range between -1 and 1 with the following meaning. Near -1 and near 1 indicates a strong relationship between the features. They most probably might be redundant. 0 indicates no relationship. That's fine. And close to 0 indicates, of course, a weak relationship. For example, in our case, distance and infrared are correlated. I will show you later in the Jupyter because I don't want to spoil it. But it's a good way to see how are these features really necessary for our model. Let's jump to the demo. I'm loading the models, initializing the context, loading the data, split it, take a look on it. You can use here data frames if you like. And then I'm trying to take a first look on the categorical distribution. And we have here some numbers showing us how many samples we have for each of this category. Or maybe we want to see the same for the testing data set, because the data not being balanced, it's a problem. We have to have a pretty balanced data set. So we have, for example, here we have almost double flashlight values. But in the trained data set, we have, it's again flashlight because they are in some other order. But anyway, we have to take care on this distribution. And then we can check for a histogram to see how our data distributed. But okay, I have this diagram for any single feature, but my favorite is the box plot segmentation. And we can see here the features, which doesn't seem to be very equally impacting our model. Most probably we might want to normalize this. Let's see the correlation matrix. We can see here in every cell how correlated are these features. Luminosity with temperature are highly uncorrelated. Then let's go to build a pipeline, because we need to do some transformations. For example, I'm getting the data and map the value to key, because machine learning, it's about numbers, and the categories are strings. So I have to encode that. Then I have a custom mapping, because I have realized I want to split my date time feature into hour and day. I think hour and day, it's much more useful for me than daytime. And then I'm concatenating the features, this is necessary when we have more than one feature into the building pipeline. And ML.NET is, by convention, is looking for this field, the field name features. And the last step in this pre-processing pipeline, I'm normalizing the features. Okay, this is important because I have planned to normalize the features, because I didn't like this plot segmentation too much. And let's see how would this look if normalized. Now they are normalized, much better. Now it seems like they are aligned. The impact is equally distributed. And now I'm expecting to build a model which not so many biases, let's say. But take care, we don't want to normalize testing data, for example. This is only for this pipeline for training data. Next, we are calling the trainer. I have used one of the trainers for multi-classification, which is, in our case, stochastic dual coordinate ascending non-calibrated very long name. And this is doing like linear regression. Actually, classification is a kind of regression. And then last step, post-processing, we have to encode back the numbers to the categories in order to make them human readable. And now we have the pipeline. Not yet the model, but we might want to validate the model against the data. And let's look how they are looking. I have called cross-validation. There are some other way of validating, but this one, it's very popular. And we can see what do we have here. It's actually it's the training data set. It's split it in folders, and each fold is in folds, yeah, and each fold is measured, and then it's made an average and calculated a standard deviation and confidence interval. Usually these data are not very friendly, so I have used a formatter in order to make them look nicer. So I have here the private static methods formatting these. And then let's check, it's right here. So I have intercepted this kind of object. We have here a list of cross-validation results of multi-classification metrics. This is what we want to be careful. It's our metrics here. And for that, I have iterated and then I have prepared the data, assembled in a table, and send it to Jupyter Notebook. All this information is very easy to see in Jupyter Notebooks because there is a Pocket View API, which is an object, an API, able to render our HTML content. Let's go back to the presentation. And check the next step. So remember, if you decide to save time preparing the data, do not be surprised you have to pay the price later. It's similar to technical debt. I would call it preparation debt. Well, we want to clean the data. Now we can use our instruments like data frames and box plot segmentation and correlation metrics. And we can decide which data are using or not, which data, yeah, and later which features, which is something completely different. First, when we got the data, we have the data, it's uncleaned. We will lose some data, which is called bad data, and then we are splitting the data in two. But after that, we can focus on building the pipeline. I have here with yellow map value to key, custom mapping, concatenate, normalize, the trainer, and then the post-processing pipeline, map key to value. For all this, for the pipeline, I'm using the training data view. Then at the end, I'm calling fit command, which is building my model. Once I have the model, I'm able to test my model against the testing data view. And when I'm using my model with the training data, I can do the cross-validation. And when I'm doing my model evaluation, I'm doing against the testing data view. And then we have another feature, permutation feature importance, another type of measurement. Let's check a little. So for model validation, the cross-validation, it's, as I said before, splitting in folds the information and sliding one by one these folds in order to calculate the accuracy for each of these. And then at the end, we are doing an average, and that's resulting in a general accuracy. We can examine the quality of our validation, inspecting the macro accuracy, micro accuracy, logarithmic loss, and logarithmic loss reduction. In terms of performance feature importance, we have this diagram, which is very important to see if we have some features which are not impacting the model. Most probably, we can remove, for example, day feature here, and our model will not suffer. Then it's model evaluation. Again, we can see here some metrics. We can watch some important information here. We can see here the micro accuracy. The closer the one, the better the accuracy, or logarithmic loss, which we are planning to lower it to 0 to minimize the value. And then I have the confusion matrix, which is a way to tell about data how many shots are correct and how many shots are false. For example, here, using the testing data set, we can make predictions and compare the predictions with the actual results, with the true results. In the previous diagram, we can see the day class was predicted correctly. In how many cases? Let's see. So day, it's predicted as day in 28 cases, but day it's predicted as flashlight in 1 case. Therefore, the accuracy is not perfect. It's 0.96. Do not expect the machine learning model to be perfect. That's not something very precise. This is why we are dealing with these metrics. And do not forget, when we are deploying a model, do not deploy without these metrics. We don't want a model and know nothing about it. Data preparation. We already did some part of this demo. I will go back and see the permutation feature importance. In the same time, we can examine the weights and biases. But now let's see the permutation feature importance. As we can see, they might be unnecessary, and we can consider in deleting it. Let's train the model, because we are switching to the evaluation, and the evaluation needs the model to be built. Let's display the metrics. And the confusion matrix, as I have explained in the slides. Of course, the more experience we get, the more we can decide. We can live without this, but we cannot expect to have a good model. The plan, the goal is to improve the model. So in time, we will be able to get the best from these measurements. But it's the first step. And of course, when we are done with this, we can save the model. We might want to save it in Onyx format. It's possible to do that. But we have to take care, because some of the estimators, not estimators, transformations are not supported yet. Like in our case, custom mapping, it's not yet supported, but maybe in the future. Okay, let's switch back to the presentation and see what's about the best part of this, the data. Data prediction, it's when we have the model, drop some input data, and make a prediction in output model. Let's see some demo for this. This is very short demo. Loading the model, the models, the data models, right? initializing the registering this custom mapping, which is necessary because I have used the custom mapping. This is a special thing which we have to take care. And then it's loading the model. What do we missed here? Maybe I didn't run everything. Let me run all these in the proper order now. Okay. Let me run again. The model is not created, so therefore the physical file is not there yet. This step is what we need. And now let's run again this. Okay, now we have the model, and let's make the prediction. We are preparing a sample, load some helpers if we really need. I have created the helper to put the data in a more friendlier way. And let's predict. The prediction says for a sample with 92 degree, no, it's luminosity, 92% luminosity and 122 degrees Celsius, 0 infrared and 0 distance at this time. Most probably it's a flashlight, but you can see here it's very close to lighter. It's not really a good guess. The lighter would be a better guess, but this is machine learning. Let's play with some other values. For example, 22. Flashlight, and that's correct. We don't have the heat anymore. It's a flashlight. Okay, let's switch back to the presentation. And what I want to tell you now, it's I hope these instruments will save you a lot of time and help you build good machine learning models. If you want to run notebooks on your machine or to reuse the formatters, I have invested much time in arranging those. Not very exciting, but useful. So you can get these already built formatters to use it in your notebooks. Visit my GitHub repository and grab them. And something else, I have a very new Twitch TV channel where I just starting to implement an end-to-end application with ML.NET. It's .NET Core, of course, with IoT, using deep learning. Actually, I plan to not label the data in a manual or semi-manual way. I will use the deep learning to label the data. I didn't try it. It's an interesting idea. So subscribe if you are interested. And usually I will do the sessions every Thursday. But you will see more data on the channel. Well, if you have questions, hit.
Well, thank you, Daniel. That was a great talk. You're getting some good feedback here on the chat here that I'm monitoring. Does anyone have any questions for Daniel? I have one while you're all typing. If you have any questions, I saw those awesome. We call them confusion matrices that you use in Jupyter notebooks there with nice table formatting and so forth. You said you had those on GitHub, right? Was that correct?
Yeah, let me show you here. It's on GitHub. I just committed the latest. I will add more diagrams.
Yeah.
And I hope they will be useful. For example, for confusion matrix, this is specifically built for multi-classification. It has to be adjusted for some other classifiers.
And these Please beat me to the question here, but the question I'm going for actually is, have you considered packaging this up as a NuGet package? Because I would love myself actually using them in some things I'm doing. So
it's a very good idea. Actually, my plan was to not let some other developers to get to through the same ordeal,
yeah,
and to share them. Very good idea. I will consider it. I will definitely. I want to do that.
yeah, I would. I think that would be great. I know that the Samuel Brewer as well, that does Jupyter Notebook development, has also done some similar things. And I think a lot of people are struggling with confusion matrix visualization, and NuGet package would be very valuable.
He was my source of inspiration, but that his classifier was with true false for binary.
Yeah.
So then I have extended.
Awesome. There's one question in the chat related to that NuGet package actually, and that's how do you add references in Jupyter, like external packages and libraries?
Well, it's a command named R from reference, I guess, where you can include. Let me get to the, like this one. This is the way we can include our NuGet packages. We are able to add some other NuGet package repository as well using the command #I. We have to put there a path to the other repository. But I think this is my response to the question. And then we just import the namespace with using.
Perfect. Yeah, that's very good. Thank you. All right. I think those are all the questions we have in the chat for now, Daniel. Again, thank you very much for this talk.
Thank you very much for having me. It was great to be part of this.
Awesome. Well, coming up right now is an interview with Paul Mendoza, who is the founder of SIGParser. And we're going to listen into his experience with MLNET in his organization and kind of what impact it has. And following that, we are going to listen to Bart Cernicki, who works for Microsoft as a principal architect, and his talk about Blazor and MLNET, which I think is going to be super exciting to hear. So stay tuned. But first off, we're going to listen to Paul Mendoza. Hey, Paul, great having you today to talk more about MLNET and your experience with it. We're really excited to hear what you have to say. Could you tell us more about yourself, who you are and what your organization do with MLNET?
Sure, thanks for having me on. So I'm the founder of SIGParser with my co-founder, Chris Landry. I've been a .NET developer for maybe 15 years now. And we started this company called SIGParser a few years ago. We started working on an algorithm about 6 years ago to parse email signatures and to extract content from those email signatures. And as part of that, we started getting real into parsing deeply nested reply chains. And so we had to build up this whole email parsing sort of system. And we had to figure out how to deal with multiple languages, how to deal with all the complexities of unique email signatures. And so as part of that, we ended up using ML.NET to drive a lot of the algorithms that we're building to parse all of this detail out of emails.
That's awesome. So what made you choose the library? Is it mostly because you were familiar with .NET from the beginning?
Yeah, for us, it was a combination of things. One, I was familiar with .NET, but two, I'm not a data scientist as far as building machine learning models, so I'm fairly new to actually building out machine learning models, especially then when I started. I had worked in sort of a data science-y background and at a previous job analyzing utility data, so I was familiar with a lot of the concepts, and I'd taken some machine learning courses. But for me, it was, what can I get in and be productive with right away? Like on day one, and really it was like, hey, I've got to build a model for this, and I don't have 3 weeks to do research and development. I need to get something out like in a couple days. And what can I do? And I was like, oh my gosh, ML.NET is there, and really all I need is like a binary classifier. And can I basically use a sentiment engine to kind of do like a sentiment analysis kind of thing to kind of do what I need? And so for me, that was kind of why we chose it. It was really quick to get started with. And I've looked at other solutions, but it's really nice to have everything inside of my one assembly and not have to call out to like a third-party service. And then if I'm calling out to a third-party service, I'm then incurring additional costs on top of what I'm already doing. And so it's really nice to be able to just package everything together into one assembly.
That's awesome. Yeah, definitely. So what would you say the impact has been of using MLNET for your company?
So, I mean, it's been huge. There are just things that I think we couldn't have really achieved any other way outside of using machine learning. I'll give you an example. One of the things is when we're processing emails for people, we're building up a contact database for the company. And so when we're building up that contact database, the user wants to sync those contacts over to their CRM system. Sometimes we're generating 100,000 contact records that weren't entered into the CRM system. But what we were seeing before we used ML.NET was that we had a bunch of contacts that were actually they were like Azure billing notifications or the receipt from Uber, like whatever email address sent that thing over, that email address is not really a human, but it's not spam either. So it's not getting picked up by the spam filter. So, but you wouldn't want that to be in your CRM system. So we were able to build in a matter of days a model that would analyze the HTML structure of an email and then using a binary classifier tell me, is this email generated by a human or is it generated by some sort of automated system? And using that, then I was able to feed that into the process of determining what to sync over to the CRM system. So it was basically reducing the number of contacts by about 80% that were junk that were going. So if we were sending over 10,000 contacts that were junk, we reduced that down by if we were sending over 10,000 that were junk, we reduced it down to like 2,000 that were junk. And then we had other things that we layered on after that to then reduce the rest of those. But ML.NET was huge for us because it let us quickly figure out which ones were human and non-human emails. And then we've done some other things like phone number validation. We built a model. All it does is validate phone numbers. You just passed a phone number, and it can tell you, okay, is this actually a phone number or is it not a phone number? Like, is it just a series of numbers, or maybe it's like a number that's in like a file extension or a file name, and it can figure that out for us.
That's awesome. Yeah, it must have been a lot of cost savings as well, not to have so much non-necessary information in the database as well. That's awesome.
Oh, yeah, absolutely.
So having used the library for quite a while now, what are some things that you are missing? I mean, nothing is perfect. I'm sure this library is going to become different in the future. What are some things you would like to see added?
Well, I mean, for me, there's two things I'd like to see. The first is actually not the library so much. It's actually just examples. I mean, for me, since I'm not a machine learning expert, and I think you're going to get, I think you guys probably have a lot of .NET developers who just need to solve a specific problem, and they just need some kind of examples to push them kind of in the right direction. Just kind of more examples. For me personally, I just kind of need more examples around text object detection, like how do you find different types of text inside text. And then the second would be you guys have a really good, I think you have a really good coverage of lots of different models. One of the models is called the latent Dirichlet allocation model. I think that's how you say it. I'm not really sure how you say it, but it's a model for topic modeling. And the model can generate the topics, but it doesn't tell you what the names of the topics are, or what the words are that compose a topic. And so without that, it's kind of hard to figure out what are the topics that you've just discovered. Does that make sense?
Absolutely, yeah. That's great feedback. Thank you for that. Well, Paul, it's been great talking to you today. I really hope you're enjoying the conference as well, and we really appreciate you sharing your experience with us. So thank you very much.
Thank you.
All right. Well, welcome back, everyone. That was a fantastic talk by Daniel just earlier on Jupyter Notebooks and MLNet. Thank you very much, Daniel, for giving that. And now I would like to welcome Bart here to the conversation. Welcome, Bart.
Welcome, everybody. How are you?
Good. How are you doing?
Fantastic. Happy Saturday.
Yeah, happy Saturday, Bart. So you work for Microsoft, right, as a principal architect?
That is correct.
And you are focusing on AI and machine learning in your day-to-day job?
That's correct. I actually have 2 roles at Microsoft. So at Microsoft, we always talk about you either fall into 2 buckets, either build stuff or sell stuff. I kind of fall into the sell stuff. So
All
I
right.
sell AI and ML. And I also lead our worldwide AI community, which is responsible for our field readiness and bridging the gap between engineering and sales.
That's great. So how did you first come into contact with MLNet?
So ML.NET, as even though it's an open source product, it is run by Microsoft. It's been around for a couple of years now, and I've been using it since I believe 02, 03, which is in June, July of 2018. So I've been a C# developer since C# 1.0, and just it was a natural fit for me to take a look at it and see if how can it help me, and it has, over the past 2 years, has shown tremendous value for myself and my customers.
That's awesome. And today you're going to talk about ML.NET and Blazor, right?
That's correct. I'm going to actually do a cross section of 3 topics, and see how I do in 45 minutes. So we're going to do decision analysis, Blazor, and machine learning with ML.NET.
Super exciting. And I know you have a lot of content to cover, Bart. I'm going to let you start directly. So enjoy, and we'll talk about questions after your presentation.
Thank you. So good morning, good afternoon, and good evening, everybody. My name is Bart Chinsky, and we're going to talk about decision analysis with ML.NET and Blazor. So I realize it's Saturday, so I thank you for everybody who is spending their weekend, learning this great content and listening to some great presentations so far. So what I'm going to do is, lay the land of what we're going to be talking about in the next 45 minutes. So there's going to be a cross section of 3 topics that I feel will give a good good content-based introduction across 3 different personas. So if you're a software developer, .NET developer, not super familiar with machine learning, there's going to be something for you around architecture and .NET and AI infusion and Blazor, and how Blazor can surface machine learning algorithms and models. Then we're also going to talk about some more specific advanced features in ML.NET. A lot of questions that we heard yesterday and today about that you'll see how I can infuse more advanced features that may not be in ML.NET currently, but you want them. And for example, explainability or some more advanced training options. And then finally, we're going to be rounding this all up in the context of decision analysis. So if you are non-technical, not a developer, not in the machine learning, how can machine learning bring value to you in a business scenario? So this is going to be an advanced machine intelligence conversation that's going to have this round of business topics surrounding it. So let me introduce what a decision is. So basically, to me, a decision is a selection of choices. So choices present themselves every single day to us. So for example, majority of us, before the COVID pandemic, probably drove somewhere, whether it's to work, drove to a park, drove somewhere, drove to a gym, and we made the decision on what route to take. Now we could take this, empirically with our own evidence that we have amassed during our historic times driving the same route over and over. You may look at the time of the day, whether there's construction on the street, whether there's a toll versus not, whether you want to take the scenic route. And these are decisions that are a small example of a decision that you make every single day, potentially. You can make this decision as an expert. You know the roads that you've taken. You know what roads get you quicker. You know what roads just work. Or you can take it quantitatively, and fire up Bing Maps or Google Maps and say, I want to go from point A to point B. Show me how to do it. Tell me why. Tell me why, because there's traffic patterns here. There's an accident here. There's the traffic jam here. And this is essentially a very small example of a low low stakes decision that we make every single day. So us as humans make these decisions constantly. So what I'm going to talk about is how you can actually take these everyday decisions and potentially augment these with machine learning and take advantage of quantitative analysis systems and be able to now drive more sophisticated analysis, more sophisticated decision-making capabilities with machine learning. So what I'm going to do is actually work bottom up. So this is meant to be an interactive session. So what I'm going to do is I'm going to actually have this demo live, and I'm going to reference to it back and forth. So there's a link here, AKMS/BaseballML Workbench. You should be able to hit that link live. It is hosted in Azure, so globally scale around the world. It is what I call the baseball machine learning workbench. So let's talk about in the 3 personas that I introduced earlier. So the business scenario here is you're a sports writer that focuses on the sport of baseball, and you basically need a decision system that can assist you with the understanding of the performance of baseball position players. So that's essentially what this is. This is a small little application delivered in a workbench format that allows you to interactively and explore the different decision potentials of baseball players using baseball data. So the software details, this is an ASP.NET Core 3.x application using server-side Blazor. It is containerized with Docker, so it can run locally. And also, what's interesting here is it can actually scale to millions of asynchronous communications using something called SignalR. And it leverages something that was introduced the last couple of days, the prediction engine with scaling. So it has a fluid design for desktop and mobile browsers. So this is a screenshot here on the left you're seeing where how it looks on an iPad or an iPhone. The machine learning details that are inside that are powering this stuff. There is multiple in-memory machine learning models that are loaded in the memory. There is data that is loaded into memory as well. That's a historical baseball data from 1876 to the current 2019 season. So we have almost 144 years of data inside being analyzed for performance. And the machine learning models that have been trained are surfaced using supervised learning, simple binary classification. And basically what it does is it takes the aggregate of the position players' baseball information across their entire careers, and then basically it uses labels as whether the baseball player made it to the Hall of Fame or was on the Hall of Fame ballot. And simple binary classification problem, and then we're going to see how this can be surfaced using what-if analysis as well as the decision-making capabilities using machine learning. So what I'm going to go over, I'm going to actually go through the application now, and we're going to talk about the baseball Hall of Fame prediction. So please follow along the slide as I talk through this. I'm not going to cover this slide. I'm not going to read it. I'm going to actually cover it live in the demo of the application. So let's get to it. All right, so what you're seeing here, if I go into the home page, maximize this a little bit bigger, and you can see the welcome screen. So the welcome screen introduces the different scenarios. Currently, I have 3 scenarios available. There's a roles engine scenario, a single model scenario, and a multiple model scenario. The about resources here is I wanted to draw your attention to first. This is my contact information here. This is the core information where you can get a source code, the Docker information. I iteratively update this project once or twice a week. So you get the app when it was last updated. Baseball season obviously is cut short this year, but I update the baseball data with the as it comes in. And also, as we talk about decision analysis, some of the decision theory frameworks, here's when you can actually get some of that information here with these resources here. So let's cover the crux of the application, and we're going to quickly go through the functionality. And then what I'm going to do is allow you to play interactively with this as I'm going through the content, and we'll circle back to it. And so as I'm talking about certain concepts, some advanced concepts, I'm going to refer back to this application. And obviously the link is live. It's going to be live. It's been live for about a year now, and I plan on maintaining it. So this is going to be around and going forward in the future. So you might get this attempting to reconnect error here. That's a signal are reconnecting. Every single time there's a pause and somebody is every 30 seconds, there's no interactivity that attempts to reconnect. So let's go to the what if rules engine. So the first one is what if analysis using a rules engine. And the rules engine I have materialized here, this very simple rule engine, is the rule of 500. So if you are familiar with American baseball, basically the rule of 500 says that if you're a position player and have attained 500 home runs in your career, you will make the Hall of Fame. So here we have Mike Trout pulled up, is the default selected option. This is his active. This is his current statistics as of at the end of the season of 2019. So you can see he's got 285 home runs. This is active information. I can do dynamic predictions here based on what if analysis. So I can actually, what I did here is linearly scale the information. Let me reload this real quick. I can actually linearly scale this information per season averages and actually predict, get an understanding of where his season statistics will end up based on how many seasons he'll play. So as I'm moving the slider left and right, you can see the seasons played changes. So I can draw your attention to the bottom of the card, you can see this is interactive and dynamic. Now you can see something's happening here. So as I drag to the right a little bit, it turns green and turns red. So when it turns green, I hit the threshold for 507 home runs. So that rule of 500 threshold is being met. So what's happening here is that once I hit 500, this what if analysis system, this decision support system is telling me that if Mike Trout plays 16 seasons, what if, and based on his average of his performance in his career, he will make the Hall of Fame because we're predicting that the rule says it's over 500. So conversely, if I scroll down, obviously it gets less and more. And here you can actually pick all your players. So every single position player is available here. You can scroll down, sorted by years. If it's not available, please type ahead. So for example, if I wanted to type in, Babe Ruth, I can select Babe Ruth from the in-memory database, select Babe Ruth, and pick some. And as you know, Babe Ruth has, if you know follow American baseball, Babe Ruth has one of the highest home run totals ever, 714. I believe he's third all time. So obviously, because he has hit 714 home runs, he makes it over the 500 home run threshold, and he now is considered to be our rules engine is telling us, yes, he'll make the home run. He will make the Hall of Fame. So I'm actually scrolling left and right. And you can see you can down predict him, and what if Babe Ruth played less years. So what this system is predicting is a Hall of Fame induction. And the Hall of Fame induction is basically based on your career statistics that you have amassed over a certain amount of years. And after a certain set of years of being retired, you are now eligible to be on the Hall of Fame. And a set of experts, sports writers, pundits, vote on you being in the Hall of Fame. And some rules have materialized in the past, like the home run rule and other rules, where you can actually now be able to say, hey, if it's 500 home runs, let's make it easy and have the conversation that Babe Ruth or other players should be in the Hall of Fame. Now, what's interesting here is that where did this number come from, right? The number 500 is a little suspect. It's a very round number. It's why isn't 505? And that rule is a simple rule engine that's been around for almost 3 decades now. Where that if you could go to Wikipedia right now, look up that rule of 500, and it's a static rule. It hasn't evolved. Some there's better metrics that are out there, like the gray ink model, the black ink model, that do a little bit more sophisticated metrics beyond just the home run feature. So can we use machine learning to improve this and make it a little bit more interesting? So if I go into the single model here, this is now powered by a machine learning model. So it's different here between, if I click on this one here, I'm not just getting a true or false binary, yes or no, this person is in the Hall of Fame or not. I'm actually now getting a probability. And now I'm actually going to make the argument in this conversation in the next half hour or so that this probability number is going to be the anchor for a lot of the decision making that you want to make with any kind of quantitative-based system, that's math-based or statistics-based, like machine learning. So here now is still different. Now I'm not just going home runs over 500. Now I'm getting a probability. I'm actually quantifying the uncertainty that that Mike Trout will make the Hall of Fame or not make the Hall of Fame. I am not just getting a number that I have to hit over 500 home runs, and I get a binary yes or no answer. So this is a monster improvement of this system already by surfacing a probability over just a simple if-else rule. Now, what's interesting is, where did this home run rule come from, right? This home run rule came from a set of experts, these human experts that have in the past just decided, this is a nice round number, make it, let's call it the rule of 500, and it's been around for a while, and let's keep the rule super simple. But it's not really, the predictive power of that rule is not really that great. And what's interesting with the probability is now actually I'm actually having a quantifiable system, decision analysis system that can actually now reduce the uncertainty to a point where I can actually be pretty sure when I see a probability of 0.55, where I can be very, very confident when I see a probability of 100, assuming the models are correct, that this decision is valid or invalid, or how close am I to this decision. And this actually allows you to make not binary decisions, but actually allows you to do something we call decision thresholding. This allows you to get a comfort level with your decision probabilities and give you ranges that you can actually work with. So if you look right now, just for illustration purposes, I start from red at 1 from Mike Trout. And as I slowly slide over and as probabilities kind of go up, you can see it turns orange, turns light green, green, and obviously then you're very dark green. So you can actually, with probabilities, you can actually have decision thresholds that you're comfortable with. And obviously this is well understood with precision, recall, and other advanced metrics that can actually give you a better understanding of what those means, confidence interval levels, confidence levels, that you can actually now map out into a level. Whereas before, we did not have a interval. We just had a number that we just said, a magic number, 500, that we had were over or below. And that number came from these human expert systems, humans that decided that, hey, this is what it is. And it has not really stood the test of time. It has not evolved with the data, as it's very biased. This is biased towards hitters that have home run power. It's biased towards players that don't hit a lot of home runs, but maybe get on base a lot and things like that. So it takes us a little further. So I have a simple model that predicts Hall of Fame induction, and I'm going to draw your attention to this what if multiple models area. So now I have multiple models, and I actually broke the problem and scenario down into 2 parts. Now I'm not only surfacing a probability of Hall of Fame induction, but I'm also surfacing the probability of being on the ballot. So before you actually make it to the Hall of Fame induction, you actually make it on the ballot, and you actually get multiple rounds of being available on the Hall of Fame ballot. If you hit a threshold of 75%, then you make it onto the ballot and you get make it into the Hall of Fame and you get officially inducted. So what I've done here is now actually you can use the probability and reduction of uncertainty using statistics and machine learning to actually look at the person's career like this. So now as Mike Trout has played, his probability of being on the ballot is increasing, is valid. His ballot hall, is very, very high that he's making on the ballot. He's not really there yet on the induction, but now as his career will progress, now he's going to actually eventually tick off both boxes. So this is actually interesting in decision analysis, breaking down the decision into a prior model or a post model that you can actually now use to actually make your comfort level or how happy you are with decision, essentially what we call confidence, to surface itself. So if I pick another player, somebody like more famous, maybe Pete Rose. Pete Rose, as you guys know, he's not in the Hall of Fame for a multitude of reasons, but he, based on purely statistics, based on just pure unbiased, machine learning models that are fed historical data from 1876, he should be obviously on the ballot, and he should be on the Hall of Fame. So I surfaced Pete Rose because this shows you a decision threshold with two probabilities that's actually surfacing a user, an example, an observation. Let me click on. I don't know why it keeps on reconnecting here, but it's surfacing a observation, Pete Rose, that actually is not in the Hall of Fame through other reasons. Gambling. He's banned from baseball from gambling, but actually from pure empirical data, statistical data from machine learning and machine learning models and baseball, he clearly should be in the Hall of Fame. So I'm going to pause there. I'm going to let you play with the stuff, play with your favorite baseball player. And I'm actually now going to talk about a little more details of how this was built and how this works, and a little bit more on the decision analysis concepts. So like I said earlier, this is whether you're on your iPad, your iPhone, your desktop browser, you're communicating via SignalR. This is going through Azure App Service, going down into a decision analysis framework powered by machine learning models that run inside Blazor and with machine learning models and ASP.NET Core, and instrumented with App Insights. So this is a very simple sequence diagram that you can look at if you're a .NET developer or you're a software architect, how this was essentially built and what the sequence of events look like. So from the client through the server back down. And so what's interesting is SignalR is actually the one that's actually rendering the delta. So it's actually sending down the delta of the HTML that as the HTML is changing down to the client. So that's why it's really the predictions and the HTML are rendering super fast. And what's really nice about Blazor is that it allowed me to write that entire application in C#. There's not a single line of JavaScript or any additional components, Python, R, or anything like that I had to write to make this work. This entire application is 100% C#. No JavaScript, and what's really nice is that Blazor allows me to facilitate some complex visuals and animations and asynchronous communication without having to worry about JavaScript communication, things like that. It's all handled for me through the Blazor framework. So this is cross-platform. This will run on Linux, which I'll show you an example if we get time, and it runs on a Mac, and it also runs on obviously Windows. So compare and contrast. So I showed you that magic number of 500, the rules engine, how it kind of thought about that problem, and the machine intelligence system. So the machine intelligence system, I did not have to program any explicit rules. All the rules were kind of figured out for me. They were dynamic. The rules are learned and constantly can adapt. So as I get new data, as new baseball seasons are played, I actually now I have more and more training data. The system becomes smarter. As the baseball rules evolve, the predictive power as well as the persistence power of the features gets surfaced. And that's actually a very important concept, because many times we build machine learning models, we look at what's the predictive power of certain features, what's the importance of these features. Well, we have baseball data here from 1876. It's a very unique scenario where we have data from almost 150 years, and which features have not only the most predictive power, but also which ones are the most persistent across 150 years of baseball data to predict, the outcome of being inducted to the Hall of Fame. So players who have got inducted in the 30s, 40s, 50s, in the 1930s, 40s, 50s. Now, 100 years later, 80 years later, how are they getting inducted? Or is it the same? Is it the same feature importance, same predictive power, same persistence? And that's what machine learning can figure out all the signals from the data for you. It's a lot easier to do that than a human system. Now, human system, if you look at these expert system, what's expertise, right? If you think about what the definition of expertise is recalling your past information, past experiences, and then being able to articulate them into with knowledge, and then be able to make a decision on it. So it's very similar to that example what I showed you with the car driver, right? If you did not have Bing Maps or Google Maps or Waze or those applications, you would make your decisions based on past experiences. You'll continuously drive the route that you'd have based on how many times in your head have you remember that you think this is the good route, but it actually wouldn't allow you to find new routes, find better routes, find faster routes, find routes that are newer, that are emerging, new roads. And that's what the difference between a rules-based system and a machine intelligence system essentially is. So it's harder to maintain. It can be difficult to change. It relies on human error, human faults. There was a study done by a gentleman called Paul Meehl. He actually took 150 different research studies, and that compared human-based decision systems to simple statistical models. I'm not even talking about machine learning. I'm talking about like probabilistic systems, small actuarial systems, Monte Carlo simulations. And he found only 6 studies out of the 150 that showed. Found only 6 systems out of the 150 that actually where the humans were able to perform just as good or even slightly better than what these quantitative systems can do. So basically, the evidence shows us do the math, and it doesn't mean crack open your latest calculus book or algebra. Do the math with machine learning. Let the mathematics and statistics that are powering these machine intelligence systems, let them do that for you. So as I mentioned here, one of the first things about decision analysis, let the decision statements be written for you. So, if you've seen the Titanic data set, for example, something simple here using a single decision tree. That is an example of a generated rules engine with a decision tree powered algorithm using machine learning. So the decision tree family algorithms, AdaBoost, XGBoost, random forest, light GBMs can provide you this kind of inference and understanding of inference using these kind of decision trees. And what's interesting about if you go back to the application, you look at the rules engine and then the model engine. What we're doing here, and what I'm doing here, is saying, you know what? Those expert systems, that expert rule of 500 that was generated by the expert sport systems that's been around for 30 years, I don't want your expertise. I don't trust your expertise. Can I do better? And I'm actually taking that power and putting it into the model, and I'm actually calling my machine learning model the expert. So in this case, my machine learning model is the expert, and I can actually now go ask the model, have the conversation with the model. How did you arrive at this conversation? How did you arrive at this conclusion? How did you make a specific prediction? How are you performing? How are you biased? And this is actually the coolest part, I think, of implementing a decision analysis system using machine learning models as experts, removing the human error, the human overconfidence, the human poor performance, the inconsistencies of human performance, and replacing it with a consistent, expert, 24/7, doesn't sleep, doesn't mind working overtime, doesn't mind getting paid, and leveraging your machine learning model as your expert. And these are the examples of questions I can ask him. Your model performance, your performance variance. What are your decision drivers? What is your inputs? How do you compare to other experts, your other models? This particular prediction, how uncertain are you? How confident, how happy are you with this specific prediction? And actually, you can have this conversation with your machine learning model as an expert using something we call explainability. And this is where I'm going to go into our next demo and set this up. So we have a lot of questions about, does ML.NET have this PFI? You heard Justin talk about FCCs and PFIs. And I'm actually going to show you something, what I think is pretty cool and super advanced. It has, this is done by one of the premier thought leaders inside model explainability. He actually has this family of products called Dr. Y. I'm actually going to focus on something called Daleks. And this actually has an entire pyramid of understanding your model and treating your model as an expert. So if you go down left-hand side, this is your individual predictions. On the right-hand side is your global predictions. And this is a suite of open source predictive and statistical metrics and features that you can actually implement and on top of your models. And what's fantastic about ML.NET, as Luis and Bree articulated yesterday, it is an open source framework. You can do whatever you want with it, and you can host it in a wide set of areas. It's open source, and it gives you a flexibility to do this kind of stuff. And this is what I think want to want to show you and convey to you as we conclude. So what I have done is encapsulated a set of machine learning models, same ones that you see on the front end Blazor application. It is actually being hosted in Azure Function. And what I'm doing here is actually leveraging R. So we're going to see some R code for a little bit. I know it's an ML.NET talk, but it's pretty cool. You're going to see some R of these R interfaces that allow you to explain your model in a very, very sophisticated way, things that are not really available in commercial software yet. Nothing like this exists. Allow you to flow this through this open source framework of explainability, and being able to have that conversation with your expert, and then leveraging ML.NET, your models that you have built with your model builders, your existing examples that you saw with the great talks today and yesterday, every single thing. All these models can be interpreted using some of these concepts. So let me actually show you how this kind of works. So this is available on GitHub. This is hot off the presses. I actually checked this in yesterday. This is the R code as well as the Azure function that you'll see in a second. This is going to be available. So we're going to actually run this on a Mac. As you can probably tell, I'm on a Mac. This is using Visual Studio for Mac 2019. The Azure function is in debug mode. It's, this can be run on Windows if you wanted to. But I'm using a Mac engine just to highlight the cross-platform capabilities here. And the nice thing is, because I have R running locally, this is going to be ideal for that situation. So just to show you, it's running locally here. I'm firing a postman, sending some probabilities over some feature examples with batters. I'm going to send that over. So this is sending over some four historical batter career samples, and I'm getting a probability back. That's all this function does. Essentially sends in batters, baseball players, and gets out probabilities. Now, what's really interesting here, now I'm going to actually navigate to RStudio here. And I'm actually going to not walk through the code, because this is not an R talk, but I'm actually going to show you that these ML.NET models wrapped inside an Azure function can now be interpreted in a very, very cool way. So now it goes well beyond what the functionality is available inside ML.NET. Now I'm actually going way further than what PFI and FCC and some of the performance metrics that are available in ML.NET. You have the ability to now generate order metrics if you wanted to. Every single time this is running, these processes are running, this is actually calling my Azure function right here locally and sending in a set of statistics and machine learning interpretability concepts over to my models. My models are spitting out back probabilities. This is churning it, interpretizing it, and giving me the information that I need. So for example, the first thing I might want to do is something really basic, right? What's my model performance? And I think this is everybody's seen this before. This is your accuracies. These are your FCC scores. These are F1 scores and things like that. So as you can see right here it's being called, call live again so you can see it maybe, so you can see I'm not cheating here. So I'm going to call this. This is cached. So let's now run the performance. And you can see right here, I get my recall, precision, accuracy, AUC. This is nothing really interesting. This is like your top of the pyramid sliver here. But now you can actually go a little further here. Now you can actually go and actually run things like partial dependency profiles. So let me take a single feature and see how that single feature interacts with the different features here. Well, it is running. I'm not sure why the terminal is not updating itself, but it's definitely running, because otherwise it would not be working. So now what's actually interesting here, now I'm actually getting some sophisticated stuff that does not exist inside ML.NET. Actually, I can get a partial dependency profile of a single feature, in this case, total player awards, how it interacts, and what the probability gain and lift is for a particular set of values. So as a player plays, he gains some awards, all-star games, MVPs, triple crowns, silver sluggers. And as these awards materialize, there's a certain predictive power that is associated with that. So actually, it starts moving up a little bit, and certain models, I'm using a light GBM model here. I'm using a GAM as well as a fast tree. And you can see the different models here perform a little differently. Each one has learned something a little different than each other. So this is stuff that you can actually now, you have the data, you can actually plot these, you can actually look at these, and you can actually, and these are interpretations of your ML.NET model. These are, I'm calling into the ML.NET with Azure Functions. So let me go through a little bit other features here. So here I can do partial dependency plots. I can do feature plots. I can do oh, this is a really interesting one here. I want to run this one. This one actually, if you go all the way down to towards the bottom of the pyramid, now I can say, okay, I got my performance metrics. I got my how everything how the globally the model works. How are you as an expert compared to other experts? Basically, how are you as a model compared to other models? And what this is actually going to do is take the model, break it down into different cross-section areas, across different features that you have, across the different specific areas that have the highest levels of probability power, and actually then give you a cross-section of your leader model versus your secondary models, and see what areas have the more predictive power. What this means is this allows you now to dissect your system into a smart ensemble, where if you're seeing features for a certain set of criteria, you may want to route it to one-sided model. If you see a feature, for example, where total bases and home runs are the most important, you may want to route to another model. And this is essentially what this is going to do. Let me show you this real quick. So this is a funnel plot. And on the right-hand side, I have my my LightGBM on Hall of Fame model. And on the left-hand side is my champion. And then I have my contenders. I have my fast tree and my GAN. And you can see my LightGBM model is actually pretty good across the board. But you can see in certain areas, in certain small cross sections here, in areas where years played is low, where hits are low, where doubles are low, some of the other models are performing a little better. Overall, LightGBM should be used almost exclusively, but for areas where I'm getting small players that don't have many years played, I'm actually getting more predictive, better results, more performance out of other models. So this interpreted my MLNet models with functionality that's open source, allowing you to do that kind of stuff. And this is what's really neat about this stuff. But let me show you something a little more interesting. So going back to the Mike Trout here. So remember I asked you a question. Well, you can ask global questions. How good is your performance? How good do you compare? How happy you are with the performance that you have done overall? But now you can ask it questions like, I can have a conversation with my expert and say, well, how did you arrive at this 34%? How did you get, what's the breakdown of this 34%, right? And you can't really ask a human to quantify that. Like, oh, 4% is this, 2% is this, 20% is this. It would be near impossible for somebody to statistically with significance prove that out to you. With a machine learning model expert, powering your decision analysis systems, you can do that. So let me show you how that looks like. So I'm not going to run this. I'm just going to show you the end result here. So just remember these two numbers, the 34.25. So I'm actually going to show you the breakdown of this probability. So it's 34.2. So this is a breakdown of how my machine learning model, ML.NET model, arrived at this conclusion. So it arrived at this 34.25 prediction by saying, and because Mike Trout's MVPs are 2, he has 13 total player awards, he's got 8 all-star appearances, he has this slugging percentage, blah, 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 and then going through all the 20 different features that have been used to build this model. What's actually super interesting is not only do you get a breakdown of the more important features individual for each this particular prediction, you also get the weight of this prediction. So you can say, if I took out Mike Trout's all his all-star appearances, made it 0, his probability would actually drop 12 points. If I took his runs away, his probability would drop 0.00. Now, obviously, this is a little bit naive because not all as you guys know, this is not these variables are not independent. You can't just do that. You can't just take away hits and have home runs. It wouldn't make any sense. But it actually gives you the interactions and the breakdown factors between these predictive features. And that's why I think this is what's so awesome. This functionality is not currently available across all the ML.NET models. And what this allows you to do is allows you to do black box comparisons. So for example, you can compare your ML.NET model using this technique to a neural network, to a R model, to a IBM Watson or SAS software proprietary models. It allows you to now take ML.NET into up the game a little bit, and allows you to bring in functionality that's only been available in these commercial products. There's some really cutting edge stuff in that Daleks framework, which I would recommend highly checking out. There is model drift areas, test train drift. A lot of these questions that were coming up today, bias frameworks. All these things that you normally have to pay 6 figures or 7 figures to have, you can now actually extend your machine learning.net capabilities that are not there yet using some of these advanced features. So now this expert I can actually say, hey, how did you get this probability? My machine learning model is having a conversation with me, telling me these exact things. Now, obviously, this goes a lot deeper. I actually you can see this is just for one. This is one set of features. Actually, the amount of explainability that I have within just one particular prediction and a global performance, there's actually about 60 of these charts and data points. So you can actually have a very sophisticated rules engine that can actually give you very much comfort into what you're trying to attain and predict. So what I wanted to kind of talk about real quick, I know we only have 4 minutes left. I know I'm going to speed up real fast here, and I'm actually going to talk about how do real systems actually look like. So I actually had a conversation with the chief data scientist at Facebook here. This is my Facebook profile, my old Facebook profile. It says I work for Microsoft, and I was actually being served Microsoft ads, and I actually asked, the data scientist, you guys are losing money on me. Why would you serve me Microsoft ads? Can't you just do something like this? If I work for Microsoft, do not show me Microsoft ads. I mean, that would be some pretty obvious statement. The amount of rules that Facebook would have to write for you to actually for this to happen would be insurmountable. If you have a system that's peppered with these if-else statements all over the place, Facebook would be completely unmaintainable. They made a decision several years ago to use ad serving to be completely autonomous, highly prescriptive, highly hyper personalized to you, completely 100% based on machine intelligence. And until their systems got there, this actually got solved about a little over a year ago. Until about a year ago, until the algorithms got smart enough, they actually were still serving me ads because the systems were still thinking that they did not learn that if I work for Microsoft, do not show me Microsoft stuff. So this is kind of like Facebook's using this, right, to power their entire ad serving, which is their entire multi-billion dollar business. And this essentially, and I'll close out with this. And at the end of the day, there's a huge opportunity here, and this is where we're seeing this at Microsoft, where building these decision analysis systems aided by machine intelligence. So decision support systems and decision management systems, being able to articulate with your internally with your company, with your startup, with your own hobby, or with your own customers. How do I build these DSSs and DMSs powered by AI and machine learning? Show them the value that you can actually do this with machine learning. And there's millions and millions and billions of lines of code of .NET out there. So these systems that have these old legacy rules engines, they're screaming to be updated with ML.NET and machine learning systems that are autonomous. So I highly recommend. There's an opportunity here. There's a cross section here where there's an opportunity to replace these systems. A lot of .NET systems, a lot of .NET code. Learn the ML.NET, learn that stuff, and then be able to not only just infuse it, not just drop a model in there, just to have a model in there, just to have AI, but think about it in the context of decision analysis. See how it can frame those decisions better, and then understand that you can actually make the system that's probably in there that was built by humans with the magic numbers like 500 with the if-else statements. It's not going to be hard to beat with machine learning. The evidence shows that if you do the math, if you do the statistics, like I showed you with the research, and if you go look at the resources, they amplify this. you're going to be in a very sweet spot. This is low hanging fruit right here. This is where we see internally at Microsoft, we see a lot of tremendous value here and opportunity here. So just wanted to close out with this and hopefully get everybody excited. How the cross section can lead to some opportunities for everybody. So I think I'm over at time. Am I correct? 1 minute. Oh, we ended 1 minute earlier. I do have some additional information here. High stake decision analysis. I have on my GitHub. I actually have some examples of a DSS and DMS. So feel free to go on my GitHub. All the data is available. The baseball data is available. It's free. The training jobs for the models, the Blazor application, the Azure functions, some more sophisticated web APIs, gRPC APIs. I have some R and Python code available there. I have Power BI dashboards using it. So if you're interested in baseball data and you just want to play around with a data set that's cool and pristine, that has 150 years of data, that's super interesting to work with, I highly recommend. It's a fun data set to play with if you're into sports or in baseball.
Well, thank you, Bart. That was a very inspiring and great talk. I definitely learned a lot myself here. And
Awesome.
we're going to see here what kind of questions we have on the chat here. Luis in the chat says, knocked it out of the park, Bart. So many possibilities to upgrade existing legacy applications. Best of all, you get to stay in the .NET ecosystem. Absolutely, yep. I think, right?
Absolutely, yeah, definitely.
All right, let's see. Does anyone else have any questions in the chat here? Guess one from me here. I guess you work a lot with both R and .NET, right, Bart?
That's correct.
What do you feel like are some, I guess, differences, or like, do you prefer being more into .NET than .NET, or do you prefer being in R? And what's the pros and cons there?
It's a simple decision. I mean, the .NET has been around for 20 years. It's changing rapidly with .NET 5 and .NET 6. So you can actually do cross-platform applications. What runs on Linux, runs on a Mac, obviously, as you guys can see. So you have the entire developer ecosystem where if you want to build your company around .NET, that's the way to go for the software development. Software developers are there. That's where the community is. R is great for the statistics. I would never build a web server in R. I would never build a distributed system in R. R is there for essentially your training, your statistical packages. And I know there's some companies like R studios doing some of the work with hosting Shiny server, but it's really dribs and drabs. I actually look at them as complementary languages, not really competitive.
Okay, great. And there's a question on the chat here. Have you ever considered using something like an F# R interop?
Yep. Actually, I did a little bit of F# about 10 years ago, 11 years ago. F# is interesting, and it does have the functional aspects and immutability. It allows you to do some interesting things when you're doing a lot of querying and understanding interactions between objects that are dynamic. So if you had a complex system with in machine learning with a lot of quantifiable information like financial information, that's where F# we see a sweet spot for. It's still around. We still have some really big customers that still use F#. But with ML.NET, what's nice about this is you could obviously port that to F#. I don't have any F# examples in the last year or two. I've not worked with it.
Okay, great. Another question here on the chat is decision analysis using Power BI powered by ML. What are your thoughts on that?
Yeah, absolutely. So it's actually super interesting, and we actually work with customers on some of these. If you work with Power BI, there's multiple different ways you can actually architect your serving layer, which is your Power BI layer for this. You can actually build infuse ML.NET jobs in your data factory jobs. So essentially in your data movement and your data analysis, have your inference be there and be persistent inside your Power BI model, or you can actually do it live. So what's really nice, some customers are using Power BI Desktop, building RESTful functions, exposing them as Azure functions, and then they actually have live machine learning predictability in Power BI. So the extensibility of Power BI, coupled with the fact that ML.NET is so portable, it's free. You can put it however many places you want, and it's still zero, right? Microsoft doesn't charge you any money for it. So so absolutely, we see a lot of use cases there, especially because we do have AI integrations in Power BI, but they are what they are, right? So there's going to be a roadmap set of features. There's going to be things are going to be missing. Some things are going to be 3 months away, 6 months away. But with extensibility with ML.NET and Power BI, you can pretty much do whatever you want. So whether that's
Cool.
network stuff, training images, or statistical stuff.
Great. And I think the final question here is, I've seen on your repo that you also work with Power BI. Do you usually first go and drill around with Power BI and build your models with MLNet, or do you have another workflow?
Yeah, so that Power BI was just an example I did 5 to 6 years ago. I have no idea how old that is. That's actually a research paper that I wrote a while ago around the different eras of baseball. And I figured, just to put something out there, just so people can see, that Power BI report dashboard actually highlights we talk about predictive power, but the persistence power of some of the features. So you can see some of the home runs or stolen bases or strikeouts, for example. They don't have the consistent correlation across for over 150 years. That was just an exploratory analysis, just to show one of my talks to show how easy that is. So these concepts, even though the baseball data is kind of obvious, it's not easy to understand. I don't know for anybody who's on the chat who has ever seen the movie Moneyball with Brad Pitt in 2011 about baseball analytics. So the software I worked on is shown there for a little bit, just to highlight how easy it is to use, for a movie audience, right? And that Power BI is just a visualization engine highlighting that. So behind the covers, it was meant for a little bit more statistical analysis and exploratory analysis.
Cool. Well, thank you very much, Bart, for your talk. You had some
you.
great feedback in the chat. You should definitely check it out. And we appreciate you coming in to speak with us here.
Thank you, Alexander. This is great. Thank you for having me.
Absolutely. And coming up at the full hour here in just 9 minutes, we got Veronica talking about chatbots with MLNet. Definitely tune in for that. That should be an exciting talk. But until then, we'll see you in a bit. All right. Well, welcome back, everyone. That was a lot of information. Thank you very much, Bart. It was a fantastic talk. We definitely enjoyed it, and I think we're going to go visit your repo and explore that more. But with us now, we have Veronica. Veronica, how are you doing?
Hi, how are you?
Good to have you with us. And you're a Microsoft MVP in AI, right?
Yeah, that's right. It's good to be here.
Yeah, and not only that, you're also famous from Build.
I had my second of fame there.
Yeah. Well, in what way are you famous from Build?
It was a little clip from conversation between a couple of MVPs with Satya Nadella. It was right before Scott Hanselman's talk, but it was just a couple of seconds.
Wow, we're all very jealous. It's nothing better than being famous from Build. It even beats being famous from TV. So you should get a T-shirt that says that, famous from Build, and wear it with pride.
Maybe I should do it. Yeah.
Absolutely. Well, we are super excited to have you here, and today you're going to talk about ML.NET and chatbots, right?
Yes, that's right.
Perfect. And like any other talk here and the stream, guys, anyone in the audience today, definitely just put questions in the chat and Twitch and YouTube, put them in the Slack community, and we'll make sure to ask Veronica after the presentation. And I think, Veronica, you may also maybe be in this Slack community as well if they have questions for you afterwards.
Yeah, definitely.
Perfect. Awesome. Well, we are really looking forward to this talk, so I won't take any more of your time. The floor is yours, Veronica.
Thank you. So hi, everyone. I'm really happy to be here. And today I'm going to tell you about chatbots and how to make them even smarter with the help of ML.NET. Here you can see my name and my Twitter handle. So feel free to find me on Twitter or LinkedIn. But I'm going to remind you about my social media a little later too. So let's move forward. And before we start, let me just tell you a couple of words about me. My name is Veronica Kolesnikova. I'm a Microsoft MVP in AI. I have a master's degree in information technology. I started my career as a quality assurance engineer, and then I moved to development. And now I'm mostly focused on back-end web development, but I'm really passionate about all Microsoft technologies, C#, .NET, Xamarin, machine learning, obviously. I really enjoy cross-platform solutions, whether those are Xamarin solutions or cross-platform bots. And my hobbies are dancing, traveling, and aerial yoga. So let's move to the content. What's a bot? It's a tricky question because bot has so many different definitions, and in different environments, it probably means different for different people. They all have different definitions. But in general, I think that bot is a software that can understand what your user wants and either respond with some information or perform some actions for them. I have lots of arguments with my colleagues about bots and virtual assistants. Are they the same? Are they different? Can we somehow relate them? And everyone has their own opinion about that. And my opinion is that bot is the same as virtual assistant. It's kind of in the base of virtual assistant skills. And for example, if you're using Microsoft offerings, and I'm going to mention those offerings later, you can see that once you create a bot, you can connect to different channels. And one of available channel is a virtual assistant, for example, Cortana. So here I have a lot of information that Siri and Cortana bots. We all remember Microsoft Clippy. Clippy is also a bot. And I never used the Smarter Trail from AOL, but I know some people did use it, and maybe they liked it, maybe they didn't like it, but it is still an example of bot. And we can never forget about Tay. I know it is not something that Microsoft is proud of, but it was a great experiment that they actually put out there. if you don't remember, Microsoft created a bot. They put it out on Twitter, but the bot was learning from tweets. So it was improving, so-called improving, because it wasn't really improving. It actually got really bad in the end, and it went down really fast. At some point, the bot became really rude and racist and was posting really inappropriate tweets on Twitter. So Microsoft had to take it down. But for all of us and for Microsoft, it was a great experiment. And now we all know that you can't just let your boat float around social media and learn from all different tweets there. How to create a bot? There are so many different options. Every tech company can provide you tools, and they provide tools both for developers and for business people. So now you don't have to code to create a bot. Here on the left, I have some examples of available channels, but I'm going to mention it in a second. So let me talk about Microsoft offerings. Let's start with the bot framework SDK. I think that's the basis for lots of bots. If you like to create everything from scratch, you know, in most cases, you know what you're doing, you know what technology you're trying to use and how to create a bot, then you can just open up your Visual Studio, add all NuGet packages that you might need, and include bot framework SDK in your solution, and then just start creating the bot from scratch. You can host that bot on your local machine. You can host it anywhere else, on Azure, in other cloud provider, on premises, whatever you want to host it. It doesn't matter. You just start from your local and then move it to different environments. Next offerings is Azure Web App Bot. And you see word Azure, and you probably guessed that it's on Azure. So you can go to Azure portal and create the web app bot. So it will be automatically hosted on Azure. And also, it will have all the benefits of web apps and all the Azure offerings available. So you can connect the app insights, you can see what's going on with your bot, you can get the logs and all of the information on Azure. You can download the base layer, like a framework for your bot right from Azure. So you're not starting completely from scratch. You have two options there, and that will be part of my demo. One option is you can connect it right away to Luis, that's part of the cognitive services, or you can create just the simplest Echo bot and then add things as you go. And next offering there is the Azure Bot Channels registration. Usually when you create Azure Web App Bot, it is automatically has an option to connect to different channels inside that resource. But if you're not using the Web App Bot from Azure, then you might want to create a separate resource that will be called Azure Bot Channels Registration, and register your bot with different channels. And now let's get back to that image that I have here on my slide. So those just some of the channels that you can connect to, like Skype and Twilio, Facebook Messenger, email, direct line, Cortana, different virtual assistants. There are so many different options there. It sounds really easy that you can connect your bot to different channels. So basically, you're building it once, and then you just connect in channels. But there's a trick. You need to remember and think when you're developing your bot solution, how your users are going to communicate with the bot. Is it specific platform that people are more comfortable typing their questions in? Like a messenger. People usually type their questions and requests there, or if they prefer to ask questions using their voice, using speech. So like Skype and maybe Teams, they probably need to support speech recognition or some kind of processing of speech. So it is not really one solution will fit to all those channels. You just need to remember to include workarounds or some kind of checks how user is interacting with your bot. So that's really important to know. Next one here is the Microsoft Healthcare bot. I actually learned about it just maybe a year ago or so, but I think they've been working on it for quite some time. Microsoft Healthcare bot has that pre-built layer of machine learning, I wanted to say smartness, because it has knowledge about some diseases, about some hospital terms and health terms, and maybe some specifics about when people are trying to connect to a specific doctor, that bot out of the box can recommend them something. I don't think that the bot can actually give a professional medical advice to people, but it can at least point you to the right physician. Also, that bot is HIPAA compliant, so you don't need to worry about that part, but it is still open and customizable. There is not one solution that can fit everything, so you can take the Microsoft Healthcare bot as your base, and then depending on what kind of project you're working on, what kind of clients you have, you can improve, you can update it, you can change something, retrain the models. So do whatever you need to do to make your bot custom specific to your client's business. And actually, Microsoft Healthcare bot is used on the CDC website for helping potential COVID-19 patients. So you can see how they integrated it on the website. And I know that there are several videos where they explain what they did there. So definitely check it out. Next one is a little more high level. Power Virtual Agent. It was released last year, and lots of people were able to check it out and test it. And during build, was it last week? I think it was last week. During the build, they really provided lots of information about Power Platform apps that are available, and Power Virtual Agent is one of those apps. So that solution is focused more on people who probably doesn't have any experience in development. They don't write code, so most of them are business people. But it is really easy to create a bot using Power Virtual Agent, and our underlying technology is still the bot framework. and still the cognitive services and some custom tools. But if you use a Power Virtual Agent, you don't have to write any code. It is all there. It's really easy to start. If you want to learn more about it, please check the videos from Build. They have several sessions there. And next one is the bot composer. That was also introduced during Build, but if I'm not mistaken, it was introduced for the first time during Build last week. Now they are working on connecting Power Virtual Agent and Bot Composer. And Bot Composer, it is mostly for developers. So you have several options there. You can use drag and drop options. You can use code options. You can combine those things all together. So you still have your files where you can actually write code and connect some pieces. And also you have UI that you can use. There are also several templates there that you can use. Template for virtual agent. You can connect it to different machine learning tools. It is all available. It is also easy to start, but that is more developer focused. And then the best part of every bot is machine learning. You can't really create a useful bot without machine learning. You probably can try to kind of work around it without machine learning, but then you'll have to write so many different loops and checks and lots of stuff. So better just delegate it to machine learning, create your custom model, train the model, and then use the model in your bot. So in the core of every bot is machine learning, unless it's like simplest Echo bot that you can download from Azure portal. And here I have the whole schema of what's going on in that bot/virtual assistant world in kind of the Microsoft related tools and the tools provided by Microsoft and channels and machine learning tools that you can use. I just basically grabbed that screenshot from Microsoft website from their documentation. I hope they are not angry with me for doing that. I hope it's fine. But you can always go back to GitHub. You can always go back to documentation written by Microsoft because they are great with documentation. I know it wasn't the case just several years ago. Now the documentation is amazing. It is so detailed. They have great examples online. They have templates. They have all the information. And then there are so many ways to communicate with developers from Microsoft, with the community. So it is awesome. Don't afraid just to go there and ask questions or learn something new about bots if you're interested. Here you can see that in the core of everything is the bot framework. And using bot framework, you are building your assistant. You can use cognitive services or you can use custom machine learning tools like our favorite ML.NET, or you can combine, mix and match everything, use cognitive services with ML.NET or with TensorFlow and other tools that you might like. You can connect to different knowledge bases. You can add different skills specific to your bot. You can also dispatch it to third-party assistant. You can dispatch it to a real person that can answer questions if the bot is not able to. You can connect to different channels. You can see it on the left. There are several channels like Cortana and Skype and Teams and all that fun stuff. And then you can accept different types of input tabs if you're using it on probably mobile devices. They can type, your end users can type their questions. They can speak, requesting information by talking to your bot. And also they can use your bot on different devices. Mobile devices, in their cars, at home devices. If you have Echo Dot from Alexa or some other devices from Google or Microsoft, then you can actually connect to your bot and use your bot on those devices. So now let's, I mentioned it. I know it is not the first session of the event, so you probably saw something like that slide lots and lots of times. But if that's your first session, or you just need a little refresher about ML.NET, I'm going to tell you really quick that ML.NET allows us C# and F# developers train, build, and ship custom machine learning models. So I am super excited that I don't have to use anything hardcore like learn Python from scratch or other tools. Though that will be, for me, that will be the next step. I am definitely on top of that. I am trying to learn Python. But since I came from .NET and C# world, it's really easy for me to start with ML.NET using C#. And ML.NET can actually use different scenarios. So here I'm just presenting several of them. There are definitely more. And I'm sure you heard about it throughout the conference a lot, so I'm not going to repeat myself. And in the bottom is the link to ML.NET repository on GitHub. So if you have any questions, you can submit the questions, bugs. You can submit your PR if you know how to fix an issue. I'm sure that ML.NET team and Microsoft there will be super happy to have your code in their repository. And I know that that topic was mentioned several times throughout the conference, though I wasn't able to watch all the talks, unfortunately. But preparing data is very important for machine learning. Data is the key of effective machine learning, building an effective model. It is basically, garbage in, garbage out. So make sure that your data is up to date. It is doesn't have any bias. As less bias as possible. It doesn't have any missing values or some incorrect information. And there are so many different ways to actually prepare your data before feeding it to your ML.NET and creating a model out of the data. You can filter data, you can replace missing values, you can use different normalizers like minimum and maximum normalization, binding, remove default stop words like a, is, and other words, and other techniques. So some of those techniques, they actually mentioned in ML.NET documentation, but there are lots of great books about machine learning, about data preparation that you can read and understand a little more what you need to do to build an effective model. And now let's move to the demo. Okay. So what we have for the demo, I kind of started from the back of it. Here I have Azure Portal, and here I already created a bot. But what you can do, let's go to and open a new portal. Hope it works. So you have your clean portal, maybe not so clean. Then you're creating your source. Here, what you do, you just type a bot. And here you have the several options. You will need web app bot. We talked about it. There are other options to find it. It's in AI section. And you can read the overview, the documentation, the pricing details. Definitely make sure that the pricing level is working for you and your customers. And then you are creating a bot. But in order to create the bot, you need to fill in the form. You are putting bot handle, that's name of your bot, and subscription, that's your Azure subscription. Resource group, you can select existing, or you can create a new one. Location should be close to your customers. As close as possible, but then, if it outgrows, then there are other options that you can replicate and, use all the benefits of Azure to actually make it easier for your users to faster connect to your bot. And then there are pricing tiers. Have free tier. It is not completely free, but it is really cheap. And then the premium layer. And here you can put the app name. And here's the fun part that you need to remember, the bot template. And that part was actually updated recently. So here you have lots of information, and depends what kind of language you're using, if you're using C# or Node.js. And then you need to understand what kind of bot you need to create and what kind of template you need to create that bot. Definitely, if you created it and then you realize that it wasn't exactly what you wanted, you can change it and then publish it back to Azure. But here you have two main options: the Echo bot, that is just echoes whatever user types, and then the basic bot. It has connection to LUIS, language understanding intelligence service, part of the cognitive services, and bot analytics also available there. Virtual assistant, that is something new. That is a template that is available for you. You can't connect it through Azure portal, but you can download. The virtual assistant template. It's like an add-on from the marketplace that you can connect to your Visual Studio, and then you can use all the benefits of that template. Some lots and lots of information about the machine learning part that you can use. You can use LUIS, you can use Q&A maker, or you can just keep it all together and create your completely custom machine learning layer using just custom tools like ML.NET. And here you can connect your application insights and choose the location. That is pretty straightforward. So you are creating all that awesomeness. Let me close that. It will take a couple of minutes, so I just want to save your time. You can definitely check it out, open your portal, try to create your bot, and if something is not working, something is not right, or you have questions, definitely let me know. I'll be happy to help you. Unless it's something specific to Microsoft and what they're doing with the bot resource. But other than that, definitely let me know, ask me questions. So that's what you're getting. basically. Again, lots of information here, lots of details, some design guidelines, and design. It kind of it gets kind of glared over because everyone, especially developers, were so excited to jump in and start writing code, and sometimes we don't have enough time to think how it's going to work. Design is really important, and I know there are people who are actually professionally doing bot design. So they think about end users, they think how the bot is going to be used. They create sample dialogues. So when developer actually builds it, then we developers will understand how user is going to interact with the bot, what questions the user can ask, what answers he or she is expecting, what actions needs to be done. So that part is really, really important, and that should be done before actually jumping into coding, because sometimes when you didn't think about something important in the beginning, then it will be really hard to change anything there. So definitely think about bot design. That's important. And then, here the whole process is shown. You can build, you can test with emulator or a web chat. Then you can publish directly to Azure, connect to different channels, and then see the analytics. So all the benefits of Azure available for you if you're using Web App Bot on Azure. So here you have activity log. Here you have an option to test it in web chat. And then different channels. So by default, you already have web chat option. That's the basic option there. And then some featured channels, and then more available channels like Alexa, that is brand new. They released it as build just last week. A direct line speech is also relatively new, but those two are super cool. I am really excited about those. And, all the basic stuff that I already talked about. Then you have speech priming options and settings, the pricing tiers. But I skipped build because that's where we're going to go now. And here you also have lots of text that if you're starting out with bots, you probably need to read. Lots of useful information, lots of examples and how you can use the bot, how you can connect it to different tools. So definitely check it out. But a really good option here is download bot source code. And when you click on it, you just downloaded a zip file with that basic framework that you need to develop your bot. So you're not building it from scratch. You can get an emulator. You can install command line tools. Emulator is that pretty thing. It's called Bot Framework Emulator, and we're gonna go back there to actually test our bot on local machine. But you can always publish. You can always publish your bot to Azure. And test it in that test in web chat. Okay, so download bot source code. When you click on that, you get in a zip file, and then you can just unpack it. I downloaded it just to save our time because we don't have a lot of time. And I can talk about bots for hours and hours. So let's jump into that. That's what we are getting out of the box. You can see we have a lot of things coming from Azure. Lots of things that are already connected to Azure. Like you have a command for publishing it. You have app settings. You have controllers, so you are not building from scratch. And then EchoBot, because I created just a simple EchoBot to show you how it works. So that's what you get out of the box. So yeah, that's the zip file. It is, yeah. So when you open your zip file, that's what you get out of the box, and you can build, add more functionality, add more dialogues, and work with your bot. What I did here, I added ML.NET. You probably know how to add ML.NET. I updated my Visual Studio just a couple of days ago, so now Model Builder is part of Visual Studio, though we all know there were some issues there, but I think they somehow got resolved. And here we have that machine learning option. So it doesn't matter if you build in just a web application, or you are building maybe Azure function, or you build in some kind of solution using Visual Studio or VS Code. You have that option to add machine learning there. And you can see that fancy screen with options there. Yeah, okay. So close that. You are selecting scenario here. I'm sure you've seen it several times, but it just looks super pretty. So I want to show it again. I really like it. We're gonna use text classification. That is really straightforward case, so it's easy to understand. And my demo is not about something fancy that you can do. It's just a way to show you that it's easy to connect custom tools, easy to connect your ML.NET model with a bot. And then you can build upon it. You can obviously update your model. You can use it in different ways. You can combine it with cognitive services and other tools. So it's like the whole new world when you start building your bots. So we here using text classification. We are getting information about my laptop. If you're interested, we gotta train the model locally. We're gonna use a file, and I here used that 250 line Wikipedia data. I noticed that 250 is not enough, so the model is not that awesome. There is another Wikipedia data file, CSV file, that you can upload. It has more data. I think it's 40,000 lines of data, so that one is more effective. But I have that one here, so we are opening it. We have data preview. We see that is showing the sentiment text, and then if it's 1, then it's toxic. If it's 0, then it's not toxic. We are predicting sentiment column, and obviously we have 2 columns here. So the sentiment text is the input column for future. And you train your model. Here you have scenario, you have the link to your data set. You can use this CSV file, the same that I'm using. You can connect to database. So there are lots of different options. You can update the time, depending the time for training, depending on your data. So it's totally up to you. They have a great article here where they explain how long should it take to train a model. And then you have an option to evaluate. So I'm not going to train it now because I'm sure you saw it several times throughout the conference. If you didn't, or if you have any questions, definitely let me know. We can, go over that together later because we don't have too much time, unfortunately. So when I trained it, I got 2 projects here. I got the model and the console app. The console app, I don't really need it. That is mostly for testing. What else? So here you can see that that's, same bot, the Aquabot that I downloaded from Azure. And here I am just opening that Aquabot file if I want to add some machine learning tools and want to access my model. And that's the zip file that we all know and like, that AutoML generated for us. It's ML.NET model. And we're using that model here. So we are creating the context and loading the model. Here I can show you how we get in the path. So it's really straightforward. And then then creating predicting engine using the model input and model output from the project that was generated. And then we are providing as a sample input. We are using text that user types in to the bot, whether it's a web chat bot or if it's, if your user speaks to a bot, then you need to translate speech to text and then pass the text to the model. Unless, you create your model that supports speech. I don't think that it's possible actually, but you never know. And then actually here we are predicting using that sample data, and then we're using the prediction to return information. So the text, we're just repeating the text that was provided by us, provided to us by clients, by end users. And then if it's 1, then it's toxic, and if it's 0, then it's not toxic sentiment. That is very, it's pretty straightforward. It just shows you basically how to connect your model with a bot, so you can build upon on this example. It's like the base layer for you. And I can test it locally. So for that, I have Bot Framework Emulator, and you can just download it either using the Azure portal, or you can just find it online and download it. It's free. That's a great way to actually test your bot on your local machine. So let's quickly test it. So that's the typical URL that you probably have when you run your bot locally. App ID, there are cases when you don't need to use them on your local. In most of cases, you actually don't need to use them, but I do. So I go back to configuration on my portal, and I am copying. Oh, yeah, don't do it. Copying those values that we have here, the password, and the app ID, and I am inserting them here and connecting. Oh, yeah, sorry, missed a step. So what step I missed is that you actually need to run it in Visual Studio first. Since, it's web app, so that's how you usually test your web apps. You just run it. Here you have some logs. You can see that that's the local host I was using there. Here we'll start the conversation. Okay, hello and welcome. That is from our bot. That is that part here. So I didn't touch it. It is out of the box. And here we are typing something. So that is a non-toxic sentiment, and that is correct. So let's try something else. That is toxic sentiment. So that's what we got from our model that we connected to the bot. It definitely can be more sophisticated and should be more sophisticated, but that's just a base example. Again, see here you have all the details of what's going on with your bot. So you have enough information here. Also, you have some log here going on. So if something is not going correctly, check the logs here and in the emulator. That will definitely help you. And I think we are pretty much done. Here I have a couple of links for you that you can take a look at, check that documentation, connect with me on Twitter and LinkedIn. And yeah, I'm ready for questions.
Well, thank you, Veronica. That was great. Very informal. Informal, I guess. Informational. Awesome. Well, does anyone have any questions on the chat here? Feel free to post them here. We have a lot of compliments on the chat for a great talk. No questions so far, what I can see. Good talk, great talk. Crystal clear, yeah.
Awesome.
So what kind of conference do you have upcoming as well, Veronica? We talked about it briefly before.
Yeah, so I have a couple of things planned. I am doing presentations at a local meetup, which is online now, and then I am actually planning to give a talk at a meetup in I think it's in somewhere in Africa. I forgot the name of the group, but I'm gonna post it on my Twitter. So that's exciting. I'm Africa to talk to people and to share some information with them. And then in August, I'm planning to virtually attend Codepalooza. I was so excited to go there physically, but unfortunately it's not possible. So I'll take whatever we have now and do it virtually.
Oh, that's a great conference. I spoke there last year, so congratulations for that.
Thank you.
All right, the only question I have in chat here is, so if I understand it correctly, the bot is just an ASP.NET Core API?
So that is web app, actually, what I showed. You can use .NET Core, you can use framework, .NET Framework. And you saw the options that you can choose C# or Node.js. So it doesn't even have to be .NET.
Okay, great. And the other question we have here is, have you tried using models other than text classification with the bot?
I tried, yeah. It works pretty good. It depends on what kind of interaction you need. So usually people, as I mentioned, several times, people usually communicate either through text by writing something or through speech, but there are sometimes cases when people need to submit an image or bot needs to perform optical character recognition. So in that cases, you can use other scenarios using ML.NET and other available tools.
Okay. Well, again, Veronica, thank you very much for speaking here at the conference today. We learned a lot. It was great.
Thanks for having me.
Thank you. And coming up now, we're going to have an interview with James Craig, who's using MLNET in his organization, and we're going to hear his experience with that. And following that directly, we're going to have Praveen come and talk to us about the data frame API. So stay tuned, and more will come soon. First of all, thank you so much for joining us. So I guess to add some basic context as well to what you're doing, can you tell us a bit about what your company is doing as well and where you're based?
Yeah, so I work for a law firm called Williams Mullen. We are in the Mid-Atlantic region of the United States, and I am one of the very few people in the IT department there, where basically I lead the development portion.
Okay, awesome. Could you talk a bit about and explain to us how are you using ML.NET today in your company, in your organization?
Yeah, so it's basically kind of found its way into really random locations in our code base. What we started off with was we took a couple projects where we had really bad data, which everybody has bad data, but we had some really bad data that we needed to fix, and it was going to cost us a lot of money because we would have to hire 2 people in order to just go through everything and fix it all. And so we took ML.NET and built a basically a classifier model and used that to clean up the information. And that worked so well that we just started to try and use it in a lot of other areas. So like currently, the stuff that we have isn't actually in production. Since coronavirus hit, all of our rollouts kind of got pushed back a little bit, but we've been using it for things like text summarization. We've been using it to try and find keywords in various documents, with our main goal trying to be to improve search within the company. And since I work at a law firm, everything is a document, everything is completely unstructured, and so we have to figure out the best way to actually get the information out of those documents. And we're finding that basically using a little bit of AI helps quite a bit.
That's awesome, yeah. What made you choose ML.NET? Do you have a .NET C# development shop, or did you come across the tool in some other way?
The legal field is 100% Microsoft. It's turtles all the way down. But basically, because of the fact that the legal industry is so heavily Microsoft-based, we've been using C#, I don't know, since 2002, 2003. And more or less, we wanted to find a library that would let us continue to work in that, because even though we have used Python and we know Python, we don't really want to have to maintain a completely separate stack just so that we can do some machine learning. And it doesn't exactly make sense for us to convert everything over to it, so we went with something in C#.
Awesome.
And basically, at the time that we were looking at ML.NET, .NET Core kind of came about, and we really wanted to start using that as well. And from what we can tell, the vast majority of the machine learning libraries at the time were not going to convert over to that anytime soon. And whereas ML.NET, like right out of the box, we could use it on, .NET full framework or .NET Core, and it was great.
So since you had a chance to use it for a while now, is there anything you're missing in the library or something you would like to see added in the future?
The biggest things that we kind of want is more like natural language processing features. Like we've found things to sort of plug that hole. So things like speech tagging, named entity recognition, stuff like that. We've found things that do that, but it would be nice if the library itself had those features.
Awesome. What kind of impact do you envision MLNet having for your organization?
Right now, it's so let me start with the pitfall that we've run into, which is we have to basically explain to the people above us that machine learning isn't infallible. Because a lot of them, they kind of have this idea that it, is better than humans and that therefore it's perfect, which isn't always the case. And so, that is kind of a hurdle that we're running into. But once we get past that hurdle, what we're trying to do is basically because the fact that we have data in completely unstructured documents, and we've got millions upon millions of these documents, and data is just in there sitting, not doing anything, we want to get at that information. We want to make it so that whenever, let's say, a bit of litigation comes up, attorneys get just a giant mass of documents, and they have to usually hire people just to go over those documents and find out what's relevant. What we want to be able to do is, instead of having them go over, 1 million documents to find out what's relevant and spend 3 months doing it, we want to be able to build something that goes, these documents seem to be all related to this thing that you're looking for. Instead of 1 million documents, let's just look at these 50,000, which is still a lot, but cuts down time, it cuts down expense, and we think that with not even that advanced machine learning, just like a little bit, we can reduce time and costs across the board in various areas.
That's awesome to hear. Very, very inspiring, and thank you for sharing your story. Definitely thank you, James, for sitting down with us today and kind of giving your view and perspective on MLNet and how you use it within your organization.
Yep. Thank you.
All right. Well, welcome back, everyone. We are back from the break here. Thank you very much, Veronica, for a fantastic talk. It was very informative. And with us today, we have Praveen now. Praveen, how are you doing?
I'm doing great, Alexander. How are you?
Good, good. And it's late where you are, right?
Yeah, it's around like 2:30 a.m.
Wow, and where
But
about?
but this ML.NET conference keeps me working for this.
Yeah, and whereabouts are you located?
I'm located at Bangalore, India.
All right, awesome. And you're a cloud architect and an avid community speaker, I hear.
Yeah. So just to brief you on who am I, so I'm working as a cloud architect at Harman International. It's a Samsung company. They are into audio video, and you might have heard about JBL speakers. So that's one of our brand, and we are developing a platform for audio, video, and lighting control, which is to control all these devices remotely through a web app. Then we are leveraging Azure over there, and I have around like 15 years of experience. After that, most of the experience is into Microsoft technologies, right from MFC, VC++, then WinForms, WPF, then web APIs, and now into cloud.
Cool. So how did you first come in contact with MLNet?
Yeah, so there was a story about that. So I used to attend few meetups for the past couple of years, and I was attending few meetups related to the machine learning field. And in one of the meetups, I got a few use cases that got me excited about this field. And I, as a like a C# developer, I kept on looking for the options that is available in .NET for machine learning, but I didn't find much of that one. But last year I got to know about this ML.NET. Plus, before that, I got to know about TensorFlow.net. So there are few kit packages that are written in .NET. So that got me excited, and I got motivated to work in this field. And therein, like from the release point 4, I started to look into the things happening around ML.NET.
Awesome. And today you're going to talk about data frame API, right?
Correct, correct.
Awesome. Well, we're very excited to have you here. Thank you very much for staying up so late to give this talk and sharing your experience and expertise with the audience here that are watching in. And we will be asking you questions after your talk. So anyone who has questions to Praveen here, put them in either Twitch or YouTube or Slack, and we'll make sure to ask them. But for now, Praveen, the floor is yours. Take it away.
Okay, thank you very much, Alexander and John. So, welcome everyone to the virtual ML.NET Community Conference. This is the first edition. I am really excited to speak on this a great topic of ML.NET. So, being a .NET developer, like it's really inspiring to see the things happening around in the machine learning, and that too from a .NET perspective. So today I'm going to talk something related to the data frame that was recently released, I think few months back, the first version of it. And I think Daniel has given a good overview about the Jupyter notebook, and he does a little bit on the data frame as well. And I'll try to take it forward and try to be aligned only to the data frame and ML.NET a little bit. And the area of the domain that I'm going to cover is the COVID-19, because that is a current area and happening area, and which everyone knows about it, the pandemic that is going on. And because of that, everyone is like, have to stay at home. So with that, I'll just start my presentation. So this is a brief introduction that I just gave. Like, I'm a cloud architect at Harman, and the domain is audio video control. So my area of expertise is cloud and distributed computing. Interest area is AI, ML, cloud, and IoT, and I'm based out of Bangalore, India. So before I start, I would like to give some acknowledgements. So first one is the data set. I would like to acknowledge John Hopkins University's for providing the data set for this COVID-19 things happening, like how many confirmed cases are there, how many deaths are happening, how many actual cases. So these all things have been provided by them. I'd like to acknowledge them. Then for Python visualization, I tried to go through one of the notebook which was written by XSB, but it's written in Python. So I tried. This was my source of inspiration to convert it into ML.NET. And not these like the great people that we have, Alexander and John. So this is the first time I am looking at John. I've been following his video tutorials where I just got to hear his voice, but as part of this conference I got to see him like face to face. So I'm glad that these two guys have been doing a great job in organizing this thing, and behind the scenes there is a lot of work that is happening, and they have done it like flawlessly. I really want to thank them. Last but not the least, the sponsors for the event like Excella and the Wintellect. So COVID-19, so what is it? As per Wiki, this is coronavirus 2019, disease 2019, that is a short form acronym for COVID-19. It's an infectious disease caused by severe acute respiratory syndrome, coronavirus 2. So they call it SARS-CoV-2. The disease was first identified in 2019 in Wuhan, the capital of China's Hubei province, and has since spread globally, resulting in the ongoing 2019-20 coronavirus pandemic. So I think almost most of the countries have been affected with this, and there is a havoc that has created, and still we don't have the vaccine for this one. But like if we follow some precautionary measures, then we can refrain from this disease. So it's like a really a pandemic which is causing a havoc throughout the globe. So there are some statistics that have put up here. So if you look at these statistics, like this is the confirmed cases as of 28 May 2020. So these are like 5 million confirmed cases, and there are deaths around like 0.35 millions. But if you look at this data set, you can't say how that it's very static data set. You can't predict what has happened in the past, what is going to happen in the future. But because these are just numbers, so this is what a statistics mean. But if you look at this graph, you can predict what has happened in the past and what may happen in the future as well. So if you combine this data, the left one, you can't make any judgment out of that one. But if you look at the plot, you can actually make some judgments out of that one. So that is where we do exploratory data analysis. So this is another two graphs. So like it talks about the total confirmed cases as per the different countries. And on the right side, we had total confirmed cases on a per day basis, how they are increasing. So this topic is more about the exploratory data analysis. So what is it? First of all, as per Wiki, in statistics, EDA is an approach to analyzing data sets to summarize their main characteristics, often visual methods. So when we get a data, we generally not able to interpret what is residing in that one, what information is hidden in that one. But as we apply some exploratory data analysis on that data, we start getting some inferences out of that one. We generally plot some graphs, we generally plot some tables out of that one. We manipulate the data, we aggregate data at some places to get a better understanding. So it's a statistical model that can be used. A statistical model can be used or not, but primarily EDA is for seeing what the data can tell us beyond the formal modeling or hypothesis testing task. So I just wanted to give an analogy here of a house. So if you want to buy a house, what all things will come into your mind before buying a house? So you may look for number of bedrooms, you may look for type, whether it's an apartment, it's a villa, whether how is the locality, and how is the crime rate in that locality. So these are the factors that may help you in making your decisions. So if you get a good overview about these items, then you can make a better judgment for buying a house. So what is the time series analysis? So time series analysis, that is the analysis of data organized across units of time. So you plot a graph of one item against the time, and you get the time series. So as you can see on the right side, we are plotting a number of total deaths over a period of time. So it starts from January 22 and goes till January May 27. And if you look at here, somewhere around like March 21, there is a sharp increase of number of deaths, and it has been increasing exponentially. So this plot gives us a very overview, okay, how things have moved in the past and how it may happen in the future also. So the plots are very helpful in that one, and it helps understand past trends and plan for future. This is what I already discussed. So there are different type of time series analysis that we can perform. So like first one is trend. So trend is like the normal trend, how's the, for example, if you take a case of a e-shopping cart, e-shopping application, so how's the sales going on for that one? It may be like a regular, so there is a trend of going up at some time, then there is a trend of going down at some time. Then seasonality is about like during Christmas, during Thanksgiving, the sales may go up, or during dormant period it may go down. So those comes under seasonality. And third one is irregularity. So irregularity, the best use case would be like the current situation that we are facing of a pandemic, wherein the sales have really dropped for some of the online retailers or some of the retailers, and it was not expected anywhere, but it has come. So these will tend to be part of the irregularity time series analysis. Then there is a cyclic, that means after a certain period of time there will be a uprise, then after a certain period of time there will be a downfall. So it may be considered to be like a sinusoidal waves, where it may go up at a certain interval, then come down, and then go up. So it remains constant with those cycles. That means it will go up for some time, then come back to some time. So these are the four types of time series analysis we can perform. And so today we are going to perform one of the time series analysis on total number of confirmed cases uh, during this pandemic of COVID-19. So before jumping into that one, I like to spend some time over data frame. So Daniel already touched upon this one, and I like to extend on that one. So data frame, if you look, it's something that is coming from the Python, wherein it's present in Python, it's present in R as well, most of the data science languages. So it's mainly prevalent there because it allows you to perform analysis on a huge data set, and you can perform multiple operations on that one, like addition, subtraction, then insertion, deletion, then you can group by, you can sort. So a lot of things you can do there. But here it's mainly derived from the Python and R. So this is how to explain what is a data frame is. If you look at this table, it's nothing but a normal Excel sheet with some rows and columns being represented. So what data frame does is it tries to fill in this thing into a data frame object and display it. So when we convert this one into a data frame, it looks like the one that is present on the right side. And as you can see, it has added one more column with the values as 0, 1, 2, 3. So those are nothing but the indexes of the rows which are present. And generally it starts with 0, not 1. But these are it's configurable, so you can change the index as well. You can assign any of the columns as an index. You can give a name to the indexes. So it's really configurable in Python. Okay, so coming to the .NET data frame. So what is it? So it's a collection of columns. It is very similar to Python data frame. So what Microsoft has done is that they tried to bring their feature of data frame to .NET so that people who are wanted to work on the data science field, they can easily work with this data set with this data type. And basically it's a collection of columns, and in this the whole data is present in the memory, so everything gets loaded into the memories. That's why it's called a in-memory representation of structured data, and it's very similar to Python data frame. Then you have there are some features that I have listed here. So first one is you can load a data set from a CSV. You can do a row or a column selection. You can join or merge data frames. You can group by, and you can fill the null values. You can handle the null values as well. So very similar to what we have in Python, and but not to that powerful as in Python. The reason being it's recently introduced, so it will take time to get to that level of Python data frame. So there is a question that comes very often, we already have a data view in ML.NET. So why do we need a data frame as a different data type? So I tried to list down some of the differences and some of the similarities between them. So first one is so data frame is part of the Microsoft.data namespace, whereas iDataView is part of Microsoft.ml. So there is no correlation. These are two very independent things working individually. So there is no dependency of a data frame on data view. Sorry, on there is no dependency of a iDataView on data frame. So if you want to see how they are related, is like there is an analogy like a data frame can be considered as a list where you can do multiple operations on it, such as addition, deletion, insertion, getting by index, all those things. Whereas iDataView is kind of an enumerable or read-only thing, which is immutable, whereas data frame is mutable. So data frame is meant for .NET developers interested in data science, that is for exploration, whereas iDataView is more inclined towards .NET developers who are interested in machine learning, that is for making some predictions or forecasting or such kind of things. Data frame is schemaless, whereas iDataView is schema bound. So schemaless, I mean to say you need not to define any class for the data. You need not to have a knowledge about what all columns are present in your data, and you need not to create a class or a class with properties for those data types. So it will be automatically handled by the data frame, and it will load and give you a tabular data. Whereas in data view, you have to define a class that mimics your data that is present in the CSV or another source, and there you need to define it as a features, and plus you need to define a label over there. So the data type for the features is also very important there. So it requires a prior knowledge of the columns or the data type of those columns that are present in the CSV. Data frame is eagerly loaded. That means everything is as soon as you load it, you can work with that one. Whereas data view is lazy loaded, so till the time you perform any operation on data view, it won't be loaded. So for example, till the time you call predict pipeline.fit, nothing gets loaded in data view. Only at that point of time it gets loaded. Then data frame is in-memory representation of the data. Then data view is a stream based with a forward only cursor. That means you read the data as per your records. You can read one record. It reads records row by row, and you continue to read those things. Data frame has a random access similar to your list, whereas data view doesn't have a random access as it's a forward only read cursor. Data frame is easy to debug because it's eagerly loaded, so you can debug the things quite well. Whereas data view is hard to debug because till the time it's called by someone, then only you will be able to see the values. So for example, if you are calling pipeline.fit, then in that case, only that point of time you will be able to see the values that is present in that, or you have to call it inside a for each loop or something like that, but then you will lose the performance improvement that is present in the data view for lazy loading. Data frame supports only CSV as of now, and that is the only data type they have provided as of now for data frame. Whereas data view supports CSV, enumerable, and relational DB. So it's very much required for your machine learning things. Whereas for exploration, many times it's mainly present in the CSV, but I think Microsoft is going to add support for other types as well in data frame. Now the last point is very interesting here. It's like a data frame is based on Apache arrow formats, and what Apache arrow format means, it maintains a kind of a standard. It's a kind of a standard which all the consumer has to be follow. For example, you have Spark, Apache Spark, you have Cassandra, or any source of data set. It has to follow that one, and it's very efficient in terms of the memory representation of the data, and it's based on the columnar data. Whereas data view is schema based, so you need to know what all the columns are present there, what all the data types of that column should be there. So it's very much coupled to the schema. Now coming to the ML.NET, so we just had a look at the data frame for exploration part. Now this ML.NET is I have used mainly for predictions here. I did a small prediction on the COVID-19 data set, and it was a time series prediction wherein I've leveraged like loading a data into an ML context, creating ML pipeline. Then in the last I'll be predicting confirmed cases in next 7 days. So I have a data of around 107 days that I've trained my model on, but the data itself is very less. So, but I have trained it on that one, and I try to predict what will be the values of next 7 days if we continue to have those kind number of confirmed cases. So for that, I have used single spectrum analysis. So single spectrum analysis is nothing. It's a powerful framework for decomposing time series into trend, seasonality, and noise component, as well as forecasting future values of time series. So I just mentioned in previous slides about the different type of time series evaluation that we can perform, or an analysis that we can perform. So single spectrum analysis allows you to perform those kind of things, and it performs the way it works is a single spectrum analysis perform spectral analysis on the input time series where each component in the spectrum correspond to a trend, seasonal or noise component in the time series. So the use case, maybe you can say it's like an anomaly detection or forecasting. So we leverage the forecasting part of it for predicting the number of confirmed cases in next 7 days. And the API that is used here is from the time series catalog that is forecast by SSA. And for visualization, I have used Xplot, the Plotly. That is a graphical user interface that is being provided. And I have created a bar chart, a scatter chart, and a pie chart. So these are the things that I have used. And this is just a preview about on the things that is being generated out of that data set. So on the left, you have a pie chart representation of number of confirmed cases and a number of deaths and number of active case recovered cases. Whereas on the right side, you can see it gives a bar chart for different countries with the number of confirmed cases. So, and for prediction, this is before the model has been trained. This is from the analysis part. So this is a plot of number of confirmed cases right from 22nd of January till 5th of May. And based on this data set, we try to predict the next 7 values. And these are the values that I got out of my ML model. And I try to plot that one, and it comes like this. And there is a slight decline in the predicted value. The reason being the data set is very less, so model is not able to interpret it very well or come up with a very good algorithm for that. But as you can see, still the number is going up in line with the previous records. So it's also increasing similar to what we have previous increase. So not a very good prediction, but the model is predicting in a little bit a better way because the things are going in an upward direction only as per the last trend. So with that, I'll just move on to the demo side. And if you need anything, okay. Okay. So okay, so this is my Jupyter notebook, and it's being divided into part 1 and part 2. Part 1 is about making the exploratory data analysis, whereas part 2 is being extended for the prediction. Okay, so this is a notebook that is created. So like acknowledgement for John Hopkins. Then this is the place where you can get the data set about this. Then I have explained a little bit about data frame. Then what all things I'm going to perform. And it's a 2 parts thing. I've divided into 2 parts this section. Then this is how we just load our packages. So currently I'm using Microsoft.ml, data.analysis, and Plotly. And this one I'm going to tell you how I am using CSV helper here in a minute. So these are the namespaces, constants. So this is about the utility function. So it is, I think, quite well explained by Daniel in the previous presentation. So I'll just skip on that one. It is about representing your data in a very formatted way. Now coming to this is one another helper function. What it does, it replaces a character in a cell of CSV with a defined separator. So I'll explain you why it is required. So for loading a data set, so I'm loading this CSV file. So these are the this directory contains date-wise data about the COVID-19 cases. So I'm using that only. This is how I'm downloading it from the GitHub. Now this is the thing I was talking about, like I need a helper method for my data set. So there is a issue in the load CSV method of a data frame. What happens is like this data set contains comma or the separator within the cell values. So this is my column which combined key which has some separator, and we are mentioning that when we load our data set, we are giving the separator value as comma. So the current implementation of load CSV in data frame, that it fails with that, it fails for that one. So what I have done is I'm loading I have created a helper function that goes and changes these separators with some other character, for example underscore. So after this the all these will be replaced with the underscore, and we can load this data set. So this is just about a workaround for the transformation of that one. And there is already a issue logged for that one, and I think the Microsoft team is working on that. Now this is about that one, like this is the one where I'm calling that, where I'm passing the original file name, new file name. Yeah, this is the main thing. So here we are passing the loading the CSV and creating our data frame. Now coming to the data analysis part. So first we wanted to see what is the range of the records in the data set. So from a data frame, you can use the columns property, and you can provide it's a collection wherein you can provide the last updated value, and it will give you the value counts, will give you all the values within that column. And I tried to sort that one, then I got the start date and date, and it is both same. The reason being it is both same because this is a data set for 1 day, so that's why there is no range present here. Now if I wanted to visualize the data here itself, I can just either call display method as an inbuilt function from the .NET for displaying the data frame. So what it does, it displays the 10 records, and this is what I was talking about, the index thing, and it will list down all the columns that is present in the data set with their values. Now there is another function called as head. It allows you to get the top 5 records from your data frame. Similarly, if you want to see the random records, like the sample is used for displaying the random 6 records, so it may be in any order or anything within that data set. Now if you want to see if you want to preview what is present in your data set as a like a statistics about your data set, then you can just call that description. So description has like length, that means how many records are present for one type, and what is the maximum value, what is the minimum value, what is the mean value for that. So this is about that. And that information, like if you want to see what is the data type of each column that is present, and what are the values it contains, then the total number of values. So we can see like this is like string, and so then you have single, then you have string. So it's a combination. So each data frame like in Python data frame, the constraint is the column will hold data of one type only. It can't have a mix of data types. So that is why you get the type out of that one. Now we will move on to the data cleaning part, and with the data cleaning part, what we can do is we can remove the outliers, we can remove the null values, we can merge two values into one. We can remove the unnecessary things that becomes a noise for the analysis, and that way the data will be more readable, or maybe you can say the data will be more accurate to for our analysis. So I'll just give you an example here. What is the invalid data here present? So if you look at the active cases, so it's a negative value. So this is how I got to know that there is something wrong within my active cases. Okay, so I just did a description and got a minimum value as minus of for the active cases. The way we calculate the active cases is we take the confirmed cases, we subtract the deaths and the recovered cases. So if you look at the confirmed cases and deaths and recovered, so it cannot be less than zero. So it cannot be negative. So this tells us, okay, there is a problem with our data set and we need to remove these irregular values from this. So for that, we need to filter out these values. The way we filter out is we use element wise less than API from the data frame columns. So we can say, okay, the values which are less than zero, get me those values. So this will give me a column, invalid active filter, and what I will do, the data frame exposes a filter API that takes a column. So these are the different primitive data types that is present in the data frame. So mainly the data frame has a class for string data frame column, integer, boolean. So like that, it has covered mainly most of the primitive data types, and you can create your own data type as well, columns as well here. So when you filter it out, then you can see when we print this one, we can see that there are some cases which have the negative values. For example, these all values are negative for the active cases. Now we got to know the list of records that is having a negative active cases. So if you take any record and apply a formula to calculate, like minus 13 index at 5. So if I take this one as example, so I have 10 minus 51, then minus 0, so it comes as minus 41. So that means it's based on this thing only, and it's invalid use case, invalid record. So what we will do is we will we want to remove these invalid cases. For that, we again create a column with a condition such as element wise greater than or equal to 0. So we are only interested in values whose active value is greater than 0, and we do that one using a primitive data frame column and applying a filter for that column. Now once we do the description, we can see that there are no values with negative, there are no active cases with negative values, so we have a 0 here. That's the minimum value that we got. So that's how we did the data cleaning part of it, or from a data frame. So we can see that the negative cases have been removed from this. And the good part of data frame data type is, like, nowhere we have mentioned about the schema of our data set. So it's like a schema less. Now coming to the visualization, so I tried to visualize few things just to keep the things very simple. I didn't go a deep into visualization here, but if required, we can explore more on the plotly charts that is available and explore more, plot more of these charts. So first one is how do we collect the data? So from the data set, we know that there are some confirmed cases, there are deaths, there are recovered cases. So we just got all of these. Then we got a sum of this one. So data frame supports aggregating the values. So we got the total values out of that one. Then we try to plot all these three using a pie chart from a plotly. So this is how it comes, and you can move over this and you can get the see the values and the percentage. Now we wanted to see the countries, top 5 countries with confirmed cases. So the data for top 5 countries is not present in CSV file together. So we need to do a group by, and so in this cell I have used group by, sum, and order by descending features of a data frame, which is very helpful for grouping the records and getting a sum out of that one, and later on sorting it. So like I'm getting a country confirmed group, then top countries column cases, then I have to, so this code is for representation only, it's not a very optimized. I try to keep it very simple just to make it better for understanding, and I try to plot it as a bar chart over here. Now we can see the number of cases against each country, top 5 countries, like US, Brazil, Russia, United Kingdom, and Italy. So this that is for confirmed cases. Similarly, I did a plot for deaths for top 5 countries. So this is about that one, and same is the case for recovered cases. So we can say the recovery is quite good in Germany, in Italy, then Russia. So with this, we can say that things are going good in terms of the recovery, but with deaths and active cases, still the numbers are quite high. This is about one chart of related to the India, and you can see we have 1.58 million confirmed cases, then recovered, and deaths are like 4,500. So this whole thing gives a little bit overview about the COVID-19 pandemic that has happened, how many deaths have occurred. Because if you just look at the numbers, you won't be able to realize what has happened and how things are there in that one. So we need to visualize it better. So the data frame helps us measuring those things and give a better visualization. Now I'll just move on to the part 2 of it, wherein I did a small prediction for this data set. Okay. So it's the same similar thing I have just explained what is that. So the main intention is to look at the time series analysis for the number of confirmed cases for 107 days, 127 days, and based on that predict the outcome for next 7 days. So this is how I am. So here you can see the time series package I have included. It gets installed. That is the extra thing that I got here. Then this is something similar to what we see. Then this is a formatter for the table. Then for time series there is another data set that is present, a different one compared to this. So if you go on this GitHub link, you'll see time series, and here I have just taken the confirmed global cases. So I'm doing the analysis only on the confirmed and that too on a global cases. Okay. So there is a catch here, the data that is present is like this. You have columns and the dates also along with that one. So loading it into data view, it's difficult because the number of columns are quite large, plus making a prediction out of these, like For time series, we just need the date range, plus we need the one attribute of it. For example, we need a number of total confirmed cases. So that we can get if we just add up all these values, we will get up those values. So there is no transpose or anything present, transformation present in data view that we can do for this. So what I did is I just changed this one into a different format and got it in this format, wherein we have a list of dates, plus we will have the total confirmed cases against those dates. So this is how I have structured this the data set that is present there, and the way it is being structured I have just explained it here. So if someone wants, they can just refer to this one, and they are good to go with this. So now we have the data about the dates and number of confirmed cases, and so this like the prediction is mainly done using ML.NET. So now we have left the area of data frame and we are exploration area. We have come into the data view part. So for the data view, we need to have a schema or a class that maps to our columns that is present in the data set. So I just created a data set for that one, class for that one, like a date, which is of type date time, and total confirmed is of type float. So it maps to our both the attributes present in our data set. Now this is for our forecasting, like this is an array which will hold the values for 7 days of number of confirmed cases. Now before doing the prediction, we just wanted to visualize, so we can visualize it through our, again you can use the data frame or you can use the data view. For the simplicity, I have just used the data frame here. It is just only for visualization purpose. So we can see like what are the top 10 values, what are the last 10 values. We can see the last date and what is the number of cases in that can tell us. And this is it can tell us, okay, if there is any negative values or anything like that. This will tell you the statistics about the data, how many mean values, how many max value, what is the mean value, what is the max value. Now number of confirmed cases over time, so we again get the values from the date column and total confirmed column, and we try to plot it, the cases over time. So this is how it comes. Yeah. So as we saw earlier that this is very similar to that one. We can say that around 19 or 21st of March, there is a sharp rise in the number of confirmed cases. It keeps on increasing exponentially. So this gives a overview of how the cases are increasing or decreasing over a period of time. So this plots helps us analyzing that kind of a situation. So we can say that the duration is from 22nd of January through 27. Then there are 127 records. Then the case on first day is 555. Then case on last day is 1.69 million. And number of confirmed cases was low in the beginning. There are a first jump around 12 to 2020 and an exponential jump around 22 March. So cases have been increasing at an alarming rate in the past 2 months. So if we look at this one, the cases have been increasing at a very high rate. Now for making the prediction is a standard process that we have been looking for the past 2 days. So we first create a ML context, and then we will load the file from, we will use the load from text file API, but here we need to define our schema or the class against the columns that is present in our data set. So this is the file name, then we need to set the header as true and separator character as comma. So this will load our data set. Now this is the main thing where we are specifying what algorithm we are going to use for this time series analysis. So for creating ML pipeline for a time series analysis, we used a single spectrum analysis, and ML.NET provides a built-in API for the same. So we provide these things, and in this we have provided a value for the horizon. So horizon is nothing but for how long in the future you want to predict something. So in our case, I have provided the value for horizon as 7. That means,
Praveen, I think
Yep.
unfortunately we have to start wrapping up a little bit here. for
Yeah,
this
I'm
talk.
just about to finish.
Awesome. All
Yeah,
right, go
great.
for it.
Thank you. Yeah. So this is for the 7 days. So when you create a time series engine with your confirmed data and the confirmed forecast, and you do a prediction out of that one. Okay, so this is the values that you got. So for the next 7 days, and I just tried to plot this one again, and the plot looks very similar to what I have shown in the PPT, and it's similar to that one. Yeah. So this is all about I have with respect to the data frame, and I had touched a little bit on the prediction part using time series, and hope you enjoyed this one. And feel free to ask me any question you have either now or maybe on the chat. Thank you.
Thank you very much, Praveen. That was great. So definitely a deep dive into data frame API and a lot of good learnings there for sure. Does anyone have any questions on the chat real quickly here before we have to jump into prepping the next one? Daniel has a question here. What value did you choose for, and how did you find seasonality window size for a trainer?
Let me check. Window size is I just used 5, I think. Yep, 5. Series length is 10,
Okay.
train size is 100, because my data is around like 127 records. So it's a very less data to do this kind of analysis, but this is just for representation how it works.
Okay, awesome. And we have these on GitHub, right? So anyone can come and look at them?
Yep. Let me turn it. Everything is here.
Perfect.
You have this part 1 and part 2.
Okay, even the speakers, awesome. Well, if you want to, you can definitely post that into the chat or into Slack afterwards, and people can go and have a look at it.
Sure.
Perfect. Well, thank you very much, Praveen, for joining us today and giving this talk. It was very, very great, and thank you for staying up so late.
Thank you, and it was a privilege to be part of this event. Thank you.
That was awesome. All right, so coming up next is our last speaker of the day. It's Will Velida, who's going to talk about serverless apps and All right. Well, welcome back again to the last talk of the day and the last talk of the conference. It's crazy how fast everything has gone by here. We had so much fun yesterday, so much fun today, but we are more than happy to welcome Will here to our conference. Welcome.
Thanks for having me. Yeah, it's great to be here.
And you're calling in from New Zealand, right?
I am, yes, all the way from New Zealand, all the way from Auckland.
Yeah.
Yeah.
And it was 2:30 a.m. in the morning for Praveen just now, and for you it's like you said 10 a.m. in the morning, right?
Yes, which is a bit more sociable than 2:30, I think. So it's early here, but it's it's not too early, which is good.
That's good. And you're a Microsoft MVP as well, but in the data platform, right?
Yeah, so that was awarded to me the start of April, so I'm fairly recent data platform MVP. Yeah.
That's awesome, yeah. And we are really excited to hear about your talk today. I think you're going to speak about serverless applications and Cosmos DB and then MLNet in the middle of all this, I guess.
Yeah, that's definitely the plan. And I also have a live demo as well. So hopefully, hopefully I'm looked upon with favor and that all goes well. So that's certainly my intention. Yeah.
That's awesome. I will always like end-to-end applications, and it's always great to see kind of, at least personally, I really like to see ML.NET be used as well and deployed. And I saw that John is crossing his fingers for you, wishing you luck. But yeah, so as always here, all attendees on the stream here, post your questions in the chat, and we will definitely make sure to ask Will those after this presentation. But I don't want to hold you back. I'm really excited to hear this talk. So the floor is yours, Will. Take it away.
Fantastic. Let me just get my... Sweet. Okay. So good morning, good evening, wherever you are in the world watching this session right now. Thank you and welcome. Thank you for joining me. I hope that wherever you are in the world right now, that you're staying safe and healthy during these very challenging times. So welcome to this session on building serverless machine learning APIs with Azure Functions, ML.NET, and Azure Cosmos DB. Now, in this session, I'm going to show you how you can train machine learning models using ML.NET and then use those models within Azure Functions. This session was inspired by a blog post that I did a few months ago where I was just sitting in my room wondering what I was going to write about and thought, well, why don't we try a little bit of fun, try and build something cool and see if we can get this going end to end. And hopefully by the end of this session, I would have inspired you to try and build something cool using ML.NET as well. It's fairly straightforward. And even though this session, I'm going to be using a scenario of building an API, hopefully the methodology that I show you in this demonstration will show you how to inject ML.NET models inside Azure Functions that can be applied to a variety of different scenarios. So just a little bit about me before we start. My name is Will Valida. I'm a software engineer working for ASB Bank based in England. If you're thinking that maybe you've watched The Hobbit or maybe you've watched the All Blacks play a couple of games for rugby and you think, hang on a second, I don't remember Kiwi sounding like that, you're right. I'm originally from the UK, but I've been living in Auckland now for around about 10 years, so I think I'm fairly acclimatized. I'm a Microsoft Data Platform MVP. My main focus is Azure Cosmos DB, but I also work a lot with .NET in my day-to-day job, a lot with Azure Functions, like to play around with ML.NET when I get the chance, a little bit of Databricks as well. And I've been very fortunate to speak at a variety of different conferences and user groups around the world about Cosmos DB functions, and I also blog a little bit on DevTO. So let's talk about what I'm going to cover in this session today. I'm going to show you how we can use machine learning models that we train using ML.NET inside Azure Functions. I'm going to be building a very basic, but I think kind of cool API that allows us to predict taxi trip prices based on some features. So essentially, the ML.NET team have come up with this really cool regression tutorial on predicting prices for taxi trips. I'm essentially going to be taking that tutorial and then embedding it inside of an Azure function and using it in an end-to-end scenario. I'll provide a demo of it and I'll explain all the moving parts. And then we'll talk about how you can inject your machine learning models that you train using ML.NET inside Azure Functions. Cool. So like I said, we're going to be building taking the taxi trip tutorial from ML.NET and using it within Azure Functions. And for this, we're going to need two functions. So we'll have our first function, which will train our model. Now, for this scenario, I'm going to be using a hypothetical batch training scenario, which will use as timer trigger and to train the model based on data that we'll store in just a local directory. And we'll train a model and save that to blob storage. Then we'll have another Azure function, which will be our API, that will inject the model that we've uploaded to blob storage and then use that model to make predictions and then insert those predictions into an Azure Cosmos DB container. So here's just a high-level overview of our work process. Essentially, we'll have our timer trigger that will train our regression model when it's invoked. This model will then be trained based on some local data. We'll upload that model to Azure Blob Storage as a zip file. This will store our model as a URL, which we can then use to inject into our API, which will just essentially be an HTTP trigger that will insert our predictions into a Cosmos DB container. Before I dive into the code, let's just recap a little bit of the process of ML.NET and just to give you a little bit of context about how we're going to use it inside our Azure functions. Just as a little bit of a recap, these are the type of predictions that we can make using ML.NET. So in our example, we'll be using a regression formula. But say, for example, you wanted to build a classification system that analyzed the sentiment of text. So say, for example, we could have an Azure function that's invoked by events that are triggered from Azure Event Hubs, and essentially that would process messages from tweets that mention our company name. We could build a classification model built using ML.NET that analyzes the incoming messages for their sentiment and then publishes that event somewhere else. So ML.NET is quite flexible in the type of predictions that we make, and combined with the functionality of Azure Functions, there's a few scenarios that we could use Azure Functions and ML.NET for. And then just to recap the code workflow of actually training our ML.NET model. So we start here by collecting and training our data and storing it into an iDataView object. We would then create our pipeline, specify which operations to extract our features and apply our machine learning algorithm that we want to use using this append model. We then train our model by fitting it onto our pipeline and then evaluate the performance and iterate on it just to see if it's actually an effective machine learning model for us to use. We then save our model using the save function into a binary format, which we can then load into our applications using the load method. And then we can make predictions on that by using the create engine predict functions. However, with this create prediction engine, this is not entirely suitable for our needs. Because even though we can use it to make single predictions, it's actually not thread safe. So every time we would want to create a prediction, we would have to create an instance of that prediction engine each and every time we'd want to use it. And depending on the demand and the kind of traffic that we experience on our applications, that's not a very efficient way of handling it. So what we can use instead is a prediction engine pool. And this is a service that creates an object pool of prediction engine objects that we can use throughout our application. Now, the great thing about this as well is even though in this scenario we're using a batch processing example, machine learning models are not static. We always want to optimize them as new data comes into our application, and ideally, we want to redeploy this without bringing down our application. And the great thing about the prediction engine pool, this actually allows us to reload our machine learning models without any downtime. And we can do this via two mechanisms. So the first mechanism we can use is using a from file method. So if we're storing our model on a local file path, we can use the from file method, which will start a file system watcher that listens to file changes and then raises events, which will prompt our prediction engine pool to automatically reload our model. So say if we have some new data coming in and we save a new model to to the local file path that we specify. The file system watch will say, hey, there's a new model here, and it will tell the prediction engine pool to automatically reload that model. Now, for our example, what we're going to be using is the from URI method. So essentially what this does, it will poll a remote location for changes in our model based on a time span that we specify. So we're storing our model in Azure Blob Storage, and we'll be making it available as a URI, and we'll poll that URI for changes based on a time span that we will configure. And you can configure this depending on the requirements of your application. Sweet. So I've talked for quite a bit. Let's actually open up our demo and see if I can do this gracefully. So what I'll do. Cool. Can you all see my screen? My Visual Studio? Silence means yes. Okay, so what I've got here, I've got my two functions. So I've got my, let me just expand that a bit. I've got my model trainer here, and I've also got my API project here. So let's go through our model trainer first. So essentially, I'm going to be training my machine learning model based on local data. So this is just a nice, simple example. So I've got a data folder here with both my test data CSV data set and also my training CSV data set. I've also got just a helper class here to just abstract some of the methods that I need to upload my model into Azure Storage. So let's go through the model. So with the data, I've created a class here that just essentially tells ML.NET which columns in my data set belong to which properties in this class. So again, this is index-based counting, so it starts from 0. So I've got my vendor ID, rate code, passenger count, the time of taxi, time of the trip as a float, the distance, the payment type, and how much I actually paid for that trip. And then I've got my fare amount. So this score will be the labels that I want to predict. So I've just got a separate class for that as well. Now, just to give you all a little bit of perspective of which packages I'm using. So for this project, so I've just got the Microsoft.ml NuGet package along with the FastTree package as well, since I want to use the FastTree regression model to train my data. And also I've got some support for Azure Blob Storage as well, along with the functions NuGet package that it comes with. Cool. So essentially what I'm going to be doing here is authenticating to my Azure Storage account, reading my local data file, and then setting a model path, and then adding that data to an iData view, and then training the model in this train and save method. So I'll be loading it from the text file that I passed through, the training data, the file path for my training data, applying a pipeline to it, fitting the model, and then testing our model for its effectiveness. And then if it passes a certain value, saving that model to blob storage. So let's kick this off. Let's see if this will work. Please don't download the storage emulator. Yep, there it is. Okay. Well, that was fairly quick. Just let that warm up for a little bit. While that's kicking off. Cool. All right. Awesome. So here we go. I'm just going to authenticate to my blob storage account, use my current directory to get my training data, and then save that as my training data path, setting it as my setting my test data path as to my testing data set, which we'll use in our evaluate model. Setting the model path, I've kept this as a configuration setting. You can set a hard code value if you want, but I've just done this just to practice, because just in case once we deploy our functions and if there's a malicious user that gets access to it or an attacker that gets access to it, we don't really want them to know where our machine learning models are being stored, just in case they want to mess it up and try and do something malicious with it, which will cause negative results. And now we're just going to go into this train and save model. So essentially, I'm loading my training data set from this text file using the ML context. Now, just to recap, ML context allows us to perform all kinds of operations. So in this instance, we're just loading our training data set. So now we're going to train our pipeline. So I'm copying columns using the fair amount and then using that label for my predictions. I'm applying some one-hot encoding to my vendor ID, rate code, and payment type. Then I'm just concatenating the features to perform my predictions. And then we're just applying that pipeline that we've defined onto the data view here. So we're taking this iData view that we've loaded our file, our training file into, and then fitting the pipeline onto there. Hopefully that won't take too long. That's the problem with live demos. It always works really nice and fast when you're practicing, and then you're always aware, okay, cool, awesome. All right, so now that we've trained our model, so we can evaluate its effectiveness. So let's step into this evaluate method that I've created. So essentially, I've created an evaluate method that will pass in through our ML context the model that we wish to evaluate, and then also the test file path to apply our test data onto the model that we've created. So again, we've loaded that into an iData view which we can apply our ML context operations on. We'll transform it, and then we can get some metrics by using this evaluate function that's applied to the regression class of the ML context. So we're putting in our predictions data frame into here, and then using label and score to evaluate its effectiveness. Now, let's continue. Cool. So in this example, I'm just using the R-squared value, just returning the R-squared value to evaluate the effectiveness of this model. But if we look inside the metrics object that we've got here, we can actually use a variety of different metrics to evaluate the effectiveness, such as the root mean squared error, the mean squared error, mean absolute error, loss functions. So if you really want to test the effectiveness of your machine learning models that you create in ML.NET, you've got a variety of different metrics to evaluate the effectiveness of your model. But for this example, we're just going to keep it nice and simple, just use the R-squared value and return that back. And then I've just got a very basic check. Obviously, for more sophisticated production applications, you'd want to really leverage the different types of metrics available to you to assess the effectiveness of your model. But here, if it's over 0.7, which it is, it's about 88% good fit, we can go into this model and then save this model using the ML context, and then upload it to Azure Blob Storage. Now, in preparation for this demo, I kind of prepared it earlier. If anyone's from the UK and watched that show Blue Pizza, they always, whenever they were doing demonstrations, they would say, here's one I've made earlier, just to save time. But that looks like it has passed. And cool. So So our model has been uploaded to our blob storage container, and we've saved it as model.zip. So I'm going to stop my timer function and head into the Azure portal. So I've got this very simple blob storage container with ML.NET models. And then hopefully there's our trained ML.NET model. So that's a very basic, very simple example of how we can use timer functions to train ML.NET models and then just upload them to a remote location. And with this, we should be able to get, there's our URI to our model. So we'll be using that to actually inject into our next Azure function, which is our serverless API. So let me just close down all of this in our model trainer and open up our API. Cool. So I've got my models, what we've had in our model trainer as well. You can have a common class for that if you wanted to be if you wanted just to separate those concerns out. For Cosmos DB, I've defined a insert object. So essentially it's our entire class. So you'll probably recognize these properties from our taxi trip class. This is in our taxi trip fare prediction class as well. I've also got an ID property here as well, because when you're inserting items into Cosmos DB, you need to specify an ID for that document, and we're going to be using the third SDK option. It's third version of the SDK in order to interact with Cosmos DB, and that's a requirement just to insert items in there. So I'm going to open up my startup class. I'm going to show you how to actually add your engine prediction pool. So here we're using the from URI method, like I said, to poll our remote location in Azure Blob Storage. So there's my URI. I've given my model a name, which is taxi trip model. And every time we use that in our different functions, we'll need to specify that's the model name that we wish to use. And this is the time period that will, this is the amount of time that it will poll this remote location here for changes in our model. Just for this example, I've kept it really, really basic, and I'm going to poll that every minute. This might be a little aggressive for an API, as particularly in a batch processing example. If you're doing some real-time stuff, you might need to be even more aggressive. The point that I'm trying to make is this is really configurable, and we can use this to, we can actually change this up depending on our requirements. Now, if I open up my predict taxi fare function, essentially what I'm doing here is I'm using constructor injection to inject my prediction engine pool and make it available to this function. So this will be a simple post request that I'll make to this endpoint, predict taxi fare, and I'll pass in through the body of our request as a string, and then deserialize my object using taxi trip from our request body. So essentially what I'll be passing through is this taxi trip model, and then using that to create our taxi trip insert object. When we make a prediction, we'll be using our prediction engine pool to create this taxi trip fare predict. What I'm doing is I'm passing through the model name that we defined here in our startup class. And then for an example, so actually the taxi trip object that we actually want to make the prediction on. So I'm using this input, which is of a trip type, and passing that through to make our prediction. Once we've made our prediction, I'm going to insert that into our Cosmos DB database using this taxi trip insert object. So this predicted fare amount will be the predicted value of our fare of our taxi trip. And then just coming through here, we'll create a new item with our inserted prediction into our Cosmos DB account. So let me add some breakpoints here, just so we can step through this a line at a time and not go too quickly. Cool. All right. So what I'm going to do is set my API up as my startup project. And we'll start that. What I'm going to be doing once this is started up and once I've got my endpoint available, I have got Postman, which I'm just going to pass post a JSON payload through to this endpoint here. So here we are in Postman. So there's the endpoint to my predict taxi fare API. I'm creating a post method here. I'm passing through a vendor ID, the rate code, how many passengers we're taking on this trip, how long the trip took, how long in distance it was, how they paid for it, and how much they actually paid for it. So I'll send that request. And come back here. So I'm going to read through that payload into a string, and then I'm going to deserialize our request body into this taxi trip object. So if we have a look at our input, we can see that it's been deserialized correctly. And now we're going to make a prediction on our input using our taxi trip model that we've trained earlier. Give it a little bit of time to think. Awesome. So now that we've made our prediction, we've got our taxi trip insert object with all the properties that we use to predict our model and also our predicted fare amount as well. So continue there, and we'll just now we've got this taxi trip inserted object that we're going to insert into our Azure Cosmos DB container. And then hopefully that doesn't take too long. Looks like it all passed. Did we get 200? Yes, we did. Fantastic. Don't worry about the time. We just stepped through the code just to show you. So if we go back into my Azure portal, what I'll do is I've already set this up beforehand. Go into my data explorer, and hopefully we should see our new prediction that we've made. Awesome. So I tested it earlier. There we are. So there's a really simple and basic example of how we can actually use ML.NET models within Azure Functions, make predictions on JSON payloads that we send to it, and then persist that predictions into Azure Cosmos DB. So something really basic and really something straightforward that we can use ML.NET models for. Now, if I go back to my presentation. Cool. Just before we kind of wrap this up, and this is a really, really basic example. So all we did was inject a model that we trained using ML.NET as a URL into an HTTP trigger. But the power behind dependency injection within Azure Functions, we can use this workflow in a variety of different serverless scenarios. And a little bit of experience with Azure Functions might think, well, this is a very basic example. You're using the consumption model. You're using the consumption model here. That there's other considerations that you need to think about. So do we want to really have our API suffering from cold starts and all that kind of stuff? That's true. And that is a whole other conversation within itself. But hopefully this talk has inspired you to try and build some really, really cool applications using ML.NET and Azure Functions. And the flexibility and the power behind Azure Functions as a framework, you can build all types of interesting and cool scenarios using ML.NET. If you want to learn more, I'd highly recommend checking out the ML.NET documentation that the team have provided. And also they've got some really, really cool GitHub samples if you're more hands-on, you want to scan through some code and have a play around with this. In terms of this presentation, I do have the code on my GitHub. which I'll post on my Twitter, or I'll post it on the Slack channel as well, along with the slides for this presentation as well. So that was a quick 30 minutes. I might have rushed through a little bit of it, but thank you for listening. That's all I have for you today. I hope you've got lots of questions. If you don't want to ask questions now, or if you have questions later, I've added my Twitter handle to this slide. I've also added my LinkedIn as well. I'm fairly responsive on those platforms. So if you do have any questions for me, feel free to reach out.
Awesome. Well, thank you very much. That was a very inspiring talk. It was really nice hearing kind of the use cases and how we can use MLNET in a serverless way here. You got some great feedback here on the chat, and I guess one question we're going to start with directly is, you said that you're going to post the GitHub links on Twitter, right?
Yeah, on Twitter, and also there's a general Slack channel as well for this, right?
Yes,
for
exactly.
the whole conference.
Yep.
Awesome. Yeah. This is, again, like I said, this is in a blog post I did months ago. So it was one of those lucky instances where I've actually created the application well ahead of time. So I'll share that link and make it available for people to have a play around and maybe improve. You know, that'd be cool to see if someone could actually. This is a very simple batch processing scenario. One of the powerful things about ML.NET is, say if instead of Cosmos DB you were saving it to a SQL database, instead of loading it from your data from text files, you could actually load it from a SQL database. Or if you keep Cosmos DB in the equation, you can actually load it your data as an IEnumerable, and then actually load that back up to use as more users use your applications and more data is being added, you can use essentially the same data source to train and improve your models as well.
That's great. Another question we have here is, if you set up feedback, how do you use Azure Functions app to train the model?
If you set up feedback?
Yeah, I think the question is about how do you use like Azure Functions to continuously retrain your model if you get more and more data? I guess that's the question.
Well, in this example, I'm using a timer function, and timer functions essentially, let me actually, do you mind if I reshare?
Oh yeah,
I'm still sharing. So
you're still sharing?
Awesome, cool. No, sorry, I was looking at the Skype. So let me just stop that. Essentially, timer functions can get kicked off by they're essentially cron jobs. So what you do is you specify a time. I'm just trying to remember, because it's not a cron job, it's ncrob job. So there's like a specific saying in Azure Functions. So this is just a basic example. I'm actually kicking this off every 5 seconds. But you can actually specify this as a time. So say if you want to train your data at 12 o'clock or at midnight every night, you can specify that within your timer function, and every night it would kick it off. That'd be good for a batch training scenario. For real-time stuff, that would be a little bit more challenging, I think. And I confess I don't have that's not something I've had too much experience with. But yeah, in this example, we're just using a timer function to specify a time to start training our model.
Cool. Another question we have on the chat here is, any clue to the cost of training the model in Azure Functions? Have you done any real business cases with this setup?
No, so this was just like a cool sample that I've just created one day, just randomly. In terms of financial costs, not particularly, but in terms of performance, this is not something I would push to production. Not this example verbatim. There's obviously there's a whole topic around hosting options for Azure Functions, and it also is very dependent on your environment as well, and the context of your business environment as well. So while today this was just a very simplistic scenario, to push, there are more more factors to consider when the production.
That's great. Well, thank you for the answer. And I think that is all the questions in the chat, I think, at least so far. Well, Will, thank you very much for calling in from all the way from New Zealand to this conference and sharing your expertise in this area. It was very inspiring to hear, and I think the audience definitely appreciated that.
Well, thank you so much, not just for letting me speak at this session, but for running this whole thing. It's incredibly challenging, the current world situation right now, and I'm not sure how it's all going to end up, but it's nice to know that through the power of virtual conferences, we can still connect with each other, we can still share ideas and present to people all around the world. And I just really, on behalf of everybody, just thank you so much for taking the time out to organize this, because even though I've never organized conferences myself, they're expensive and time-consuming beasts. So I'm really grateful to you for running this event. It's been fantastic.
I appreciate those kind words, Will. We have had a blast doing it. Thank you very much. And we're actually going to loop in Bree and Louise and John here as well and wrap this conference up. But thank you, Will, so much for doing this.
Well, again, thanks for having me. All the best.
Bye-bye.
Bye.
All right, we'll see if we have Bree and Louise here on the line, I think. Yes, here we go. All right, well, welcome back, Bree and Louise, as well from yesterday. You've been in the background, but I wanted to make sure we bring you back at the last scene here.
Yeah, thanks for having us.
How was today?
It's been amazing, I think. It's been great. I mean, so many good talks. We've been streaming for almost 10 hours now. I am tired, but I am so inspired and full with just happiness about the great community we have across the world, right?
Yeah, definitely. I've been watching all day as well, and everyone did so great, and lots of really good questions from the crowd. It's really exciting to see what people are doing with this, and are really excited to use it. So.
I want to bring in Louise here. Louise, you have to show off your shirt here because you got it last night, right?
Finally got it.
Finally.
Part of the crew.
Awesome. This is the uniform now.
Yep.
Good. Well, one thing to kind of mention as well is that the Slack is going to stay open. We are not closing down the Slack workspace. So stay in the Slack, connect with each other, think of good open source tools and startups, whatever you want to do, or just ask questions. We're all here to communicate and connect, and I definitely want to have that and see this community grow. Both me and John are hoping that we will be able to do this again soon. I know at least that we are planning on doing some kind of MLNET hackathon, right, John?
Yeah, early stages of planning that right now. I think we're going to try to get something announced fairly soon, or at least try to.
It's out there already. It's in the universe, so it's manifested itself.
Happen now.
Exactly. We said it has to happen. We're gonna do it, but I think we all need a little rest first, and then definitely do that. But one thing I want to point out as well, if you want to hear more about MLNET, definitely follow these amazing speakers from all across the world to do so. Also, definitely follow John. He's on YouTube. He's produced tons of good videos on his topic, and he's definitely a really good source of information. Luis has fantastic blogs. I know that myself, and I follow along on those. He can definitely share those information, and he also streams on Twitch. I think LQ Dev, right, Luis?
Yeah, LQ Dev 1 for Twitch streams.
Yeah, definitely. And myself, I stream every Tuesday and Saturday on Alex Slotte on Twitch. So if you want to tune in and work on some open source tools with me and learn MLNET, definitely do so. And Bree, I know you're always available for feedback as well, right?
I am. Please reach out to me anytime. You also can leave any feedback on the GitHub or just directly to me. I would love to hear it all. Or if you just want to tell me what you've been working on with ML.NET, that would also be awesome. So.
Yes.
And awesome. We want to thank Malibu also for her encouragement and support and all the things she's done.
Yeah, she napped a little bit today through it all, but she was mostly there for us. So she's excited too.
That is just awesome. Well, that's super nice, guys. Well, we will make sure to put all the recordings up from today on our YouTube channel. We'll make sure to put up the workshop there as well in the next few days and send you an email with all the links to remind you they're there. But please spread the word about MLNET and the conference so we can have an even bigger crowd next time and more awesome and fantastic talks. We're looking forward to it. Any parting words, Bree and Louise, John?
Just thank you all so much. I mean, thank you to Alexander, John, and Louise. This was incredible that we were able to, a 4-person team, put this all together. Thank you, everyone that was watching. And I'm, again, just really excited to see what's coming.
Awesome. Well, thank you for this event, everyone. We have been happy to have you, and we're looking forward to seeing you next time. Have a great time, guys. Thank you.
Yeah, thanks, guys.
Thanks. Bye, guys.